Good morning. Welcome, everyone, to the 2025 ML and Blockchain Research Summit. I am Bhaskar Krishnamachari. I'm a professor of electrical and computer engineering at USC. I'm also a consulting advisor to the AI and automation team at Coinbase. We have an exciting program for you today. Let's go over it. So this is the third in a series that we began in 2023. It's a forum where we get to hear thought leaders from across academia and industry. These are experts in their relative fields who will share their research, their insights from practice, all at the intersection of blockchain and AI/ML. We have today, as I said, a very exciting program. We're going to start with a fireside chat with Tim Draper, who's one of the OGs in crypto, as well as an investor in many emerging AI startups. We will have 9 speakers from academia and industry, as well as 2 exciting panels. This is an event with a lot of interest. We had more than 600 registrations. We have people spanning, again, academia, industry. We have Web3 and AI enthusiasts, and I think literally from all over the world. So let me kind of set the stage a little bit for our program today and talk about the general theme of this event. So we're looking at AI, and here, really we're going to use AI and ML interchangeably. AI is all about endowing our machines with intelligence to be able to do all kinds of tasks for us. And machine learning is the most dominant methodology we have today for enabling these AI systems. And the other major technology, of course, that Coinbase has been involved with is blockchain. And today we're starting to see a convergence of these 2 emerging technologies, and today's event is all about that. So let's think about, what are some questions we can ask about these 2? And I kind of frame it as 2 complementary questions, right? So the first question is, what is it that AI is going to do for the world of blockchain? And the other side of that coin would be, what can blockchain do for AI? So let's kind of consider these 2 questions, think about some of the ways in which we might see them, these 2 technologies intersect in either direction. So starting first with what AI can do for blockchain, you can imagine using AI techniques and ML methods to build all kinds of autonomous software that are going to be off-chain themselves, but very intelligently interacting with the on-chain systems and protocols. An example of that might be a bot that is doing some trading on a DeFi platform. The intelligence in this case is in the client that is off-chain, but interacting with an on-chain, for example, decentralized exchange to make trading decisions. Another example where we might see AI being used to kind of connect with blockchain is to deploy some of that intelligence on-chain in the form of smart contracts. These might be ML models that are deployed on-chain. They may be interacting with users and the market in ways that make a lot of sense. We may also see AI used to reduce vulnerabilities and bugs in our smart contracts, make sure that they're error-free, that they're keeping users' accounts and funds safe at all times. The other direction that we definitely see AI growing in the context of blockchain is to help facilitate blockchain development. We're going to be hearing today from, for example, Michele Catasta at Replit talking about how AI tools are being used to make it easier for people to develop complex software. And last but not the least, we can imagine AI being used for detecting fraud and malicious behavior on chain and improving the ecosystem for everyone involved. Again, as a concrete example, the Coinbase AI team has a research paper that shows how graph embeddings can be used to identify fraudulent and malicious addresses on the Ethereum blockchain, and this is appearing at the IEEE ICBC event next month. On the other side of the coin, we think about what blockchain can do for AI. We've got the ability of blockchain-based systems to help maintain the integrity of data that is used for training AI models, and then the models themselves. Make sure that they're not tampered with, prevent sort of adversarial attacks on the data, sometimes referred to as data poisoning attacks. We could see blockchain help to prove and assert ownership of digital assets that are AI related. You might imagine the output of a generative AI solution that is a digital asset that someone would want to tokenize and be able to share and maybe even sell on chain. But you can also imagine potentially tokenizing the prompts that go into generating specific outputs. We could see blockchain play a role in the economics of AI, enabling marketplaces for data that developers of AI models looking for data can go to in order to find relevant training data for their uses. We can imagine marketplaces also for model and computation as we see that our larger models need a lot of computations. Being able to decentralize that, being able to access them through a distributed marketplace can be very helpful, and blockchain can help do that. And last but not the least, blockchain can really enable our AI models to be deployed in a trustworthy manner so that we know exactly what model we're interacting with. It hasn't been tampered with. It's doing all the right things that it's supposed to, maintaining relevant kind of standards for transparency and auditability. So with this sort of level set, hopefully we're all on the same page about the emerging themes that this conference and summit is going to be about. One kind of indication for how timely this event is, and indeed, the last two events we've had have also been, is the growth in research in this kind of joint space. So this is a search that I did for the keywords machine learning and blockchain on Semantic Scholar, and we can see just in the last 10 years that the number of papers that are out there at the intersection of these topics started maybe 10 years ago, less than 24 papers. And today we have probably close to 1,500 papers. And it's growing, as you can see, close to exponentially. And it's something that clearly has captured the imagination of the research community. So let's look at the program that we have today in a little bit of detail. So we're going to start out with a very exciting fireside chat. Tim Draper, who's very well known in this space, and looking at kind of his vision for the future as these technologies come together. He's going to be in conversation with Rajarshi Gupta, who's going to ask him some of these questions about, how do these two technologies come together? So we'll start with this fireside chat and hopefully give us kind of the big picture view of both where we are today and where we're headed in this space. Next up, we're going to have Michele Catasta from Replit, and he's going to be talking about their infrastructure that they're building to be able to empower software creators using LLM technology so that both technical and non-technical users can produce software that's meaningful and relevant for their use cases. And as we mentioned, this could be, for example, helping develop the software for blockchain systems. After that, we will have a talk by Professor Raluca Adapopa from UC Berkeley. She will be telling us about privacy-preserving AI compute with decentralized verification. She's going to be telling us about secure inference, trusted execution environments, the use of secure RAG retrieval mechanisms for LLMs, and more. Following that, we'll have a talk by Professor Salil Kanhere from the University of New South Wales. He'll tell us about decentralized identity management, in particular in the context of a system that they developed, a protocol at UNSW, which has to do, it's called CredChain, it has to do with verifiable credentials. Christoph Niemann from AWS will follow up with a talk about the rise of autonomous commerce, and he'll show us how Amazon Bedrock can be used to create Web3 agents that interact intelligently with the crypto world. After that, we'll have our first panel for the day. This is a panel on that first question of AI for blockchain. What can AI do for blockchain? And this will be moderated by Anand Iyer, and he'll be in conversation with Ashish Goel and Christoph Niemann and Gilad Bookman. And they'll be discussing all the ways in which, as we just talked about, AI is going to be playing a role in the blockchain ecosystem. And as we can see, we're going to get both an academic and industry perspective on this rich topic. The panel will be for about an hour, and after that, we will have the rest of the program continue. We have Eric Reppel from Coinbase will be telling us about the agentic internet, how we can compose different agentic elements and create a new internet, and what role crypto is going to be playing in that transition. Ilya Polusukin, who is very well known as a co-author of the Attention is All You Need paper and a co-founder of the NEAR protocol, will be telling us about the roadmap to a user-owned AI model, his vision for an AI ecosystem where users can really own their own data, and the focus is on the well-being of users rather than corporate profits. And I think that's something we all would appreciate hearing more about. Xiang Ren, who's a professor at USC and also a co-founder of Sahara AI, is going to follow up with a talk about how some of the APIs for LLMs today actually unintentionally reveal details of the model. And it's a bit of a paradox in that clearly there may be some security concerns around it, but at the same time, it's also an opportunity potentially to improve transparency and auditability of the LLM models. And hopefully we'll get to see how that also connects with the blockchain ecosystem. In the following session, we'll have our second panel of the day, which will be the other side of that coin, blockchain for AI. And this will be moderated by Yuga Kohn. And he'll be in conversation with Professor Ling Liu from Georgia Tech and Dylan Zhang from Pond, as well as Jan Liphart from Miston Labs. After that second panel, we have Professor Ashish Goel from Stanford, who'll be telling us about decentralized exchanges and some of the algorithmic aspects around that, including constant function market makers and batch exchanges. Our last speaker of the day will be Jasper Zhang, who will tell us about how to lower barriers for building software now that we're in this age of open source AI, what verifiable systems will have to do with it, as well as how to scale up compute. And then we'll wrap up with concluding remarks by Rajarshi Gupta, who's at Coinbase. So just again, at a glance, we've got a rich program. We've got, after the Fireside chat, we have 4 speakers from both academia and industry, followed by a panel at 11:45 on AI for blockchain. And then the second half of the day, we have another 3 speakers, then our second panel of the day on blockchain for AI, and a couple more speakers after that before we wrap up. So a really exciting program, a lot to look forward to. So without much further ado, let me get us started on our first event of the day, which is a fireside chat with Tim Draper, conducted by Rajarshi Gupta.
Hello, everyone, and welcome again to the 2025 Machine Learning and Blockchain Summit. I'm Rajarshi Gupta, and I lead AI and automation at Coinbase. It is my privilege today to welcome Tim Draper to be the keynote speaker for the summit. We'll be having a wide-ranging fireside chat on AI and crypto and their interactions. Now, Tim Draper founded Draper Associates, DFG, and the Draper Venture Network. During his career, he has backed major companies like Tesla, SpaceX, Coinbase, and Skype from their very early stages. He's also a leading advocate for Bitcoin and decentralization, having won numerous accolades within the crypto ecosystem. He's in fact also invested in over 50 crypto startups, including Ledger and Tezos. Tim is a prominent voice supporting entrepreneurs and innovative governance worldwide. Now, needless to say, he has received various awards and honors, and I'll mention just 2. That includes the World Entrepreneurship Forum's Entrepreneur of the World, and he's also listed as one of the top 100 most powerful people in finance by Worth Magazine. With that, let me welcome Tim to the stage.
Thank you, Rajarshi. This is great to be on your show. And we were investors in Coinbase. My son was the first seed investor in Coinbase, and we're big fans of everything that you do. It's a wonderful company, and it's been really exciting to see what Coinbase has accomplished over these years. So
that's
I'm
great.
so honored to be here and so happy to be here. And I'm wearing my Bitcoin tie in everybody's honor here.
Thank you so much. It's a real pleasure. So let me get right on to it. And you have had a very storied career. So I wanted to start by asking, what was your light bulb moment that first sparked your interest in crypto? And then I'll repeat the same question for AI. I actually don't know whether your interest started with crypto or started with AI.
Actually, we were investors in AI long before there were LLMs. And in fact, we backed this company, I think it's called C2B, that did an AI. And what they had done was they got all the data from 7-Eleven, the convenience store. And with all that data, they said, okay, now we're going to run the neural network on this, and we're going to come up with whatever information it comes up with. And it came up with beer and diapers. And it turns out that beer and diapers are often bought together. And to this day, you go into a 7-Eleven, the beer is next to the diapers because of that. And that was many, many years ago. That was 20 years ago. So, and I remember studying AI and expert systems when I was at Stanford. So, and I'm old, so it was a long time ago. The way I got involved with, and I'll tell you more about AI in a bit, the way I got involved in Bitcoin was this. In 2005, I met a man from Korea, and he was an extraordinary guy. And he said, hey, half of Korea is playing this game called Legends or Legacy or something like that. And I said, well, that's great. He said, yeah, it's massively multiplayer. And I thought, okay, that's great. And then he said, it's half of Korea. And then I said, yeah, great. And then he goes, and I bought his son a sword for his birthday. And I thought, what? It was a total non sequitur. And I said, what do you mean? And he said, oh, no, it's not a sword. It's pixels on the screen. It is a digital sword that we were buying for real fiat money. And I started to think about, real sword, fiat money. And then I started to think digital money, a digital identity, a digital life. And he was basically living this digital life because he hired a guy, he was very wealthy. He hired a guy to be his avatar, to play the game while he was at work. So he would get more inventory or bigger, whatever. And I realized then that we were going to have a world that's IRL in real life, and then we were going to have one that was virtual. And so I got very interested in digital money, and I thought it was going to happen between gamers. So like you'd have Farmville, and it would you'd translate some Farmville gold to Zork diamonds or whatever, and there'd be like a currency a series of currencies that would all kind of work together. So that's how I thought digital money was going to happen. But then Bitcoin showed up. My partner at the time, Joel Yarman, introduced me to Peter Vassen, who ran CoinLab, and we invested in CoinLab. And then I said, okay, well, I'd like to buy some Bitcoin, and I bought 250,000 Bitcoin for $4, $250,000 worth of Bitcoin for $4 each. And I thought, okay, that was done. But it turned out that he had to go mine that Bitcoin, and he had to get these new chips that would help him mine the Bitcoin faster in order to get it for me.
Right.
And so it was a very complicated thing. And by the time I got the Bitcoin price had already gone to $32. But after that, he stored it all at Mt. Gox, which was the biggest exchange
at the time. Yes.
At the time. And they were also custodying Bitcoin. Anyway, they disappeared the money. I don't know how all that happened. I didn't really dig in. But what I did dig into was that Bitcoin didn't disappear on that news that $400 million worth of Bitcoin it just
Right.
disappeared. Instead, the price of Bitcoin dropped about 15%, and then it was straight up after that. And I thought, wow, people really want this. And I did some deep research, and it turned out it wasn't just, guns and drugs. It was people sending remittances overseas. It was businesses who had to pay employees who were remote and didn't have bank accounts. It was people who lived in countries where there were no banks, starting to create their own economic systems. And I realized this was really going to be important. And at one point I met Sebastian Serrano, who runs Ripio, and he was just getting it started. And he said, yeah, I live in Argentina. And I said, okay. He said, yeah, my family created a fortune 3 times during my life. And each time we lost that fortune to bad currency manipulation,
right.
Hyperinflation. And I said, whoa. And he said, yeah, 3 times. And I'm only 30 years old. So it's like every decade we have currency wipeout. And so he said, Bitcoin is going to save our family. We're going to build a fortune, and we're going to keep that fortune. And he was very excited about it. And I thought, okay, that's another great use. There are countries with really bad fiat currencies. And so now I got more and more interested. I started to buy Bitcoin again, even though I'd sort of lost the Mt. Gox Bitcoin. And then the U.S. Marshal's Office had a big auction, and the market price was $618 on the Bitcoin. And I thought, well, I'll bid on this. This will be fun. And there were 9 lots, each one at about, I forget, let's see, must have been 2,000 Bitcoin each or something. And maybe 2,000 or 3,000 Bitcoin each. Okay. And I thought, well, all my friends who were involved in Bitcoin at the time, no other venture capitalists, by the way. It was.
This is a very well-known story.
I was the first venture capitalist to buy Bitcoin. And so then I thought, okay, well, I'll just bid on all 9 lots, and I'll go above market. I'll bid 628 or something, 632. And so I bid 632, and I thought, I'm sure I'll get 1 or 2 of these lots. And that was about what I was comfortable with, financially comfortable with. Well, I got all 9 lots. And I went, oh, what? When you win an auction, that means you're paying the highest price anybody will pay.
Right.
Anyway, I bought them all, and we had to wait about an hour for all the blocks to line up so that we actually had credit. So I was on the phone with the U.S. Marshal's Office for over an hour, actually, while the transfer was happening. And so I felt like, okay, so I got it. And immediately Bitcoin dropped it went up to 633, and then it dropped straight to $180. And at that point I thought, I still believe in this. I don't quite understand why it's dropping in price. And I had started a school for entrepreneurs at that time. Mm-hmm. I didn't know, I didn't really have a budget to pay them to come in and speak to my students, to pay these speakers. And so we had Tony Hsieh, who was the guy who started Zappos, and we had all these extraordinary entrepreneurs come in and talk about what they did. And so $180 of Bitcoin. I gave them those coins, the Cascacious coins, to go speak. And
if they held on to it,
and they got their coin and they left, and nothing happened really for a long time. And then over the course of the last, 3 or 4 years, almost every one of them has come up to me and said, I ripped my entire house apart to find that damn coin. And they've some of them, most of them found it, because now those coins are worth maybe $150,000 on eBay. I mean,
right.
It's much more than a
this is fascinating, right? I mean, some of the stories that you mentioned, it's known that you bought these lots from the Mt. Gox auction and so on. But it is such incredible, like hearing it from the horse's mouth, saying how this thing really went down. So thank you. That's wonderful.
Yeah, and I'm just glad that it all worked out, because if my wife had known I had taken like more than our nest egg and put it all into this
Bitcoins,
before it went up, she probably wouldn't have been very happy with me.
Yeah.
Anyway, we're very pleased at how it's all worked out. And I think I always invest in the new technologies, because eventually over time, the new technologies overtake the old ones. The car overtook the horse.
Mm-hmm.
Electricity overtook the horse. People who would grind things up. The computer overtook a lot of the menial labor that we had before. And now, of course, AI, and you wanted to get into AI. AI is transforming a lot of our lives. I just heard of a new app that's a cheat app, and it helps people when they're going through interviews to answer questions well, and it helps people who are on dates answer questions well.
Oh, that's really cool.
Pass tests by, and they call it cheating, but I forget what it was called. Anyway, I think AI, and it's like it takes a while for our values to catch up to the technology. Because at first we're saying, oh, wait, you can't use AI for school. It would be, stealing or cheating or libel
for example, one of the things we are seeing is, of course, you worry about candidates using AI in their interviews. But what we are trying to move towards is saying, you know what, in real life, you will be using AI in your work. So it's not that we actually want you to cheat. We want you
to use AI. So you would more likely hire the person who was using AI to nail the interview than the one who wasn't.
Absolutely.
So I think people say, my son says, AI is going to take all our jobs. And it's a great way to look at the world, because if AI takes your job, that means you have to reinvent your job. So I think that makes a big difference. I think we all have to reinvent our jobs and bring AI into those jobs so that we continue to innovate and we still drive forward. And so and people think, self-driving cars, and, maybe we'll get robots to clean our houses or whatever, but they never think in terms of AI, like taking over the accountant's job or taking over the lawyer's job or whatever. I am looking at it and saying it's going to take every job. So I look at venture capital and I say, I've got to get out in front of this. And so we've been using AI. I mean, now I created my first expert system in venture capital 20 years ago. And now that LLMs are out there, the neural networks, I can apply my expert systems to the LLM and keep improving it.
Correct. It's much
so
easier.
Now we have this huge data lake of 250,000 startups, and it spews out 5 that it recommends each week. And those 5, then I say, this is not good because it's a race to the bottom. This is not good because it's a feature. This is not good because it's something else. And then I say, I like this one. And so then the AI kind of goes, oh, he likes things that, and then it'll look through and figure out what it is. Sometimes I don't even know why I like it. But the AI can figure out some of the things that I don't even know. So I'm very excited about that. We use it for diligence when we find a company. We run full diligence through AI on the people, the company, the competition. We then, when we invest, I have 4 or 5 digital twins. They are used for a whole bunch of different things, for PR for the company. We use Otter to record all the conversations we have with entrepreneurs. And then Otter creates this AI that says, hey, you met with this guy 6 months ago. He said he was going to do 10 million in revenues. Has he done 10 million? You know, then we use AI for, there's a company called Seer that we backed that can detect emotion and lies. And so we can run a video through Seer and detect what the entrepreneur was thinking a little bit.
I see.
And then we have another AI that can detect voice. So we're looking, we're innovating, we're analyzing in a whole bunch of new ways. It is more exciting to be a venture capitalist now than ever because of all the AI I've done.
Yep. I mean,
and then now we're supposed to talk about how they come together. But anyway,
yeah. So actually, let me ask that. Let me ask the harder question first, right? Like, how do you see crypto helping AI? So, I mean, I'm thinking of examples like crypto enabling AI agents with crypto wallets, or using things like, using the blockchain to verify the trust and the security of LLMs. I mean, what are your ideas on how crypto can help the AI world evolve even faster?
So both are decentralized. So here's what AI is, has all of the knowledge captured throughout all the years that the internet's been in business. And that's 6 billion of the 8 billion people have in some way contributed to that internet knowledge. And that knowledge, so when you have an LLM, you are capturing the knowledge of those 6 billion people. It's a very decentralized source of knowledge. Bitcoin is a decentralized currency that is transparent and open and global, and very much the way AI is decentralized and open and global and accessible by everybody. And where Bitcoin keeps perfect records on the blockchain, AI can use Bitcoin or the blockchain to keep perfect records of what are considered facts at a given time. So I think that's kind of one way for us to think about it. Another way is that I think AI is going to help people think about their money.
Right.
Right now, people are starting to use it for everything from diversification to estate planning to whatever. And I tell people, hey, you should, whether you're a company or a family or a government, you should have a certain portion of your money in Bitcoin. And the reasons are obvious, but to make them clear, Silicon Valley Bank went out of business. I got about 15 calls from entrepreneurs saying all our money's in Silicon Valley Bank and we can't make payroll on Monday. And that was Thursday. And I had to scramble to make offers to those people to get them money for their payroll, because the CEO and the board are personally liable for payroll.
I remember very much. I remember very well. We were was at Coinbase.
And so it's pretty clear that corporations should not just have money in banks, probably some in big banks and some in small banks, because U.S. government can bail out a small bank. They can't bail out a big bank. And then some in Bitcoin, because if there is the domino effect that they were talking about when Silicon Valley Bank went under, you're going to need another kind of currency to hold. But that's also true of a family. Anybody who wants to take care of their family has to hold some Bitcoin, because they should have, 6 months worth of Bitcoin in their family budget, because if the banks go out, you're going to really need to take care of that family. And then governments are now recognizing that they've got to make it a part of their treasury. And so corporates need to do it, individuals need to do it, and I know you guys have some, so good thing.
Yes, of course.
So people are using AI to plan their finances, and so that means figuring out how to properly diversify, to own, crypto, fiat, stocks, bonds, whatever. That all is becoming more automated. And not only that, but AI has gotten to be, there's some that have gotten to be advisors. So they say, well, let me understand your financials. So you tell AI all about your financials, and the AI says, oh, well, you're very heavy in this and this, and you're very light here in this. Is there a reason for that, or something we should look at? Maybe you should make some changes. So that's starting to happen. AI is figuring out how to, for estate planning, how to best handle passing money on to, and that's true for Bitcoin too, passing money on to family. Right. And then AI is doing something really interesting, because Bitcoin's now people are driving smart contracts on Bitcoin. So we could cut a deal and we could write it all into software on a smart contract. And let's say the deal is just like a bet on the Warriors game. I bet for them, you bet against them. The winner gets the money. A very simple, that's a contract. We can build that into software on a smart contract. Well, you take that a lot further, and all contracts could be driven by Bitcoin and through Bitcoin and AI. And so here's what I've learned. There is an entrepreneur who came to me and said, hey, we can create the entire argument for the defense of any litigation. And we can do a better job through AI than the lawyers can do. And I said, okay, that's great. And I said, well, can you also do an equally good job for the prosecution? And they said, yeah, we can do an equally good job for the prosecution. And then I said, can you figure out a settlement between the two? And when he heard that, he said, oh my God, I've got to do that. He said, but we got to do this first. So eventually, not only will the contracts be built into software, and so we'll have fewer disputes, but when we have a dispute, all previous court cases, all that stuff will all come to fruition in a settlement. So I actually think that when I do a deal with an entrepreneur, one of the terms will be that the first line of defense will be an AI settlement. Then it'll go to arbitration, and then it'll go to court.
Yeah, that's an incredibly good idea. We've obviously started seeing these AI lawyers come into vogue, but the idea of using like two AI avatars to come to a settlement might benefit everyone enormously.
Oh yeah, I think we're going to save. The great thing about AI and Bitcoin, well, Bitcoin, everybody will be wealthier, because just the same way everybody got wealthier when people went from shells to gold, and gold to the promise of gold, and promise of gold to credit. Each time there was the world got richer, because we all were able to make deals with each other. And that amazing quilt that's been built called the economy patches us all together, and Now I can say I need a toothbrush, and within 4 hours, Jeff Bezos delivers a toothbrush to my door.
Actually, let me ask a different question on a slightly broader topic. Of course, you mentioned a couple of times that it's a great time to be a venture capitalist. What's the major advice and guidance you give to all the people who are trying to build in crypto, build in AI? Like, what should their Northern Star be?
Well, if they're building in crypto, I recommend that they build for Bitcoin. And the reasons for that are many, except that there's a gravitational pull toward Bitcoin now. Bitcoin used to be about a 40% market share in the first boom and bust. And then the next one, they were about a 50% market share. And now they're about 61%. Actually, I think it's even gone up from there. So all of these other tokens are a great sandbox, and great things have been created on them, but they're all getting ported to Bitcoin. And when they're ported to Bitcoin, the other token will be less relevant. And that same thing happened with Microsoft. Microsoft was the software operating system, and everybody built on the operating system. And they said, we're just going to be the operating system. You guys go innovate, do whatever you want. So then Lotus 1-2-3 created a spreadsheet, and it got to be a big deal. And Microsoft looked and said, that's a big deal. So we're going to incorporate Excel into our operating system. And Lotus 1-2-3 went away. And then the same thing happened with WordPerfect. It was this enormous success, huge word processor on the operating system of Microsoft, everything. And Microsoft then said, that's doing very well. Let's do Word. And so Microsoft did Word, made it a part of the operating system, and WordPerfect went away. Microsoft then bought PowerPoint, and they incorporated it into their operating system. And then eventually they saw games take off, and they were a little bit too slow to get the games. And eventually they created the Xbox and moved from there. But it became that standard place that everybody went to. And then so for individuals, you kind of went there because it was easier. For corporations, you always went there because you didn't want to get fired. And so I think the same thing's happening with Bitcoin. You're seeing corporations starting to bring Bitcoin into their treasury. You're seeing governments making Bitcoin a part of their national treasury. You're seeing individuals holding Bitcoin, knowing that, hey, maybe things will may go against the dollar, and they have. I mean, if you've held Bitcoin all this time, your dollars, by comparison, have not done very well, and they probably will continue not to do well against Bitcoin. To wrap it up, I think it's really fun having these two waves collide, where Bitcoin, which is where all the gravitation is coming, and AI are sort of coming together in a big way, in a lot of ways, where you're going to use the blockchain and smart contracts. They're going to be a part of the zeitgeist, I guess. They're going to be a part of this incredible ecosystem, and I think the world will become much, much richer for it. I think they're all going to be. We are all going to be so much better off because of AI and Bitcoin. And you hear that today, and you think, oh God, that's Draper. He's probably investing in a bunch of AI companies, a bunch of Bitcoin companies. But we tend to have a window that's about 2 or 3 years before the public.
Right.
And that's the window I'm seeing.
No, that's fascinating. Tim, this is such a great opportunity to hear from you and hear this expansive view of how the world has evolved and how technology has evolved. And so this is just wonderful. I'm so glad that you could spend this time with us and share your knowledge and your experience and your wisdom with the audience here. So thank you once more again. This is a huge pleasure.
Terrific. Thank you so much for having me on your in your event. And yeah, go Coinbase. Way to go, baby. It's a great company.
Bye-bye.
Well, what a great fireside chat with Tim Draper. We really got to get his insights on this ecosystem. And as he talked about, it's really coming together. Clearly someone who's an optimist about the space. So next up, we're going to have a presentation by Michele Catasta from Replit. And he'll be telling us about how software creators are going to be empowered through LLM technology. I want to take this time also to let our audience members know that they are free to post any questions they may have for Michele in the chat window that you have. And you can even post questions while the talk is going on, and we'll be able to collect them and use them in the Q&A that follows.
Hi, I'm Michele Catasta, president of Replit. And today, I'm going to be talking about how we empower 1 billion software creators with Replit. But first of all, let me give you a bit what I've been doing in the past few years and why this has been my passion for almost a decade. So after I completed my PhD in machine learning, I joined Stanford in 2017, and my research agenda was already focused on applying AI to source code. And I caught the transformer wave very early, so I started to work on representation learning for code. That became a passion even further, so I joined Google in 2021, and in there I work on training very large models for code. And at that point, after spending a couple of years doing that, I realized that it was time for me to have product impact. So I joined Replit. I initially built the Replit AI team 0 to 1, and then just 7 months ago, we launched Replit Agent, which is going to be the focus of today's talk. So as I mentioned at the beginning, our company mission is to empower the next billion software creators. But how are we going to make this happen? I'm sure many of you listening to this talk had a chance in life to create software. And I'm quite certain your experience has not always been delightful. Creating software is hard for so many different reasons. You can have hardware problems. You have to set up your development environment. You need to understand the maze of version control and how to collaborate with colleagues and so forth. And clearly, that is by far one of the highest barriers of entry to software creation. But the truth is, we have been working as a field relentlessly in the past decades to make sure that everyone could become eventually a software creator. As of today, only 0.3% of the global population is actually capable of creating software. There is a big chasm between the software engineers, depending on how you define them. They maybe range between 30 to 50 million people in the world. And at the same time, how many people actually have internet access? And it's estimated to be more than 5 billion. So at Replit and myself, we strongly believe that this chasm can be filled very quickly in the next few years. Let's start from the very beginning. This quote from Bill Gates is at this point almost prophetical. In 1977, he said, there will be a computer on every desk and in every home. Today, it doesn't sound that counterintuitive. It actually happened. It's even in our pockets rather than in every home. Smartphones are so powerful that everyone pretty much owns one of them. But it took several decades to make this happen. And the key unlock has been the fact that the cost of compute has dropped so much that it made access to compute universal. So we went from mainframes that literally costed as much as a house, all the way to personal computers today that go for just a few $100s. So the shift that we experienced in just a few decades has been mainframes accessible only by experts, all the way to giving personal compute to everyone. I argue that the same is about to happen for software creation. And the unlock here is not in terms of the cost of compute dropping, but the fact that the cost of intelligence is dropping. And again, the access to it is going to become universal. So what you can see in this plot is the Pareto frontier drawn between how much an LLM costs and what is the score that is getting on a very famous benchmark, which is basically question and answer on advanced subjects. You will recognize on the bottom right some of the older models that have been around maybe for 12, 18 months. And on the top left, the Pareto frontier keeps moving, which means models are getting more powerful and are getting progressively cheaper, to the extent that the top reasoning models today have reached or surpassed human expert level across several subjects. So again, drawing from the analogy we did before, where compute became accessible to anyone, we started from software engineering, only available for experts, so these 30 to 50 million number of developers that I was mentioning before, to the vision that we have as a company, which is Replit is actually a product for everyone. Everyone will become a software creator thanks to that. And my thesis is that we're going to see this shift from personal compute to personal applications. So echoing Bill Gates' quote from 1977, what I expect is to see a personal app on every device, at home and at work. And I'll argue that since the past few months, this is progressively becoming more and more the case thanks to what we just launched. But I keep talking about what Replit does, and I can't take for granted that each one of you has tried it. So let me give a high level of what Replit Agent is. Our core mission has been to go from idea to app fast. That's what we want to enable our users to obtain. So in this case, what you see on the left, we have a simple chat interface. We type down in natural language what we want to build. The agent creates a plan for you and proposes it, and you as a user, you can decide if you want to move forward or not. Let's say we like the plan that has been proposed. We go to build, and agent puts us in front of a skeleton of the application right away, just in a few minutes. Let's say we like the output of the app, but we want to change the color of the pins into blues, and we just type it down in natural language. And there you go. The app is updated after a few minutes. Now the agent replies, asks you if you want to test it or not. We like the output. Now we got an additional idea. We would love to add an image of the landmark. And again, right away, we're adding images directly from the Wikipedia API. And you can imagine that you keep iterating on this application and make it as personalized as you want. And you can also deploy it in public so that you can give access to both friends and family, but also if you're creating something of value, you can start a business on top of it, which is what is already happening very often, especially in the last few months. So since we launched Replit Agent back in September 2024, more than 3 million apps have been built on it exclusively using the agent interface. So from people that have no coding background, they just express their intent in natural language, and the agent took care of building the entire application. What was the unlock here? As I hinted at that before, intelligence and the fact that it's becoming so widely available and progressively stronger was the real unlock. So you might have heard this quote from Dario Amodei, the co-founder and CEO of Anthropic. His expectation is that in 12 months, nearly all code may be generated by AI. And let me put emphasis on nearly. What Dario is claiming here is not the fact that suddenly all the software engineers in the world will disappear. There will always be, in my humble opinion, especially for the next few years, a subset of very strongly and competent technical engineers keep pushing the boundaries of how far we can take software. But at the same time, there will be a horizontal expansion of how many people in the world will actually be capable of creating software, thanks to the fact that LLMs have become so good at generating code. On the left, on this slide, you can see this plot on the performance of SweetBench. I will explain briefly what SweetBench is, but keep in mind the trend. We started from 2023 and 2024, where the performance was below 20%, and then you can see how we quickly ascended that curve. We're past 80% at this point, using several advanced techniques, and we can expect this benchmark to saturate very quickly. So in a window of time of roughly 18 months, we went on a benchmark that LLMs could not almost approach at all into something that they are practically completely solving. Why is this important? Sweetbench is a way to evaluate code agents. And what it does is it's a collection of tasks that are generated from GitHub pull requests across 12 open source Python projects. And what we're asking the system here, the agent, is to create code that solves those PRs. There are already tests in those repositories, so we can evaluate if the pull request is correct or not. And this has been launched back in very early 2023. And as I said, in the last basically 18 months, the performance has skyrocketed. Why are evaluations important? They force not only the research community, but also companies to ascend the benchmark as quickly as possible. And this unlock not only forced model providers to make progress, so make their LLMs more powerful, but also as a community, we learn how to build better agents, more reliable, more capable. I keep mentioning the word agents, and I think it's important for me to put it in context and make you understand what they actually are. There are so many definitions out there, but I'm going to try to use the one from a recent blog post from Anthropic that I find to be very clear. So agents are systems that can dynamically orchestrate their own processes and tool usage, while at the same time maintaining control over how they accomplish the tasks. So rather than the software developer deciding how the system will accomplish the task, in this case, it's the agent and it's the intelligence baked into the LLM that decide how certain tasks will be accomplished. Now, the drawing that you see here on the right shows you at a very high level even how Replit agent works today. But I'm going to give you a highlight on why it's even more interesting to do a deep dive on coding agents. So this is exactly the same plot, but I'm putting emphasis on the right side for the following reason. Most of the agents share the left-hand side of this drawing. There is a human providing input. We go through an LLM, and the LLM decides which tools to call, how to interact with the environment, and then there is this feedback loop ongoing. If the agent deems that the task has been completed or not, then there is a stopping criteria, and we return back the control to the human who can submit the next task. This feedback loop is where in reality most of the complexity of agents are today. And the reason why it's interesting, and the reason also why I would say most of the progress has been made in coding agents, is because the feedback loop when it comes to code is even tighter and easier to control. Reason is, first of all, code is verifiable both through execution and testing. And that is the main insight behind Sweetbench, if you recall. So what I was explaining there is that we have a PR description, the model generates the code or the agent generates the code, and then we can immediately verify if that patch is correct or not by means of running the test. This is not something that you will be capable of doing in case the agent was working in a different domain. We don't have a strict and verifiable test to find out if a natural language answer is correct or not. Also, there are plenty of dev tools that have been creating over the past decades, literally because developers created tools to make their life easier. And all these tools now can be orchestrated by agents. So we don't have to create new tools from scratch. We can basically reuse all the effort that these millions of developers have put in the last decades. And that's exactly what we have done at Replit. So on one hand, there is the complexity of how LLMs are evolving, which is mostly in the hands of model providers. But what agent builders like us are doing is creating a very powerful environment that exposes very powerful tools that the agent can orchestrate correctly. So this field, it's very brand new, and I think in the literature we have been calling it agent-computer interface for less than a couple of years. The insight here is that we built tools that humans use on computers for several years, and all our studies have been optimized on how to make those tools as easy to use and less ambiguous as possible for a human user. But the truth is, this paradigm is shifting very quickly. So we're moving now to a world where a lot of tools are not going to be invoked or used directly by a human. They're rather going to be used directly by an agent. So there are some new design principles to be followed to make the agent-computer interface as proficient as possible. So first of all, the actions should be simple and easy to understand for agents. If you think about it, this problem is fairly similar to what happened already in the real world. If you're collaborating with one of your colleagues and they're not an expert in the subject matter, and your request is fairly contrived and ambiguous, most likely the interface between you and the other person will be a lossy channel. The communication will not be productive, and likely the task will not be accomplished correctly. So a similar concept is going on here between making sure that an agent exposed and used by the agent, a tool exposed and used by the agent has to be as simple as possible to understand. At the same time, we want the action to be compact and efficient. So think of traversing a file system. It could be done in so many different ways. You could have like different versions of an ls command. You could write custom code to collect, say, all the file names recursively in a directory. The fact that there are so many options is actually worse for an agent. Like, you want to narrow down the space of options and make sure that every time the agent tries to take an action, there is one single compact and efficient interface to make that happen. Next point, very important. The feedback coming from the environment should be informative but concise. So this is the feedback I was talking about before in this slide, where we have this loop where an LLM calls a tool, an action on the environment. Let's say the action is actually execute the code that the agent has generated. The feedback could be all the logs that the agent sent to the standard output. The truth is that amount of logs could be overwhelming. And I'm not only talking about in terms of cost, because of course, the more data you're passing over to an LLM as input, the higher your call is going to be costing you. But at the same time, is also an issue of how much you could be confusing an LLM by providing an amount of information that it can't really parse through or reason on. And again, this is a problem that as a developer, I'm sure you face yourself as well. If the logs are too verbose, it's very hard to make sense of them. So it's important to make sure that you only pass strictly important information back to the agent. And last but not least, you want to build guardrails on how the error propagation happens. And it's very important also to be able to surface errors all the way to the agent. And what I mean by that, for example, you're building an application that is trying to talk with a third-party API. And if you swallow the exceptions, if you don't surface the errors, the agent won't be able to make progress and debug the application. Conversely, and especially with the latest versions of coding agents on the market, you will see that they're capable of really debugging way far in case you do a good job at providing back all the error data that is important. Like, they are almost starting to mimic how good a human is in terms of debugging software. Aside from everything I said, there are also another couple of pillars that I want to put attention on, and they come from first-hand experience in building agents, in the last couple of years of my career. On one end, we have evaluations, and I will dare to say that evaluations are as important as software testing. You will find out that, especially over a long span of time, the return of investment of creating evaluations will often surprise you. And on the flip side, if you don't invest time doing evaluations, soon you will find yourself not understanding if you're introducing regressions or not in your agent. By the way, this high-level take doesn't apply only to coding agents. It applies to agents in general. So my recommendation is, the moment you have an understanding of what you're building, split all the agent actions, find out what are the key sources of errors, and build bespoke evaluations for each one of them. In our example, for a coding agent, for instance, what is important to evaluate is how good the agent is at editing files. Does it make mistakes? Does it understand instructions? Does it ignore parts of the code that should actually be edited? All of this can be encoded in a large evaluation that you run on a regular basis every time you update your agent logic. So this is the first place where I will put a lot of attention, regardless of the type of agent that you're building. The other one is observability. And the reason is, when you're building an agent, especially at scale, they are as complex as creating a large distributed system. Furthermore, I would say an additional source of complexity is the fact that LLMs they're injecting an unprecedented level of non-determinism in your code. So let's go back to our drawing here. If you can see, part of the logic of how this system works is what the LLM decides to do. So which tools to call, which code actually to generate, because as you can imagine, that code will be executed in this loop all the time. So all this level of non-determinism is very uncommon. The first time that we've been experiencing this as system builders has been basically in the last 18 months, where LLMs have become powerful enough to actually build agents. So observability, if anything, has become even more important than before. And I'm not only talking about aggregate metrics, like to find out at a high level if an agent run is successful or not, to find out what is the user behavior. I'm also talking about being able to really look into what the agent is actually doing. So reading every single LLM outputs, understanding why the agent has made a certain choice, and by means of training this muscle and observing the agent behavior over a long span of time, you will be able to gather insights that you wouldn't be getting by not putting a lot of effort on observability. So I will dare to say, especially in the last few months, I've become an observability maximalist, and I will recommend each one of you intending to start creating their own agent to invest time since day one on observability. I covered at a high level everything that we did until we launched Rapid Agent B2, but I want to go back to the mission of the company that I explained at the very beginning. The fact that we want to empower the next billion software creator. Why am I bullish, and why am I connecting the dots from where we are today, where Rapid has millions of users, all the way to bringing us to the 1 billion active software creators on the platform. The reason why I believe this is going to happen, perhaps even sooner than many people expect, is because I've been seeing personally agents becoming more and more autonomous on a very short span of time. And recently, there has been this study published on measuring the AI ability to complete long tasks, which went back in time for the last 6 years, and they have a very exciting finding where the length of the task that agents can complete with 50% reliability has been doubling approximately every 7 months for the last 6 years. When you're in front of empirical laws of this kind that prove to be true over a long span of time, it will be hard to convince myself of the fact that all in a sudden this trend is going to stop. And if anything, what I've been seeing is actually this trend is accelerating. Even in our case of going from Rapid Agent V1 to V2 in the past few months, I will dare to say the level of autonomy and how ambitious the agent is, so for how long it can work without human supervision, has grown definitely more than 2x. And we have a plan internally, to reach the next level of autonomy, like in the next few months. That's what we're going to be calling Agent V3. But I want to put emphasis on the timeline and how much time it took us to go where we are today. So Rapid as a initial prototype launched on the web dates back to 2008. So we're talking about 17 years ago. And it didn't have any autonomy whatsoever. It was literally a text editor online where you could type your code. Then 10 years after that, we introduced LSPs, which also had some very basic code completion purely based on the syntax of the code. In 2022, so 4 years later, we launched a fast AI code completion model that allowed to complete lines of code or maybe small blocks of code. Fast forward another couple of years, we launched Agent V1 early access in September 2024, and we made it GA in December. And Agent V2, the early access was launched in February, and the GA in March 2025. If you happen to have used both of those products, you would have seen that Agent 1 had probably a couple of minutes of autonomy before it went back to the user and asked for feedback. On Agent V2, we're already around the 10-15 minutes threshold, where you could describe at a high level the task that you want to accomplish, and the agent will go and not only create the feature, but will also do a pretty exhaustive job in terms of testing and debugging. And where I see us going next for Agent V3, which I think will bring us around the, if you map the level of autonomy to those of full self-driving, it will put us in a place where probably the agent will be capable of working, so going from point A to point B, maybe for an hour in a row before asking a user for feedback. We're gonna add in the recipe a way not only to create applications automatically, but also to test them. So we're creating a new system that will be in a sense like adversary, and will be testing the application continuously, so that the agent can be exercised not by a human providing feedback, but rather by an AI that tests the apps and provides feedback on what the agent should be doing next. So it's a very exciting future, and that's why I'm also extremely grateful that the field of people doing research on agent keeps expanding over time, because I see this is where the most of the progress, especially in terms of democratizing intelligence, will actually happen. I don't think it's purely a matter of putting LLMs in the hands of everyone. The moment we're actually going to see worldwide impact of AI will be the moment that agents will be in the hands of every single person, because they're going to really be capable of accomplishing tasks 0 to 1 without human supervision. I could have gone on for much longer on this talk and go on more technical details. We don't have the time for that. So if you're curious to hear some more of the technical insights on how we built the past versions of Rapid Agent, just check my thread on X. I have this Stanford lecture where I go for more than 1 hour explaining a bit how we went in the last 18 months from a basic version of the agent all the way to what we just launched a couple of months ago. Thanks for your attention, and I would love to get questions now. Thank you.
Michele, thank you for an absolutely brilliant talk. It was great to see the sort of behind the scenes look at how you're creating software agents. So let's get started with some questions that we have. So the first one is, what would you say is the single biggest sort of technical hurdle in getting your AI agents from sustaining, say, hour-long autonomous sessions?
I would say the combination of making LLMs not only more powerful, but capable of understanding each single step required to work on a long horizon task. And at the same time, what I was explaining at the end of the lecture, the capability of testing the applications that our agent creates. The reason why it's so important is because without testing, it's relatively easy to fool a coding agent that the task has been accomplished correctly. And there are so many different challenges to make that happen, such as browsing through a complete web application, doing several types of inputs, several types of interactions. And that's exactly what we're building today for the next version of Rapid Agent.
So similar to kind of autonomous driving, we also have concerns about the safety of our code. What are some measures that you're taking to prevent the AI agent from shipping unsafe or malicious code?
I love the self-driving analogy. I think what is happening today is our car is driving in a simulated environment. That's the way in which Rapid works. We have isolated containers. There's nothing that can go wrong except in your own instance of compute. The moment you decide to deploy the application, we have a lot of security countermeasures, and we force the agent to go through certain best practices to reduce the blast radius of what could possibly go wrong. So I think it is easier to harden the security of your app rather than making sure that everything that an LLM generates is safe by definition. I leave that challenge to the AI providers, and I try to make sure that the envelope that I put around that app is as secure as possible.
Great. So beyond kind of SWE bench, what are some benchmarks that you think best predict the real world success for coding agents, and why is that?
On one end, I love benchmarks that show you how good LLMs are at tool usage, because ultimately an agent, as I was explaining before, is the combination of the raw IQ of the LLM and its capability of choosing and how to use the tools that it has available. So those benchmarks are extremely important. At the same time, and this is more a call for my community rather than something that exists, I would love to see end-to-end benchmark where the artifact built is a full stack application. And rather than evaluating the agent on how good it is at creating a patch, a PR, it's rather how good the agent is at creating a full stack web app, which is something that we're working on already. But I'm going to make this call to the public. If anyone wants to collaborate on this research project, please reach out to me.
Great. Thank you so much. Thank you so much for your presentation and for taking these questions.
Of course, it's been a pleasure. Thank you.
Thanks. So next up, we're going to have Professor Raluca Adapopa, and she's going to be giving us a talk about the privacy-preserving AI compute with decentralized verification.
Hello, everyone. I'm Raluca Adapopa, and I'm an associate professor at UC Berkeley working in applied cryptography and security. I'm also co-founder of IMUA, Opaque, and Prevail. I'm very happy to be here today, and I'll be talking about privacy-preserving AI compute with decentralized verification. So as you probably know, demand for GPUs remains ahead of supply for high-end GPUs, especially on major clouds and beyond. As a result of that, there's been a number of decentralized marketplaces that are emerging because they are offering otherwise idle GPUs for a much cheaper cost. As a result, a number of users have increasingly been leveraging decentralized systems for their AI workloads. However, a challenge with that is the fact that now a user has their precious confidential data spread across, potentially different GPU owners that it doesn't know or trusts. So in a decentralized GPU system, we have a user send their AI workload to, let's say, in this case, 3 GPU owners. That could be, smaller clouds or individual owners. And the user would send maybe the data that they use for fine-tuning, or they would send prompts. These prompts can be confidential, and each GPU owner can in principle observe this confidential data and can also alter the computation that is being produced. For example, some GPU owners might be incentivized to use a smaller model instead of the bigger model to save on electricity. So the question is, how can we ensure confidentiality of this data and also the integrity of the data and the computation in this decentralized AI system? So I've done a lot of work in that space, and let me begin by first showing a very simple setup for inference in RAG, and then seeing how we can secure that with confidentiality and integrity properties. So we have a user who wants to query an LLM, and we have a RAG database that captures a lot of knowledge. The user sends a query to the model provider, which normally gets routed to a retriever, and the retriever makes a RAG query to the RAG database. The RAG database returns related knowledge to that query, and then the retriever augments the query with that knowledge and sends it to the model, and the model replies with an answer. So this is a simplified pipeline for inference and RAG. Now, in this pipeline, the concern is that the LLM, the retriever, and the RAG database are going to be run and hosted by an untrusted owner. And again, as I mentioned, this can be very confidential. For example, the RAG database can contain user, medical or financial data, or other sorts of user documents. Also, the RAG query, what you're querying for, if you're querying for, let's say, cancer or flu, that could also be sensitive. And LLM processing and the answer can also be sensitive as well. So I've done a lot of work on trying to protect the confidentiality of this data and the integrity of the computation, despite the fact that the owner of the GPUs is untrusted. And there's really 2 parts to this work: secure inference and secure RAG. Now, for the inference part, what I'm referring to is really primarily interacting with LLM, sending queries to the LLM and responses. And for the RAG, I'm mostly focused on the retrieving part. But really together, is what one would use in practice to create a secure inference RAG pipeline. So basically, by secure inference, what I mean here at a very high level, and we define cryptographically informally a lot of these notions in our various papers that I will mention. But at the high level, what we mean is the fact that the user sends an encrypted prompt to the model provider, prompt that the model provider doesn't see, and receives an encrypted result. Again, the model provider doesn't see that result. At the same time, the user doesn't see the model weights, which are proprietary. And for the RAG, similarly, the database and the query of the user stay confidential and the model provider doesn't see them. So how can we provide secure inference, a secure RAG? So there's really two major approaches, is the cryptographic approach and the TE-based approach. I have done research on both of them, including build real products in companies like Opaque and relatedly in Nimua. And the reason is that, there isn't a winner in this case, one size fits all. Both of these approaches work very well for certain use cases, and they have a trade-off. So let me tell you a little bit about the trade-off, and then I'm going to go deeper into some of these categories. For the cryptographic approach, it's suitable for simple computations, but slow for complex workloads. So really, efficiency and security is a big trade-off for these two approaches. There's other trade-offs as well, including some that I'm discussing in a ACMQ article, if you're interested, about cryptographic systems versus enclave systems. But I just want to highlight the efficiency versus security challenges now. On the efficiency side, cryptographic approach still has a lot of overhead. So that's why it's more suitable for very simple computations. The RAG queries tend to be a search in the nearest neighbor graph, which is much simpler than a more complex workload like a transformer. In terms of security, they provide very strong security guarantees where you primarily assume that hardness, cryptographic hardness on the server side. So in the server cannot affect confidentiality or integrity, even if the entire code base on the server side is corrupted. It can affect things like availability, take the service down, and some other notions like that. Now, on the TE side, the trusted execution environment side, they can support efficient, complex workloads. Today, we have GPU enclaves that can support transformers at very high speed. Moreover, they offer a confidential VM interface, so there's no application rewriting. It's very convenient to just put in some code base inside these enclaves and run it in a confidential computing environment. Also, in terms of security, though, they rely on the security of the TE, the trustworthiness of the hardware vendor that created the TE, and on the trusted compute base that you put inside these enclaves. And sometimes people who put whole stacks inside the enclave. And this is in addition to cryptographic assumptions, which they also rely on for things like secure communication and whatnot. Okay, so basically, depending on your workload, if you have a simple workload where you can actually optimize things for that workload, then a cryptographic approach is better security-wise. But if you have a complex workload and you don't want to do application rewriting, then really the TE approach is one of the pretty much the only approach you can use today. So let me now dive deeper into the TE approach, which is work that I've done both in academia through my papers, Opaque, Snoopy, and Oblix in particular, and also as part of co-founding my company, Opaque. Hardware enclaves are one type of TE. They're a type that has risen to prominence in the past few years. They are widely used in major clouds, for example, Google Cloud, AWS, or Azure. And computing with hardware enclaves is also called confidential computing. So these enclaves can be CPU-based enclaves like the Intel SGX, TDX, AMD SAV, SMP, or GPU enclaves like H100 and Blackwell, which are newer, and which work usually by connecting to a CPU enclave. So some very quick 101 on how hardware enclaves work is basically on the cloud side, on the machine, we have the CPU and the GPU driver in something called a confidential VM. This is hardware isolation that is enforced by the hardware enclave hardware on that machine. And that offers something called remote attestation, which measures the software running on the confidential enclave in the confidential VM and sends a signed digest of that software to the user. So the user can verify what software is running on these enclaves and also can learn what is the public key of the enclave. And this public key is certified by the hardware vendor and another relevant certificate chain. Now, through this, essentially the outcome of this is that the user can create a secure channel between the user and the inside of the VM. And through that, it can send confidential data. It's encrypted and authenticated. This is a secure channel like, TLS. And only the inside of the enclave can decrypt it. The outside of the enclave, even the operating system outside of the enclave, cannot have access to the inside of the enclave and cannot see the data that the user is sending or tamper with the execution. Also, the GPU driver is connected through another attestation process to the actual GPU machine. So basically, the GPU enclave on the GPU, together with the CPU enclave on the CPU, form essentially, you can view it as one logical enclave. It's then very natural to leverage these enclaves for secure inference and RAG. The idea is that we place the model inside the enclave and we place the RAG database encrypted outside. Now, for sending the prompt and the response to the inside of the enclave, we just use encryption in transit, like normally. But this channel that's encrypted for the prompt and the response, as I said, is only decrypted inside the enclave. So software outside of the enclave, including cloud employees, cannot see what the prompt or the response are. Now, inside the enclave, we perform secure inference. So this is called encryption in use. Even though the data gets decrypted deep down in the processor, it is encrypted outside of the enclave So for all purposes, administrators looking at the data coming out of the enclave, looking at the memory in the cloud, the data looks encrypted at all times. Now, deep down in the actual processor, the data gets decrypted with the TEs, which is why TEs are so efficient. So basically, the secure inference and LLM runs on the prompt and the knowledge from the RAG database inside the enclave very efficiently. Knowledge from the RAG database is fetched in encrypted form, but it's decrypted in the enclave. So inside the enclave, we have regular inference and RAG pipeline running. But outside of the enclave, everything looks encrypted at any point in time. That's why it gives this essentially this notion of encryption in use. This is the perception that software outside of the enclave has, because in fact, the data does get decrypted deep down in the processor. So basically, my company Opaque that I've co-founded based on my academic work together with my colleagues at UC Berkeley and students who graduated, offers this kind of secure inference and RAG pipeline on the major clouds for confidential data. This technology offers the flexibility to run and change code inside the enclave, and also very efficient. There's minimal overhead added to the regular pipeline. So the idea is that there's no friction. You can take your RAG pipeline and place it inside Opaque and use it unmodified with little performance overhead. All right, so now let's switch gears and talk about the cryptographic approach. I'm going to tell you about secure RAG, which is actually efficient even in the cryptographic setting. Now, I'm not telling you about secure inference, and even though we've done a bunch of work there, for example, Maril, our latest work, improves performance over state-of-the-art by 10x for transformers. So for doing secure inference for transformers with cryptography, it's still very slow. So that area of work is still not efficient enough for transformers. Big strides have been made, but the cost to run cryptographic inference for transformers is still very, very high. So on the cryptographic side, I would say RAG is primarily the more efficient one of the two in this scenario. So what can you do? You might wonder, what can I do if I don't have secure inference, and I just have RAG from the cryptographic approach. And really what you can do is actually combine them. And I've seen this model quite a bit, where you do secure inference using the enclaves, using the TE approach. And then you can do the RAG. If you don't want to do it with the TEs, you can do it with the cryptographic approach. And the nice advantage of this is that the cryptographic approach is so powerful that you essentially can think of removing the RAG database out of your trust perimeter. You don't really have significant trust assumptions there, not when it comes to confidentiality or integrity. So you're essentially removing the database from the trust perimeter by using cryptographic RAG, and then you're just focusing on securing the secure inference part. So let me tell you a little bit about how Compass works, which is a very new recent work of ours. Basically, Compass enables you to do the RAG retrieval on an encrypted RAG database. And so embedding search is basically what happens during RAG retrieval. It's a very common type of search. Google does it, Bing, Pinecone does it. And Compass offers an encrypted version of that preserves the privacy of the query and the privacy of the database, but also enforces integrity. So basically what happens is that the user sends a query to the retriever. The retriever is on somewhere in a trusted perimeter on the client side or on premise, or it can run in the enclave in the combination with the TE. And the retriever encrypts the query and sends it encrypted to the RAG database, which is on the server side in the cloud. So an attacker, the server side or untrusted owner, cannot see the contents of the RAG database and cannot see the contents of the query either. Then the RAG database returns the results encrypted, and the retriever can decrypt them and give them back to the user. For example, it could be a ranked list of values that match that query. From the user's perspective, the query ran normally. There's no sense of computation encrypted data. But from the server side, it only received encrypted queries, and it has an encrypted database and returned encrypted results. So from the server side, an untrusted owner is unable to see what the query and the database is. And to just be a little bit more precise here, by untrusted owner, really, the owner can be completely compromised, can be malicious, can try to deviate from the computation, alter results, alter the database, try to do side channels on the server side and learn what the query is. But despite this, the server cannot learn what the database is, the query and the results, and we formalize what we mean by this in the Compass paper, which is available online. And the server cannot tamper with the results undetectably. If the result is not correct that comes back from the server, the retriever will be able to detect it right away. Moreover, we also protect against the leakage vector called access patterns. When you have an embeddings database, when you have a nearest neighbor search, then the path you take through that graph leaks a lot about the content of your query, because nodes are arranged based on meaning and relation to each other. So for example, if the attacker somehow knows that I search for cancer at some point, and the nodes related to cancer are probably types of cancer. So just based on how the user moves in the graph, they can infer what the nodes are and what the query is. And there's a literature and a line of work that demonstrates that these attacks actually can reveal a lot of information about the query and about the data. So basically, we protect even against that. The server only sees the user making some random looking queries. Even if the user moves through neighbors in a nearest neighbor search graph, it just looks to the server like the queries are random. What we don't protect against is denial of service attacks. So if the server doesn't want to provide service, then there's no protection here. And if the server wants to just exploit things like the time when you make a query, then again, we don't provide that any protection there. In principle, you can pad by making lots of queries at a fixed rate, but that's obviously very expensive. So how? At a very high level, we enable HNSW, which is a state-of-the-art embedding search index, to run efficiently and securely on encrypted data. I cannot tell you how things work because time is short, but just to give you a sense, we leverage a tool called Oblivious RAM, which is a very powerful tool for querying data in a way that at a high level, intuitively, the queries look random. It's nice because it's still algorithmic in complexity. It's agnostic of the embedding distance in embedding space. And it's easy to add a Merkle tree, hash tree on top to obtain malicious security. Unfortunately, it has a large number of round trips and high bandwidth when you combine it with HNSW, because this kind of embedding search indexes are designed for local search. So they have lots of different hops, which translate to wide area network round trips for ORAM. So we were able to resolve this tension and combine HNSW and ORAM through co-design of machine learning and cryptography. Basically, we have a new way to traverse HNSW over the network, and we have an ORAM that we modified in a white box way that is particularly tailored at graph traversal. And together, we actually obtain very good performance and efficiency. I won't be able to go into the two directions that we have in terms of the techniques that we have been applying, but you can see the paper to learn more about them. All right, so the last piece that I want to talk about is adding crypto-economic security to the cryptographic approach to alleviate some of the cryptographic burden. And this is work that we're doing in a company I have co-founded called IMUA. So IMUA is a universal protocol for shared security, which basically takes the economic security of multiple blockchains and combines it and extends it to off-chain services such as decentralized AI, like we're talking about here. At a very high level, you have stakers at stake and against validators and operators that also have a minimum stake required. And this network of these, essentially through IMUA, provide cryptographic security, crypto-economic security to some off-chain services. And these off-chain services can be a decentralized AI marketplace like what we're talking about here. If misbehavior is detected as part of that, then we have slashing, right, as a punishment. And essentially, the stake is lost. So there's crypto-economic incentive to behave correctly. So how can we use this in the decentralized AI space? Well, let's think about integrity. So we want to verify that the results coming from the model provider are correct. In particular, the model provider did not use a weaker model. There's different ways to do this in the literature. For example, we can ask the model provider to provide a ZK proof and verify it, or we can actually do re-execution, where we re-execute the query at some other node. These are expensive. For example, for re-execution, if you re-execute the query at 2 or 3 other nodes, you pay 2 or 3 the cost. Instead, the idea is, what if we could just verify from time to time? Of course, then the attacker could cheat the other times. But the idea is we'd like to verify the correctness of the query, for example, through re-execution or some other means, at just periodically, but unpredictably. So we choose sometimes when we're going to verify with certain probability, but the attacker, the server, doesn't know when they're going to get audited and verified. And because of that, the attacker should want to behave correctly because they're going to get caught otherwise with a certain probability. And so here the GPU owner is going to stake through IMUA, and it's going to get slashed if it caught misbehaving. So just to kind of complete the picture here, we have a user that's querying decentralized AI off-chain services, querying and answering. And as part of those systems, we have some sort of simple verification where we verify from time to time the correctness of the results from the GPU owners. There's a variety of different tools you could be using for that. And if we detect misbehavior, then you slash the GPU owner through IMUA. So basically, they have the incentive to behave correctly. Otherwise, they're going to lose stake. And the way one needs to structure this stake economically is to make it more economically advantageous to behave honestly every single time, because the cost benefit they have by not doing that should be smaller than what they lose by being slashed. All right, so this completes the picture of cryptographic approach through cryptographic techniques and cryptoeconomic security and the DE approach. And let me conclude. So basically, decentralized AI is a very exciting application that's rising. And really, a main challenge there is how to provide confidentiality and integrity. This can be achieved through cryptographic and TE-based solutions that have a trade-off of efficiency and security. And cryptoeconomic security via risk-taking can reduce the burden of cryptographic verification. If you want to learn more about this work, please follow me on Twitter or read my papers. Thank you.
Great talk, Raluca. Thank you for covering such a wealth of topics there. So we have some questions for you. So the first is, when should teams be keeping a part of their RAG pipeline in a GPU enclave versus switching to pure cryptographic protection?
Great question. I would say that for the model part of the inference, it should stay in the enclaves because cryptographic solutions are still very slow for the actual transformer inference. But the RAG retrieval, so I would say, RAG has two steps, has RAG retrieval and has the model part. For the retrieval part of the database, that's where the cryptographic mechanisms like Compass are actually much more efficient. And it's something that you can actually develop very efficiently and engineer very well. And that basically enables you to remove your RAG database from the trust perimeter. So I would say putting the RAG database with cryptographic protection and doing the retrieval with cryptographic protection, and then keeping the model and the model inference in the enclaves. That's the divide that I would say makes the most sense.
Great. So this is a little bit about the cryptoeconomic aspects. So how large should a validator stake be, say, relative to the GPU revenues in the case where you're doing the slashing if they don't get it right?
Very good question. So we're actually about to put the exact equation on archive later this week or next week. But just to at the high level, the way to think about this is it depends on a few things. So let's think of a specific validator in part. Let's think of the gain they could make by not running that model and running a smaller model, or just not running that model, like how much compute are they saving and how much basically cost are they saving. And so that should be smaller than what they risk losing if they cheat. So basically we can think of the amount that the slashed amount and the chance of being caught, right? It's kind of like expected of what they risk losing at that cheating attempt. So basically making sure these quantities, that the amount they risk losing is higher than the amount they actually can win, will create the economic incentive for the validator to behave honestly. It's a bit more complicated equation than that because there's a few other factors, but at a high level, this is the way to kind of think about it.
Got it. So the next question is about side channel attacks. Are there any sort of realistic side channel attacks on, say, H100 Blackwell GPU enclaves, and what kind of mitigations are still missing?
Yeah, very good question as well. Side channels are a beast in that they're so complex of different types. First of all, the GPU enclave is still connected to the CPU enclave, so you still inherit some of those side channels from the CPU. Second of all, there's a bunch of side channels from the GPU computation itself, like accesses to the GPU memory. And then there's side channels caused by things outside of the enclave. For example, you're accessing the RAG database, whether it's in memory or whether it's somewhere remote. That, I would say that side channel vector is probably the first to mitigate first. Why? Because searching in embedding space, that movement in embedding space leaks a lot about the meaning of the content by the very way in which embedding space is structured to capture meaning. So I'd say I'd first go about trying to mitigate the side channels with respect to data retrieval and searching through embedding space. And these are the oblivious techniques I talked about. And then just make sure to use the latest advances, latest updates and upgrades for side channels with respect to the CPU and the GPU enclave. These tend to get patched fast as soon as they get detected, but there's still a wealth of them happening and most likely to keep happening.
there's kind of a gap between your average ML engineer and all of the sort of cryptographic techniques or even hardware security. So is there at this point a good set of tooling or SDK features that are helpful for ML engineers to kind of adopt enclaves or ORM without a lot of expertise in those?
Yeah, very another good question. You guys have a lot of good questions. I don't really usually say that for every answer, but they're great questions. So for confidential computing, tools have improved with the cloud providers offering a VM interface. So you no longer have to rewrite your application. That being said, it still requires more expertise than I would say the average ML engineer has, because you have to set up the remote attestation that I mentioned in the talk. So this is really the reason why we started Opaque, is to reduce some of that friction and to provide that kind of tooling. So I'd say, we have ML engineers usually use, tools like Opaque to just literally turn it on and then have confidential computing and not worry anymore about the ML pipelines having to change and the setup for, cybersecurity expertise. When it comes to oblivious computation, things are not quite like that. There's a few startups trying to offer ease of use for oblivious computing, but I'm not really aware of a solution yet that actually makes it easy.
Still kind of in the days of having that all worked out.
Still in the early days of that having to be developed. And I'd say, but the one thing that's somewhat good thing is that it's a pretty well confined piece of library that one can, it's not like a complex big system. Again, I guess it depends on your use case, but if you just treat it as a black box for retrieval, it could be well confined, so there shouldn't be a lot of development. Again, depends on how much you want to scale and things like this. But yes, I would say the overall answer is that there isn't like a lot of mature code that you could use for oblivious computing.
Sounds great. Thank you so much, Raluca. I really appreciate your talk and for taking the time to answer our questions.
Thank you so much for hosting me, for the questions too.
Great. And now we're on to our next speaker, which will be Professor Salil Kanhere from University of New South Wales. And he'll be telling us about decentralized identity management.
Hello, everyone. Welcome. I'm Salil Kanhere. I'm a professor in the School of Computer Science and Engineering at UNSW, Sydney, Australia. And I'm going to talk about some of the work we've been doing in decentralized identity management, particularly looking at making it practical and extensible. So as you all aware, digital identity is being adopted in various parts of the world. So here on this slide, you see some examples I've put together. For example, in Australia, we have national digital identity laws come into place. There's similar rollouts in other parts of the world, like in Korea. I'm aware that several states in the US are doing similar things. For example, I saw this particular news item where in Louisiana, they're now requiring anyone who wants to watch adult content to prove that they are above a certain age. And that has to be done through a Louisiana state digital identity application. So if you look at the current state of how digital identity actually works, there are sort of two broad approaches. So you have this traditional siloed approach where each of us, we go and create an account with a particular service provider, say Facebook, Google, Amazon, right? And then they manage the identity for us for that particular service that they provide us. Recently, we are seeing this other approach coming by, essentially a federation. So rather than creating accounts with each of these service providers, you may designate a particular federated identity manager. A lot of times this could be some of the tech companies like Google, Microsoft, Apple, for example, or your organization might be using another provider, right? And then you use essentially the credentials with that identity provider to, they would verify you, and then you get access to these services. And this could actually be used across multiple service providers. That said, there are a lot of problems also emerging. So here I present two examples from Australia that happened last year. One of our largest mobile provider got hacked, and details such as passport information, driver's license information were all leaked. And this was almost 40% of our population here in Australia. So that was pretty huge, and it had some significant repercussions. Similarly, one of our large grocery provider got hacked. And this here is an example where this ID verification service itself got hacked. And this was providing services to various other service providers like TikTok, Uber, and X. Then we have issues, going back to my earlier example about Louisiana. There are issues around using a service like that. Essentially, as you see here on these posts that on your screen, there is concern that this service that they are wanting you to prove your age is essentially managed by the state. It's a Louisiana wallet. It's a centralized, essentially, service. So this could potentially lead to this surveillance state problem, where the state is sort of now monitoring all the activities the citizens, residents essentially are doing. There are privacy issues around that. I mean, there's concern on what if some of this data gets leaked? Could someone then blackmail the particular individuals, knowing their behaviors? And there's concerns around the terms of service of this as raised here, right? So the key issue here generally is the loss of privacy. So if you take a step back and look at where we are, so there's a lot of problems essentially from a user perspective, right? So we create our identities, it's something, and we record a lot of our personal information, but we don't have much control over how this identity is used. There is potential of leakage of the personal information, potentially sensitive information, which you may not necessarily want to reveal. And of course, there are concerns around the reliability of these services. And a lot of times, the design of these services is based on what the service provider thinks is good for them, rather than what we as identity owners are concerned about, right? So they might go with simpler ways to implement things rather than keeping our concerns in mind. So recently, there's an alternative emerging, which is referred to as self-sovereign identity or decentralized identity. The idea being that we as identity owners get sovereignty over our credentials. So we should have a lot more control over our credentials without relying on any third parties, right? So we can use these credentials issued to us at will without fearing that there would be leakage of the usage of these credentials to third parties, which is what often happens in the current ecosystem. So what exactly is this? So there's essentially this notion of a decentralized identifier. It's a unique identifier. So as shown here, it could be something like this. It's permanent. It's resolvable to a particular entity. And when you create these identifiers, you're also creating a pair of keys, a public and private key, essentially. So this is cryptographically verifiable. And it's managed in a decentralized way. So it's not managed by one central entity. So here, for example, this DID refers to this particular subject. There could be a URL pointing to that DID, which you could pass along. And there'll be some metadata, which is stored, which is referred to as the DID document, which is then normally stored on a verifiable data registry. And this DID document can include the verification key. It can include a pointer to the service endpoint. So someone can then initiate a discussion, essentially use this DID. Now, there are two versions of this. There's a private version and a public. A public version is something you would hand out to everyone so they can publicly connect with you. Private DIDs are useful when you want to have a private engagement with one particular entity. So the SSI ecosystem sort of looks like this. You have the issuers who are the ones who are issuing these credentials. So these could be, for example, your road traffic authority who's issuing you a license. It could be the government issuing you a passport. It could be a university issuing you a transcript, right? The holder or the subject is the one who's being issued the credential. The verifier is someone who needs to verify that credential in order to give the subject access to certain services. For example, if you're taking your transcript to a prospective employer, the employer could be the verifier in this case, right? As a holder, the idea is to create a presentation which you then present to the verifier, and the verifier can then verify that this presentation is accurate. So they can check the identities and they can confirm that this is indeed a correct credential. Now, a key component here is the verifiable data registry. And of course, there are various ways to implement this. However, in recent years, we are seeing a lot of adoption of decentralized distributed ledgers, essentially, or public blockchains for managing the data registries. Now, there are a few issues with regards to this, and this is something we've been working on in our lab. So I'll present you very briefly two pieces of work that we've specifically done. In the first piece of work, we are looking at this notion of data minimization, right? So this is one of the key principles of self-sovereign identity, which refers to essentially collecting the minimum amount of personal data that is necessary for delivering a particular service. And you'll find a reference to this also in the GDPR as one of the key privacy regulations. So that's kind of depicted on this slide here. So imagine Jane, she's got a degree from a particular university, and the university has issued her a transcript, right? So this is the issuer in this case. It's a known entity who has issued her that particular transcript. And as you'll notice, the transcript has various attributes. So the example here basically shows you a case where Jane may want to selectively disclose certain attributes to certain verifiers. For example, Bob may only need to confirm that Jane received a degree from a particular institution. Bob does not really need to know her date of birth. Bob does not need to know her GPA, right? So when Jane presents the credential to Bob, she could selectively hide some of these attributes. When she's revealing this to another person, she might choose to reveal the GPA and hide some of the other attributes, right? So that's a very simple sort of illustration of this. So in this first work, which we called Crate Chain, published a few years back, we actually tackled this specific problem. And the reason being that we couldn't find a scheme whereby the holder, the subject, essentially could create a different presentation, essentially selectively hide certain attributes on the fly without having to go back to the issuer, right? So in this previous example, the current schemes at that time required Jane to essentially create a new credential based on whatever she wanted to reveal by going back to the issuer each time, right? So that creates unnecessary work for the issuer. So we were looking for a way whereby we could do this in one shot. Essentially, the issuer gives you one credential, and then you as a user can selectively hide whatever you need without having to go back to the issuer. So we actually found one particular redactable signature generation algorithm, which comes from this particular paper here. So this is based on the GGM tree construction and Merkle hash. So it sort of works in 3 steps. You start with a pseudo-random value, L epsilon, as shown here, and then you create essentially a binary tree like this. And each node, you create a random number. And the depth of the tree will essentially be based on how many attributes you have in your credential. So these leaf nodes here are essentially individual attributes. So the first phase is creation of this tree, the expansion phase. The second phase is your standard hashing, which is essentially what we do in a Merkle tree. So at the bottom here, you would hash two attributes together along with the random value here. And you would keep doing that. And as you go up the tree, you will be hashing the left and right children, essentially, of that particular node. And at the end, you have the root of the Merkle tree, which is then signed. Right? So this is the final phase. And this signature is essentially an extensible signature. So this is what the issuer would do in the first instance. They would create this signature. So the steps are sort of highlighted here. So you have a first setup step where the issuer creates certain parameters. Then we also allow the issuer to basically say, hey, you cannot redact certain fields, right? There might be cases where you might want to say in this template, in this credential, you can never remove your name, for example, right? So that information is then stored here. Essentially, these are the fields that cannot be redacted. And then the issuer would execute the steps I showed you on the previous slide. Create the credential, create the signature, and this credential is then given to the issuer. We also take a hashed hash of this credential and store it on the ledger. So this allows us to track the assignment of these credentials later if there's a need to audit. This third step is what the holder, the user, can do. So they would then decide to remove certain attributes from the credential. These attributes should not match any of the attributes that cannot be redacted. If that happens, the system will give an error. For the redaction, all the issuer has to do is essentially remove those particular attributes that at the bottom of that tree on the previous slide. However, what the holder the holder would also do is they would include the hash of those attributes in this extensible signature. So even though they are not including the attributes that they want to remove, they will add hashes of those attributes to this extensible signature and the indexes. So later the verifier can actually put this tree together in the verification phase, right? So the attributes that are revealed are still here, and the in the credential, and the verifier, when they're regenerating this, they would have those actual attributes. But for the ones that were hidden, they would have the hashes and the indexes from here. So they could fill those in and they could regenerate this tree and confirm that it is accurate. So we've implemented this within an SSI ecosystem. So here, for example, you see the whole system with a DApp server to interact with the actual users. Down here, you see the actual SSI platform. So this includes various services like managing the DIDs, managing the issuers, managing the accounts, and then some of the services that we have implemented. So the setup phase, the signing phase, the redaction phase, and a verification phase. So these are the credentialing services that we implemented. And at the bottom here, you have all the registries that manage on-chain data. So essentially credential registry, issuer registry, and so on. This here shows you some simple interactions. So assuming a user has been authenticated, let's say they want to request a credential. So they would send a credential request. The DApp server would obtain their DID, send that information to the issuer. The register issuer will then check within their own data store for whatever, for example, if this was a university transcript, they would check all the courses the student has enrolled in and their marks, and they would then generate the credential by invoking the signing service here, as you see. And the credential would then be sent to the DApp server. A hash of the credential would also be stored on the blockchain. And the DApp server would then send the credential, link to the credential to the recipient, who could then download it from the issuer. So now the recipient has the credential, and let's say they now want to actually create a presentation. So they would redact certain fields that they wish, and then essentially tell the server to generate the claim. The DApp server would then invoke the redact function, which would first check that those attributes can be removed, and then they would regenerate. They would create the updated presentation, which would then be sent to the verifier. The verifier would then download the presentation, and they would call the verify function, which would involve regenerating that tree and checking that the root matches, the signed root matches. So that's essentially what we've done in the first piece of work. Now, in the second piece of work, we've addressed another issue, which is part of the SSI standard. It basically says individual users should be able to create credentials on their own, right? So in all the previous discussions, the assumption was the issuer is someone well known. It's like an institution which has gone through rigorous checks to be allowed to issue credentials. So in this second piece of work, we were trying to see if we can extend similar capabilities to personal issuers. So a very simple example we give is, okay, let's say someone has had an accident, Anna, for example. She's been taken to the hospital, and she wants Tim, her friend, to be able to take responsibility of all the medical treatment on behalf of her, because she's incapable of doing that herself, right? So the hospital might require her to sign a letter of authority. And essentially, in this SSI ecosystem, this would mean Anna, as the personal issuer, would have to create a credential for Tim and hand over the authority to Tim to take all the treatment decisions on her behalf. So this would involve her issuing one such credential. So what we found was this facility does not exist in the current ecosystem, because issuers are assumed to be official entities. They have to go through a certain process to be onboarded, right? So can we essentially do that without this heavy onboarding process? And to do that, we've incorporated this notion of web of trust within the SSI ecosystem. So the idea is that we essentially we create these three levels of entities. We have at the top level, we have the organization, essentially, who sets the rules, who decides how people can be onboarded, essentially, as personal issuers. And in the middle, we create essentially what are called trust proxies. So this, in the hospital example, these could be, say, a doctor, right? So the doctor could be trusted to onboard their patient and allow the patient to issue those supporting credentials that I mentioned, essentially a credential that allows someone else to take a decision on behalf of that particular patient. So in this example, the doctor would then become the proxy, and they would create credentials like you see here, essentially create a consent credential, create a delegation credential, which would then allow the patient to actually issue those credentials for someone else. I am running a little behind, so I won't go into all the nitty-gritty details, but essentially this involves a few steps, a few components. So we need an ecosystem where we need to create these templates and how the decisions on how to manage those templates. We need what are called role credentials, which allow someone to prove their role in order to serve as a proxy. And then we need certain cryptographic schemes which allow us to essentially manipulate the template at a later time, essentially add the names of the individuals who are being onboarded and the actions that they are offering essentially in the credential. We also have a voting process. Sometimes that might be necessary in the context of the application to prevent collusion, for example. So I think I'll quickly summarize, essentially, the goal of this talk was to just give you a brief overview of this emerging concept of decentralized identities and how they allow us to take greater control over our identities and our credentials. And specifically, I talked of two pieces of work from our group. The first one is looking at how you could essentially selectively disclose attributes within the credential. And the second one allows someone to onboard individual users to allow them to then issue credentials. So yeah, that's it. Thanks again for your time. And I'll be very happy to take any questions from the audience. Thanks.
Hi, Salil. It's great talk and wonderful to learn about all your work on decentralized credentials and identity. So we have a few questions for you. Let me read them out and you can respond. So the first question is, how do redactable signature schemes compare with other privacy-preserving techniques like zero-knowledge proofs or secure multi-party compute in terms of practical implementation challenges? Are there specific use cases where it might make sense to actually combine some of these schemes together?
Yeah, thanks, Bhaskar, for the question. So yeah, I think that's a very valid question. At the high level, of course, both schemes are doing similar things, essentially offering this aspect of privacy protection. Now, there are certain things where one is perhaps better than the other. I guess where zero knowledge can be quite useful is because you're essentially generating a proof. You're not actually showing the actual credential, right, to the service provider. So there might be use cases where that may be preferred rather than actually presenting the real credential. We did some benchmarking, performance benchmarking. I was trying to find that paper. I haven't been able to find it, but I think if I recall, zero knowledge was also better in terms of performance compared to redactable signatures. That said, the cons with zero knowledge could be essentially it does require putting in some trust into generating the witness, for example. Essentially, it's basically a horses for courses, right? So certain use cases where one might be better, certain where zero knowledge might be better. And this idea of combining the two is actually also taking some credence. Essentially, I've seen works where you use the redactable signature as the first step, and then for more complex scenarios, you then explore zero knowledge proofs.
Very interesting. So there's a question about multiple verifiers. How do redactable signature schemes work if you have multiple verifiers?
Oh yeah, that shouldn't be a problem, particularly our scheme, because we give the holder the complete control over which credentials they're hiding, right? So if there's a scenario where they need to present the same format of the generated credential, they can certainly do that. But if not, if different verifiers want different things, that can be generated very quickly by the holder directly.
Anyway, it seemed like that was almost the point of your scheme, right? Was to be able to generate these different views. I see. Okay, so next question is about biometrics. Do you think biometrics are going to play a role in self-sovereign identity? And we're thinking about something like WorldCoin here.
Yeah, certainly. I think that is where there's also a lot of work, particularly here, because in these plain vanilla implementations, we are sort of, again, putting the trust on the user wallets, right, essentially, to store all this. And that's where biometrics can actually help, just like we see with other sorts of password management schemes that we have on phones. So I think that's a great combination. And again, there's some work in that space, certainly.
And are there any recovery mechanisms for self-sovereign identity systems if users lose access to their private keys? There's a lot of trust being placed on the users, but they may not be experts.
Yeah, again, a very valid question. So yes, I didn't get to present that in the talk, but we have a revocation mechanism in there. So essentially, you would register the revocation onto the ledger. And so from that point on, that particular credential is considered revoked. So anytime anyone queries the ledger, it would be apparent that that credential has been revoked.
Got it. And maybe one final question here, which is how does CredChain handle situations where a credential, maybe this is related, needs to be updated?
Right. So yeah, the cancellation part is similar, I guess. The updating, again, in that case, you would generate a updated version of the credential. And given that it's again on the ledger, you could sort of override the previous credential by having a pointer
So really
back.
same mechanism in a way. You kind of revoke and put in a new one. Got it. Great. Thank you so much for the talk and for taking the time to answer our questions. Really appreciate your time.
Thanks for having me, Bhaskar. All the best.
Yeah. Excellent. So next up, we have Christoph Niemann from AWS, and he's going to be telling us about the rise of autonomous commerce.
Hello, I'm Christoph Niemann. I'm Senior Blockchain Solutions Architect at AWS, and I'm helping customers building solutions on AWS. What I'm going to talk about today is the rise of autonomous commerce. Of course, we have all these blockchain agents out there, and they will need to be able to access the payment rails, if you will, of the real world. Currently, we have about 8 billion people on the planet. Of those are approximately 1.8 billion unbanked. So meaning they don't have access to a bank account. They can't use the traditional financial system. In blockchain space, for the longest time, we've tried to banking the unbanked, meaning we built a new financial system that even the currently unbanked can use because it's a permissionless system. They can just access blockchain and transact with it. But with the rise of agents, it might very well be that the largest unbanked population in the future won't be humans, but actually will be agents. We don't know the future number of agents, but it's probably fair to say that there will be lots of them. And all these agents will need to be able to pay for services to have access to a financial system. They probably won't be able to access the traditional financial system because, of course, agents are virtual. They can't do KYC. They can't can do AML with traditional banks or anything like that. They will need something else to use. And that is what we're using Web3 for. So with this confluence of agents and agentic workloads, and then, of course, Web3 as the payment rails, we have a really nice intersection there that we can use to make this autonomous commerce happen. Now, of course, at AWS, we prepare for that future, and we built a generative AI stack that has a couple of services that are specifically meant to be able to use Gen AI and also to couple them with agents. On our lowest layer, we have Amazon SageMaker and all our infrastructure like GPUs or specific Gen AI chips like Trainium and Inferentia, and of course, on normal services like EC2 that you can use if you want to build your own models. They are specifically meant for building new models, training models, and the like. On our middle layer, we have our Amazon Bedrock, which is a service that allows you to do inference based on foundational models. And with Bedrock, we also develop Bedrock agents, which allow you to build agents on top of LLMs. So these agents can use LLMs to reason, and then they have actions that they can use to interact with the real world, if you will. And then on the top layer, we have applications that leverage LLMs and foundation models. I won't be going into them. Just one example, Amazon Q Developer, for instance, is something that helps you develop if you're using Visual Studio Code. This talk specifically will be focusing on Bedrock agents because that is, of course, what will enable the autonomous commerce. Now, Amazon Bedrock, our managed service for using foundational models. Amazon Bedrock has a couple of things that set it apart. One is we have a choice of foundational models that are available through a single API. You can use Amazon Bedrock to try out various LLMs and then see which one performs best. And that all comes through one API that you're calling So you don't have to worry about the various models and their different APIs. You just use that single API and then choose whatever model you want. You can, of course, customize models. You can do retrieval augmented generation, so basically augmenting your model while you're querying it. And then we have agents that can use these foundational models to reason about and then do something in the real world. One thing to point out is that security, privacy, and data governance are essential for our services. And specifically, we aren't using the data that you're feeding into the model to train our models. Rather, that data remains private to you. The same with knowledge bases that you create for your agents to use. Those remain private to you, and we won't be using them for training our models. Now, Bedrock, I already mentioned it, has a choice of LLMs available. We have the AI21 Labs models. We have pretty much all the Anthropic models on Bedrock. Of course, we also have our own models, Amazon Nova, that you can use. And just pointing it out, Amazon Nova are the most cost-effective models that you can use on Bedrock, and a whole load of others. So whatever model is the right fit for you, you can choose that to use on Bedrock. The latest current edition, for instance, is R1 DeepSeek, so we have that available as well. Now, Bedrock is the underlying service that you can use for LLM inference, but you want to build on top of that to enable autonomous commerce. And for that, you actually need to be able to do something, not only do inference on knowledge that you've gathered, but rather act on it. And that's what Bedrock agents are for. They will enable you to not only reason, but then, of course, do something, call specific APIs, do anything with any other AWS service based on the outcomes of the inference. So Bedrock agents share the same features and properties that Amazon Bedrock itself has. So you have the choice of foundational models that you can use. You have memory, knowledge bases, and guardrails. So private knowledge for each agent, and then so-called guardrails that restrict the actions of an agent and, for instance, prohibit the use of offensive language and anything like that. And then, of course, on top of the quote-unquote normal Bedrock features, you have tools and action groups that allow you to act and react to the real world. We also built in trace, debugging, and observability. And a fairly new feature is the multi-agent collaboration. So now we can use different agents and let them collaborate. And there will be one supervisor agent that orchestrates actions between those specialized agents, so that we can really kind of build microservices, if you will, out of agents. What does it look like if you want to build an Amazon Bedrock agent? The first thing is, of course, you need to select your foundation model. And you can also test out various ones and see which one performs best for your use case. After that, you provide the basic instructions, meaning you really create the prompt for the agent so that it can use that prompt and do its inference. Third step is you select the relevant data sources. So not only the LLM itself, but any kind of knowledge bases that it needs that are private to the agent, or any external APIs that it can call to do ad hoc queries and get new data from the real world. And then finally, you specify the available actions. Those are really the things that the agent does based on the inference it has done before. Now, in the final part, what I want to talk about is what would a Web3 agent on AWS using Bedrock services look like? And I'll start out with our supervisor agent. With a crypto AI supervisor agent, that is, and its main purpose is to orchestrate various other agents that we'll pull in one after the other. What we want to create here, and what's also available in that GitHub repository that you see on the bottom right, is a Web3 agent that creates proposals for trades, for blockchain trades, based on the current sentiment that it sees in blockchain data. For that, of course, we need access to the current sentiment of various crypto news sites. So the next thing that we need is a knowledge base for this agent that actually holds the current crypto news as they come in, and that's updated continuously while new news are being generated. Of course, we will be using a web crawler for that crawls various news sites and puts them into our OpenSearch serverless vector store so that agents can use it to do inference on top of that. So this web crawler continuously pulls a couple of news sites and adds that information to the vector store, and then the knowledge base news crawler can use that data to query the current sentiment, if you will, about crypto in general. So that's the first thing that the crypto supervisor agent starts. It does a query via the knowledge base to get the current sentiment and to see if it should propose a query or not. After that, it very probably needs some more specific data that it needs to query ad hoc. There are two main sources for that in our example here. One is the AWS public blockchain dataset, which provides historic data about a couple of blockchains. And basically what we've done there is pulled all the data from the blockchains, stored it in S3 in an easily digestible format, if you will, so that you can query it via Athena, via SQL commands, and don't need to go via RPC calls to the blockchain specifically. Our little Lambda function in between there does exactly that. The agent provides the SQL to query the data source. The Lambda function sends it over to Athena. Athena processes it, queries the public dataset, and returns the results for it. Now, this is for historic data. So if we want to know which account held a couple of tokens at a specific point in time or anything like that, this is the path we're going to take. We also might want to query current data sources, something like the CoinGecko API or so for current prices. Our Lambda function can easily do that as well. It can also do external calls to another API. Of course, then it needs the API key that we first need to retrieve from the provider of these data sources. But in general, the Lambda function can query them. So now we have the current sentiment from our knowledge base, and we also have the current pricing data and the like, providing the supervisor agent with all the data that it needs to propose a trade. Now that we have the trade, we also want to actually execute the trade. For that, of course, if it's on blockchain, we need a private key. We have AWS KMS key store that we can use to store a private key, and that we can also use to sign transactions for blockchain. So now our Lambda function can create a transaction that proposes a trade on a decentralized exchange, gets it signed on KMS, and then sends it off to blockchain so that it's executed. Of course, we can also put some human guardrails in between there so that the agent only proposes a trade, and then once a human approves it, it gets executed on blockchain. The interesting thing here, of course, is the key itself never leaves the key store, is securely stored in there, but we can still work with it and have our agent sign transactions on it. And of course, with the private key in there, the agent has access to a blockchain account and can do whatever it wants with it. Now, one thing that's not yet in the repository, but that is fairly useful, is the X402 protocol. I did say that earlier for the Coinbase API, CoinGecko API. If you want to get current prices, you would need an API key to query them. So first, you need to register with CoinGecko to get that API key, then provide that to your agent so that it can do all these calls. With X402, of course, we can enable, or the providers can enable their website to accept micropayments. So by that, we would get rid of the API key, and the crypto agent could directly call the website for new information and provide payment via blockchain. So that is something very, very useful because it would enable a much smoother and more frictionless access to all these external services. If you want to try that out, AWS Samples Crypto AI Agents with Amazon Bedrock is the repository on GitHub that gives you access to a CDK script so that you can spin up these agents in your own AWS account. Again, it doesn't have the X402 enabled services yet, but all the other parts are there to give you an idea on how to access external knowledge or private knowledge sources, how to access external services, and then, of course, how to interact with blockchain. And that is probably what then will, of course, enable our autonomous commerce, because now we have all the actions available for agents, and the agents can pay for them. With that, I'm going to close. Thank you for your attention. I will be around for questions, and will be very interested in learning what you want to build with these tools.
Thank you, Christoph. What a very clear explanation of what's possible with Amazon Bedrock, and especially really enjoyed kind of the breakdown of the Web3 agents and how to go about creating them. So we have a few questions for you. So let me read them off, and feel free to expand even further if you need to. So the question, first one here, says, I'm a little confused by multi-agent architectures. A supervisor agent orchestrating other agents sounds a lot like a single agent, but with tool calling. Can you help me understand the difference and trade-offs?
So yeah, of course. The orchestrator or supervisor agent, if you will, its main purpose, of course, is to orchestrate different activities between all kinds of agents that you have. And the main idea that we followed there is to enable specific agents to be very specifically trained for their action that they want to take. So we have one agent that only does the trades and is really good at that. And then the next one is really good at interpreting all the knowledge that's coming out of the knowledge base. And we can have these agents using their own knowledge bases to then do inference on them and decide what they want to give back to the orchestrating agent. This is kind of the idea of that we have in traditional software development, if you will, of microservices. One tool for a specific job that's very good at it, and then you, of course, chain them together into some more useful activity. There is a very simple technical reason to it too. Of course, we could potentially create just one agent that has access to all kinds of different tools to do the exact same thing. But then the prompt itself would potentially get very, very complicated. And that is one thing that we want to avoid, because, of course, the context window is somewhat restricted. So you don't want to fill the entire context window of an agent with your one prompt. So that's why we want to separate it into different tasks and have different agents work on top of that.
So I guess the analogy here to the tool use is that these other agents kind of become tools for the supervisor agent in a way.
They do. The difference, of course, between just quote unquote calling an API of an external service that might give you some data is that these agents that are really acting as tools for the supervisor are proper agents, so they can do inference on their own, which is kind of a multi-step chain across the entire process. Mm-hmm. So that's the difference. Of course, the agent can just call different tools and access a database and whatnot, but it can do inference on its own, and that's what the supervisor then can use.
Gotcha. And I guess even from a design perspective, it's somewhat more scalable, because if you think of sort of additional agents you want to add into that next layer, it's easier to kind of scale that way.
Absolutely. And you can easier specialize some agents on something, and particularly even train them on different knowledge bases that you have. So one could have this knowledge base, the other another, and then they only have that particular knowledge base because that's relevant for their job. And they not all agents have access to everything.
Gotcha. Okay, let's get to our second question here. So it says, Can you explain a bit more? You mentioned this X402 standard. So what is it? Maybe a little bit about its history and background, and how is it enabling micropayments in this architecture?
So the X402 standard is based on the HTTP 402 code, which is basically payment required. And that code has been there for forever. It's not been used since day.
Yeah.
So it's just sitting there for future use.
Mm-hmm.
And now, of course, we have the technology to actually make use of it. Because, of course, with traditional payment systems, like credit cards and the like, it's really impossible to do microtransactions, 1 cent payments or something like that for an API call. There's just way too much overhead to it. However, now with Web3 technologies and fairly cheap transaction fees on some of the layer 2s, we can actually do very small payments and use them on the internet. So we could potentially pay for a single API call. That is much different from what we're using today. Today, we're using API keys for various APIs that we're calling, and we're paying them in bulk, saying $10 per month or something like that, and I'll have 1 million API calls or so. With these 402, I could do away with all of that and just pay for this single API call that I'm doing without needing to register first and having a proper subscription to the service and the like. So that's what this will enable, really making micropayments based on blockchain technology. The standard itself doesn't prescribe blockchain technology, but of course it's the most useful for it because it just enables this very low transaction fees for everything. So that's why I'm seeing great potential in it, because it is this missing Lego piece that we'll need for agents to be able to actually interact with value across the internet.
I see. So when we kind of integrate, these agents with Web3 platforms, one of the biggest sort of new headaches that shows up is key management. So, when you're coding up in this framework, is it fairly straightforward to kind of store the private keys that are needed for various steps?
Yes. So, I mean, the good thing about using, specifically if you're using Bedrock on AWS, is that Bedrock in and of itself is only doing the inference. And then we have all kinds of other services that you can use in conjunction or together with Bedrock. One of them, of course, is AWS KMS, Key Management System, which is a secure key store that you can use to store your private key. It basically never leaves KMS. You can use it to sign transactions for the most common blockchains nowadays. And even if you don't have that, we have tools for that, like trusted execution environments called Nitro enclaves that would enable you to do any kind of cryptography that you like. So basically what we are building here is a key management system that's entirely in our services on the cloud. So you don't have to worry about seed phrases, storing your private key on paper or anything like that. It's really all in these services that are really secure. So, and then of course you don't really have to approve any transactions, because you can enable the agent to actually retrieve the key, sign the transaction, send it off onto the blockchain.
Yeah, and definitely that's one of the biggest headaches, and so having tools to be able to deal with that is very, very important. Okay, so our next question here says, do you have any recommendations on how to select what model to use? For instance, are there particular types of tasks that Nova is really good at, and so on?
That's a really hard question, because of course it does depend on the task that you're trying to do, and it's hard to give a general recommendation. The really good thing about Bedrock is you can try them out. You can just use like 2 models or multiple models in parallel and see which one performs better. This particular example that I've showed, that is using Nova, and that's fairly good at interpreting what it sees on the internet from the knowledge bases. But I wouldn't go out and claim it to be the very best model that's out there. That really does depend on the use case that you're trying to solve, and just give it a try. Try out different models. most of them are available on Bedrock and easily selectable. So that's a good thing.
I imagine, users might also want to just do some testing of their own on different benchmarks and kind of get a feel for what's working well for them.
Absolutely.
Mm-hmm. Sounds great. Can you say a bit more about the knowledge base that is being used by Bedrock agents? Is it essentially a collection of free-form text materials, or does it already have some specific format or schema? And can it even be like a tabular database?
So it's free text data mostly, because of course it needs to be interpreted by the LLM and needs to be stored in a vector format so that it can be used for inference. That's what we're using in the example. We're really just crawling websites, taking the text from it, putting it into the knowledge base, and then inferring on top of that. Agents can also, of course, use numeric data, stuff like that, and just call an API directly, as we do in the example with the CoinGecko API for pricing information. But it's not something that we directly have in the knowledge base.
If they have data in this type of, like a tabular format, and they have some kind of intermediary software that can basically issue queries to that database and pull it into some text format, then you can use it at the other end, it seems.
Oh, yeah, absolutely. Yeah, that would be possible. And that's also something that we, again, in the example, do with our public data sets. Those are really tabular data. Those are really, you query them via SQL. And that's what we're using. We have this Athena service in between that's used to query the data that sits on S3, and then the agent can use it directly.
Gotcha. So there's some sort of text to SQL type of thing that might be happening there, I suppose. I mean, because the original question's coming into these agents format, and then they would issue the corresponding queries, or?
Yeah, exactly. So the agent itself has something like some query like buy me something in the price range of, I don't know, $10 to $100 or something like that. So that's a text format. There's text to SQL that Bedrock does. So it knows which SQL query to issue against the database, against our S3 dataset via Athena. It returns the result, has a current price, uses that information to then further generate a proposal for a trade.
Gotcha. The other sort of interesting opportunity here is to kind of create a universal interface to very different blockchain platforms, right? You've got such a range of different, some of which are just ledgers, some of which are running smart contracts, but even there with sort of a number of different ways. And it seems like one would have to design interfaces for each of those blockchains, and maybe they already exist. Are you also working on, are you aware of any efforts to kind of try and unify some of that kind of interfacing with the large number of different blockchain data formats that one might encounter, so that you can get it in a format that's friendly for the LLMs to digest and do something with?
You mean for inferencing and
I mean, just
pulling data out of the blockchain?
Pulling the data itself from these different chains, building those connectors, is that something that you're leaving up to the end programmer, or will there be kind of tooling to facilitate that?
I mean, there is some tooling around. I mean, obviously, we have some providers for blockchain data that work quite hard on unifying the data that's coming from different blockchains. It's fairly easy as long as everything is EVM based, so Ethereum and that ecosystem, because it's fairly similar. But then if you go to Solana or any kind of more complicated or different blockchain, it becomes much different. And if you go to Bitcoin, for instance, just compare Bitcoin to Ethereum, very different data formats. So there are some providers that try to do that. That can be used. We don't have it integrated into Bedrock or anything like that. So that is up to the actual developer to either build that on their own, because they have their own data sets and they might index the blockchains themselves and store it in some sort of format. Or, of course, use one of the existing data providers for that can give you that data in an easier to digest format, let's say.
Gotcha. And then, what you presented today, and that's already a huge, step over what's available, is kind of focused on using the LLMs to, let's say, analyze the data that comes from the blockchain, or maybe even take actions to go send transactions to the chain to be trading decisions, etc. Do you envision, maybe not through this particular platform, but kind of in the roadmap ahead, anything that would facilitate developers to actually deploy also code on chain? So whether it's smart contracts or kind of modifying some of what's on chain itself. So right now, Bedrock's focused on the intelligence at the edge, if you will, interacting with the chain. Can you imagine kind of efforts in the future that push the intelligence on chain as well?
As in inference on chain directly? I would love to see it. I do have my doubts, to be honest, because of course one of the defining features of blockchains is that it has to be verifiable across the entire blockchain, which also means that very many nodes recompute. And putting inference directly on blockchain would just put a huge burden on compute on the blockchain nodes. So it would be very nice to see, but I'm kind of doubting that will directly take place. What I can see more probably is that we still have some off-chain component that does the inference, but then sort of generate some sort of proof that we put on blockchain to make it verifiable, but not the actual inference. I don't see that on chain. It's just a too complicated computational job that you need to do as to do that in a transaction. But the proof itself, make the blockchain the proof layer, if you will, for various decisions, that's what I could see and I think will happen soon enough. Yeah.
That makes sense. Thank you so much, Christoph. Really appreciate your presentation and taking the time to answer our questions.
Thank you. Happy to be here.
All right. And now we're on to our first panel of the day, which is going to be the panel on AI for blockchain. That's going to be moderated by Anand Iyer. So I will hand it over to him.
Amazing. Thank you, Professor Bhaskar. Excited to be here with all of you today and excited to get this started. I would love to welcome our panelists on. So let's have them join us here today. Gilad, Professor Ashish, Christoph, welcome back. Christoph, you're on a roll today. You've been on nonstop. Do you want a sip of water or some tea or?
I'm good, thanks.
We just started getting warmed up. I was really curious to see how you're going to tackle inference on chain, and you left us hanging here. So excited for this panel. I thought to level set, and Christoph will give you a break, but I thought we could go around and maybe hear a little bit from each of our panelists on their expertise and experience here. I'm happy to get this started, and Gilad, I'll probably turn it over to you after. But thank you again, the Coinbase team, for having me here. I've been investing at this sort of crosshairs and intersection of AI and blockchains for a few years now, and I developed a thesis that for the longest time we'd heard about how where are some of the practical utility and applications of blockchains. And to me, as the AI tailwind started to become strong a few years ago, it felt like the primitives we've been building in the world of blockchains for a long time felt like the right antidote, if I may, for the centralized AI systems that are evolving. So I've developed an investment thesis around it, had the opportunity to co-invest a few times with the Coinbase Ventures team, but also excited to hear from you as some of the experts here and share some of your wisdom. So Gilad, I'll turn it over to you. We'd love to hear some of your background, what you've been working on at Coinbase, and then we'll turn it over to Professor Ashish after that.
Great, amazing, thank you. So I've been in Coinbase for 4 years now. I'm managing the machine learning recommendations team, and we're focused on content discovery, personalization, helping our customers kind of understand what's going on in this world, understanding the world of DeFi, identifying opportunities to trade. And I think, I'm very excited about the potential of AI to not just do kind of the traditional recommendations, but also help users kind of digest this world and simplify it and make it more trustable and enable new utility in crypto in general.
Thank you, Gilad. Professor Ashish, over to you.
Thank you. Thanks for organizing the panel, and thanks for inviting me. My research is actually not much focused on blockchains. I'm really excited about the application layer on top of blockchains. Things like decentralized finance, the design of decentralized exchanges, the smart contracts, the kind of new economic primitives that are being created. And on that side, AI tools are going to be really sort of determine how this market evolves. There are two ways in which AI tools are affecting things like decentralized finance. One is the same way in which they are affecting finance, because you can make predictions, you can use models to determine optimum pricing schemes. But the other way is, as we have these more complex exchanges, more complex smart contracts, more complex markets, many Uniswaps acting together, you also have this potential of these AI agents interacting with each other via the market. And because they're so complex, the kind of equilibrium conditions that you study, the kind of market behavior that's going to emerge, I think is not very well understood. And for me, that's a very exciting direction for research.
Incredible. Yeah, excited to dig in and hear a lot about your research as well. And Christoph, hope you've had a chance to take a little breather, but maybe just a level set for those of who are just tuning in again, maybe a little bit about your background and your work, please.
Mm-hmm. Yeah, I'm Christoph. I work at AWS as a solution architect for Web3 solutions. What we do, of course, at AWS is really provide the infrastructure for AI, Gen AI with Amazon Bedrock, as well as for Web3. So you can build your services on AWS using Web3 and using our key management services and using our nodes to run, to access a blockchain and the like. And I'm helping with that. I've been in blockchain for a couple of years and still happy to work on that. And with agents, I think now we have this final missing piece that we were missing for quite a long while to make blockchain accessible to, well, almost everyone, if you will.
Incredible. Thank you for those backgrounds. Let's dive in. I'll start with maybe level setting a little bit in terms of where we're seeing impact of AI within the blockchain space, right? And to me, it feels like one of the areas of the application space that's really truly shown product market fit has been decentralized finance, DeFi. So if this feels like the area that's most ripe for innovation when it pertains to AI, what are some examples of this that we're seeing today? Where do we see this impact panning out? And yeah, I'd love to hear, just to get the juices flowing, how you've been thinking about this. Professor Ashish, I'll start with you. Yeah, would love to hear your thoughts on the usage of AI or machine learning within DeFi.
So I think there are two standard ways in which AI applies. One is in the machine learning kind of setting, and the one is in the social choice style setting. In the social choice style setting, just the idea of how do you govern these systems is very exciting. New kinds of governance mechanisms are emerging with new kinds of DeFi primitives. And then on the more meat and potato side, the more decision-making side, when we think of things like market equilibrium, something as simple as the stock exchange has a continuous auction that's running all the time, and you have supply and you have demand, and they clear. And the assumption there is that most of the traders on the market are price taking. They take the current price and they'll either trade at that price or not trade that price. There's some people who are liquidity providers and they're saying, okay, we are willing to provide liquidity at this price or that price. But they're also sort of making this very discrete decision of a price that they're going to they're willing to accept. Now, you could also imagine a system where these agents are reinforcement learning agents. And they have this very complex long-term strategy. And so far, even high-frequency traders on, say, something like the Chicago Mercantile Exchange, they've been able to extract value from the market, but they've not been able to really affect the long-term trajectory of how the market goes. They're still optimizing for the short term. They're using AI, but those AI agents are optimizing for short-term profits. What if these AI agents are then making a long-term 3-year strategy? And then how does that, and there's not just one of them, there are many of them. And they're trying to also anticipate each other's strategy. And I think DeFi is where this idea is going to first come to head. Just because centralized markets such as the New York Stock Exchange, have many triggers and securities built into it to avoid this kind of behavior. They might call it market manipulation and clamp down on it. Now in DeFi, I think it'll be hard to rule out this kind of behavior. And this is the first time we'll really see in practice what happens if long-term, long-thinking AI agents are actually pitted in competition with each other to try to manipulate the market in ways that are suitable to them. And I think and there are no analysis tools for this. All this area has are impossibility results. You want to play any game over long steps. If you look at game theory, you ask a microeconomist, they'll say, well, this thing is like either hard to compute, S&P complete, doesn't have good game theoretic properties. But these things are now going to be here over the next few years. I think it's an analysis issue, but also a design issue. Just understanding how to design these AI agents to have these to avoid these worst outcomes. And just to set the context, I don't actually know how to do it. I think that's a proper role for academia. I mean, I hope Gilad and Christoph have solutions. We don't really have any solutions, but these problems are very exciting.
Yeah, thank you for that. And maybe to segue from there and to fly at a slightly lower altitude and try to see where this meets sort of like practical use cases. Maybe I'll start with you, Gilad. Curious, I think the current state of artificial intelligence today, as we know it through LLMs, through chat-like interfaces, obviously, these aren't very deterministic, right? And especially when you talk about something like decentralized finance, the probabilistic nature of these are not particularly reliable. Let's put it that way. So I'm curious, where do you see, between sort of like the academic nature and the research that needs to happen? Number one. Number two, we have seen the pervasive nature of bots in the world of blockchains for a very long time, which, to me, if you use the old school Unix sort of representation, these are like read write at best, but we need them to, be more, I guess, need to be able to think and react. And that's sort of where the agentic, where workflows transcend into agents. So I guess there's really two questions in there. How do we transform some of this research into what could be feasible, especially given the backdrop of LLMs that tends to be more probabilistic in nature? What do you think needs to happen there?
Yeah, I think so. Again, it's exciting, very exciting times to have these tools. And if you look 2 years ago, I think they were very non-useful to the world of finance and crypto, but now they're becoming, with the reasoning capabilities and the development with agentic flows, and they are becoming useful. And the first usage should be just to augment kind of human decisions. And DeFi is special here because it's open, it's on the blockchain, it's transparent, and simple kind of normal users can have access to primitives of finance that they didn't have in the traditional finance. So just having this ability to do more sophisticated things is both it's a benefit, but it's also a risk. And I think LLMs can help here augment a decision making in terms of simplifying narratives, identifying anomalies, and kind of alerting users to where things are happening right now, especially with the meme coins kind of market. A lot of the trading is following this story of narrative. So understanding narratives. So LLMs are useful very much in digesting large amounts of data and kind of highlighting areas where there is benefit for users to take action. Then we can take it to the next stage where this AI tools can actually take action on behalf of the users. And that's also an area where I think there is an advantage here, because DeFi is complex. There is so many different primitives. You have to bridge and swap and wrap, and like there is so much concept to wrap your head around, and a lot of approval of transaction. And then you do the transaction, and having an agent kind of simplify this story for you and explaining this to you and doing this for you. And then the last step is then, I think, how do we make this autonomous for you on behalf? Agent starts from the idea that it's an agent on behalf of something, some entity, to do something for them and be kind of their agent in the world. And I think automatic like management of wealth through all these different primitives, I think it's an area where AI can really help and really kind of extract the value of that DeFi promises. That was more of a promise and not as much as a reality so far.
Yeah. I had a bet with my friend as to how soon into this panel the agents will come up, and I think it happened within minute 12. So it's indicative of I think the excitement that we have, because it's a very practical way in which we think AI progression will happen, even when it comes to utility blockchains. And maybe Christoph, just staying on the same topic, trying to unpack the real practical implications of AI, whether it's the current flavor of LLMs or more vanilla machine learning as we've known it, within the world of DeFi. What are I would love to hear sort of your thoughts and 2 cents on how we see the space evolving today.
I think, well, I mean, there are the usual suspects, if you will. One of the problems that we currently have with LLMs is hallucinations. They just make up stuff, which makes it fairly hard. So if you were to give your wealth to an agent and then couldn't be sure that the agent doesn't make up stuff all of a sudden, that's hard. So that's one thing that we need to solve as a technology in general, of course. We need to guard against that and make sure that the agents don't make up something. That's one of the things. Then, of course, the other thing that will become problematic, I think, is there will be many, many agents. It's not just, there are already many humans, but it's still kind of manageable. If you look at agents, you can have just hundreds and thousands of agents per person. So there will be very many, and they will generate a whole lot of data. And we see that in the chatbots. They generate a lot of AI slop, stuff that's really not useful. Just today, I read a blog post from the Curl author who said they are getting all these bug reports that are obviously AI generated, and they don't help at all. They have to dig through them, try to understand them, and then it's just made up stuff. So that is something that we need to deal with. How do we make sure that we don't end up with all this noise, but we need to focus on the signal? And humans are much better at that than agents for now. On the other hand, agents, of course, can process this vast amount of data very, very quickly. And that's what where their main advantage is, I think.
Yeah.
So, yeah, need to deal with that.
No, thank you. That's plenty to start with. I wanted to touch on something you said, Christoph, and I wanted to start with Professor Ashish. If from your academic point of view, how should we be thinking about this? So, we've had this theory or this philosophy maybe for several years now in the world of crypto and blockchains, and we've talked about onboarding the next billion users onto the world of blockchains, right? And my bottoms up engineering mind, I couldn't quite wrap what that meant, because to me, these are distributed ledgers, and you wouldn't want the average user to care about Postgres or Mongo, for example, right? And why blockchains here? So now, on the other hand, agents as a UX, because some of these consumer experiences, as we know, we've figured out how to make it work, right? Whether if you're an average user and learning how to use a wallet or learning how to use some of these esoteric DeFi applications, they weren't for the faint of heart. But somehow we've made it work, and we've proven that it can work today. So I guess my next question really is around, maybe picking up on some things Christoph was saying around agents is sort of the UX layer, right? And I think we're going from this progression of humans managing these systems, and I think we've hit this local maximum, maybe asymptoted there in terms of how many daily actives or monthly actives, even if they're botted in nature, we've been able to hit. But maybe each user can now have thousands of agents that are stateful, that are persistent, that are long running in nature, that can do a lot of things for you. But maybe that's the steady state world that we need to get to. But what are the things that we will need to do to maybe, and I don't want this to be a leading question or lead you in a direction of an answer, but do we need to go from where we are or where we were to a stage of semi-autonomous state where we still feel like we have a sense of agency over these agents, to then progressing into, I trust this thing enough now that you can run with it and generate the best yield from you, whatever the case might be. So I guess there's some philosophy, some practicality in there, but I'm curious, where would you snapshot where we are today? And what are the things that you think you might want to see before we can turn over full agency to these agents so that they're, harnessing the best yield for us, for example? And I'll start with you, Ashish.
I think, there's an easy answer, and I'll start with the easy answer. we need to have some understanding of the alignment problem before we hand over autonomy of what we want to do to these agents. And I think the nice thing about agents acting on behalf of a single individual is that the alignment problem is much easier. The alignment problem is just, is this agent acting in my own interest? And you don't really have to sort of think of what society's broader interest is. And on the one hand, that might sound like I'm making an unethical statement, but that's a proper way for a platform to operate. You'll have these agents, and you have to just align these agents to act in the human interest. And then there's a platform, and it's up to the platform to be designed in such a way that these agents acting in individual human interests are not causing the platform itself to evolve in a way which is bad for society. So I actually think that this is, I'm glad you pointed this out. I think this is going to be an easier use case. Often when we do LLMs and we want to align an LLM, for example, you want to align Claude or ChatGPT, you want to align it so that it's acting in some broad societal interest, which is ill-defined. And I think what you're saying here is very perceptive. I do think this is going to be where agents are going to play a very strong role, especially in an economic setting. You're trading, and the interest of the individual might be easy to specify. And so the alignment problem might be much easier. Right now, these chatbots, AI agents, reinforcement learning agents, they're in a situation that they can do anything we want them to do. We just have to be able to specify what we want crisply.
Got it. Just to stay on the alignment problem, back to you, Ashish. How do you define alignment? How do we set the guardrails or the standards necessary for us to understand what this means? And at what point will we then realize it's becoming a problem, for example?
So, I mean, at a surface level, alignment is an obvious thing to say, right? Is whether the agent is acting in a way that's aligned with the interests of the person it's representing. The reason the complexity of the alignment problem comes in from the corner cases. You define a particular way in which you think, in terms of what you think the individual wants, but your model of the description is not sufficient. And so when a corner case arises, the agent behaves in a way which is very different from what the human would have wanted. And those corner cases are very hard to capture. And that's where the difficulty of the problem lies. How do you articulate the entire space of outcomes and describe for them what the user would want? And I think your idea about DeFi, the reason I think it's a great question, and this might be a great use case, is because in many of these economic situations, there might not be as many corner cases. For example, in the case of just trading, you might say that my goal is to maximize my long-term returns, but I want my volatility to be below a certain amount. And I think the easier it is for a human being to specify their own utility comprehensively, I think the better these agents are going to be in terms of representing our interests.
Thank you so much. Gilad, maybe turning over to you, and again, staying slightly on what might feel like a philosophical topic, but do we need a set of agents that are helping us stay aligned? Because, again, to Ashish's point, the corner cases, it's the 80-20 rule, right? I think the minute you slide into the 20%, that can, it theoretically could be devastating, but how do you think about, in permissionless systems, things like alignment and oversight? How do we define that? How do those act? And how do they have their own sense of agency?
Yeah, and so there's definitely many risks here, and not just from like misaligning agents, but malicious agents. Especially in the world where the transaction will be agent to agent, or there will be multi-agents that kind of interact. Supposedly on behalf of the user, but sometimes someone can inject a malicious agent that will kind of try to take your money, do something with it that you didn't expect, even though he promised to do something on your behalf. So I think that this is a point where blockchain actually can help, and all the concept that we developed for permissionless and trustless environment in crypto, like proofs and staking, maybe to give my money to an agent, the agent needs first to stake their money, to stake some assets, and then there is some validator, third party, that if there is a problem, they take those stakes away. So there is some concept that we developed in BlockFi to develop this world of trustless and permissionless that allows us to help to solve these problems of multi-agent alignment.
Brilliant. Yeah, you're absolutely right. That feels like these primitives are going to be put to work in some really interesting ways. And in like maybe more traditional game theory, right? We have these shelling points emerge where, if left to their own devices, these agents have to gravitate towards primitives that have been tried, true, and tested, and slashing, staking of these primitives that have been working, albeit in a more human context, for a long time. So it feels like a natural evolution for us to be like, hey, I'm going to put up this bounty, I'm going to put up this stake, and if I don't perform my duty, I'll get slashed. And it feels like a natural primitive. Christoph, from your point of view, again, just thinking about agentic experiences. I know you spent a lot of time thinking about data and blockchains and things of this nature. How do you see agents playing a role there when it comes to accessing index blockchain data, et cetera? And does this increase the footprint for utility of this kind of data in ways in which you might not have expected before? Or do you feel like you're prepared from all the infrastructure standpoint to be able to access this data and use it in ways in which you're sort of predicted?
So let me start with that. Of course, agents can use the data, and that's one of their main, it's their source of knowledge, of course. So they will need access to all this data. That is something that's grown fairly recently to much larger scale than we had before. This need for data and need for data across all these different blockchains. So that's also what we're seeing. There's many different providers now giving you access to that blockchain data. Of course, blockchains in and of itself have all the data stored in there, but it's really hard to query it. It's really costly, very computational intensive. So it's not a good source of data for your day-to-day business. So you almost always want to have the data in some sort of format that's easier to query. And that is something that's growing fairly recently, and has been quite a lot of talks about that. Now, of course, one thing that the agents then do is use that information and make decisions on, well, initially on behalf of humans and potentially later even autonomously. But one thing that I'm kind of thinking about now is, because the agents not only have access to all that information and can process it much quicker than humans ever can, of course, but also the blockchains itself, where the transactions will happen, get much faster. So Ethereum today has something like 12 seconds block time. Base already had 2, and now with Flashbots, they have something like 250 milliseconds. So 250 milliseconds to a finality of a transaction, that's way faster than humans can react on it. So one thing that I think we haven't solved as a space in general is, how do we deal with all these agents that can make decisions very, very quickly? And how would we avoid something like a flash crash on a DEX? That's something that's certainly in line with or aligned to the human that initially started that agent and said, well, maximize my yield. But in general, for, say, society or for the space, of course, it's detrimental. We don't want flash crashes across the space. So how do we avoid that while still being able to maximize utility for the individual agents?
Yeah, good point. Just to touch on this more and continue down this path, I'm curious, do we, in a world in which, let's say we're highly pervasive agent utility happening across the board, what are some primitives that we could rely on to think about things like reputation of agents, or when it maybe, I think there's a gray area, or maybe there's a sliding scale, alignment starts to look like governance or something in that spectrum. How should we be thinking about this? How should we be thinking about credentialing, or maybe attestations and things of this nature? And Ashish, I'll start with you again. The off-chain economic models that we've created to understand trust in a human-centric environment, how does that start to look different in a world in which agents are highly pervasive and operating on chain? Curious to hear your thoughts about that.
I mean, I do believe that there would have to be less emphasis on reputation in the traditional sense, and more emphasis on market design in ways that are more robust. And I think, of course, we can trust them in a computational sense, So the kind of work that's being described here, for example, there was a mention in the previous panel of how you could do inference or put the proof of the inference on the chain. So things like correctness, trust in a cryptographic sense, that an agent is doing what it says is doing. I think that's going to be enormously useful. But I think reputation is probably going to be sort of out the window because human beings will have a layer of indirection, so they can any kind of slight misbehavior that an agent is doing, because the individual is standing one step away from the agent. It'll be hard to ascribe that agent misbehavior to the individual's reputation. So I do think that we are going to go into a world that's less reputation based and more based on actually have computational proofs of verification, have more robust market rules, do more careful mechanism design.
I see. And again, Ashish, just wanted to stay on that for a second. It's that's a fascinating way to think about it. Is a world in which agents need to interoperate and communicate with one another. Let's say, hypothetically, I have an agent that's acting on my behalf, and you have one, and there's a discoverability problem. But once we've solved for that, how do we, let's say Gilad's agent is comparable to the one that you've developed. How do you see, an agent assessing the best fit for what it needs to execute based on the other agents that it has access to through, let's say, a registry or something like that? So I'm just trying to tease out, when you said reputation is going to be less important, market design will be more informative here. I'm trying to figure out how that might look in a practical sense.
I really think that at the very base level, I think it'll be the kind of things that were being discussed. For example, I really like Christoph's idea of putting a proof on a blockchain. It's going to evolve less. Reputation is sort of much more around history. Because you did something well in the past, I trust you to do something well in the future. It's because I'm going to think of you worse in the future, I trust you to do something well in the present. Whereas I think we can imagine something which is more like a REST API equivalent of reputation or trust. Everything that I need to trust you is encapsulated in this data packet that you sent me. It has all the proof that I need to know your intentions in terms of how you're going to evolve. I think that's going to be like a foundational primitive, and I'm really glad that like the people here are thinking about it. The deeper aspect of that which you mentioned is going to be very important, but unlike this idea of REST-based verification, everything you need to trust someone is in this packet of data. I don't quite have a good answer to the other broader question of how these agents are going to evolve. I think that's really going to be like a fascinating question to both be studied by academics and to be solved by practitioners.
Yeah. Gilad, what do you think?
Very hard problem. I don't have a good answer. I think, I guess the best answer I can say, I think we're not there yet. Like, if you just trust agents right now to do something on your behalf, you're going to lose a lot. And so we're going to learn. Like, things move very fast in this world. I think the reasoning, again, like from 2 years ago, is not the reasoning we have right now. And I think back to the point you made earlier, and Christoph mentioned around like AI slop, that a lot of time what the LLM generates is kind of like an average response. And we will need to build systems that kind of do this multi-pass on reasoning, where they kind of generate the slop first, then they make it your accuracy, then they call tools. Today, all of this is very slow, so it's not very efficient because we need to do a lot of like rounds of LLM calls. But in the future, I'm sure we're going to develop these new paths of new design, new architectures models where reasoning is built in, it's done in parallel, it's using tools, it's create functions on the fly kind of thing. I don't know. It's an exciting world, and we're not there yet. So I think we need to think about this risk. We need to design the markets correctly, but we have some time.
Thanks, Gilad. All right. Ashish and Gilad have spoken. Christoph, I think it's up to you now to come up with a solution. So we've got, I'm joking. Just to stay on this topic, curious to hear your thoughts on trust, reputation, and how we see that evolving over time. And, I might even go as far as saying, I think a part of this excitement behind this panel is that, in the discussions that I've had with many smart folks like you, is we're all thinking about these problems. And I think to your point, Gilad, like it's a hard one to figure out exactly what the solution is going to be. Sometimes we'll have to just see how these things play out to figure out how we might have to counteract it. But in the spirit of having a healthy discussion, curious to hear, Christoph, your point of view as well on trust and reputation.
I think, and Ashish, do disagree with me if you think I've got it wrong, but I tend to disagree that reputation won't play a role, and specifically so because I think the current LLMs that our agents use to make decisions are non-deterministic. So you can't really verify what they will be doing in the future. That is something that we're using in blockchain, of course. Smart contracts are out in the open. We can always verify what a particular smart contract will do at a certain point in time with all the conditions. We can't do that with LLMs, which makes it kind of very hard to verify. I mean, we can always generate some sort of proofs what they have been doing in the past and that they acted according to what their intents are. But then, of course, I think we need to use that information to build some sort of reputation on top of that we can use then to make future decisions if we want to use this or that agent. And I'm not entirely sure if we can just disregard that. I see all the problems that we have with reputational systems, and we see that in the human world, like, I don't know, reviews and the like. There's a whole lot of missing pieces and not working systems. But I think we need to have something in place, because otherwise, how do we predict what an agent will do in the future if not looking at its past actions?
Ashish, what do you think?
I mean, that's also a valid point. I mean, it's hard to have a good panel without some amount of disagreement. And so in that spirit, I'll maybe clarify what I was saying. I do completely agree on this one point, that it's going to be very important for these agents to have reputation. So individuals can assess whether to use an agent from this company or that company, or to use agent A or agent B. I suppose what I was trying to say is that if an agent misbehaves, the consequence of that agent misbehaves in relation to the system, maybe it exploits a weakness in the system. It's going to be very hard to take that agent misbehavior and go back to the individual and say, you are a bad person because the agent did bad things. And in that respect, I think the traditional way in which you think of reputation might get weakened a little bit.
Got it.
Okay, yeah, I see that.
Yeah, no, that makes sense. Fascinating to think about in a world in which, if it's agents acting with full autonomy, I think that's gonna be a fascinating steady state world. Maybe moving on to some more maybe interesting practical use cases, and I'll come back to you, Ashish, on this one as well. How do you think about AI helping us? Let's set the backdrop first, right? We've come so far with building solid security, observability, monitoring solutions in the world of blockchains. And in spite of this, the hacks haven't gone away, right? Like there's still exploits that tend to happen. And, the degrees of sophistication are only increasing because AI, it's like a cat and mouse game now. Because, obviously AI has made the ability for social engineering scams to, figuring out weaknesses or vulnerabilities in systems exceptionally, to target these and, to find the acute problems and tap into them very well. How do you think about AI when it comes to the development of smart contracts, the security of blockchains and protocols? Do you see that we're starting to trend in this direction where it can start to have an impact? And maybe for this, Gilad, I'll start with you. I know maybe this is something that's slightly in your wheelhouse.
Yeah. So AI is very good at code generation, code validation. And it's kind of one of the first use cases that kind of shows traction. And this is great for smart contract security, I think, in the sense that we can because it's so good at code. And the problem with smart contracts, I think, in general, is that there is not a lot of practitioners. There is not a lot of history. There is not a lot of kind of code bases to learn from. So, and because code is verifiable and because LLMs are good at generating code, I think this is a very promising area where we can take LLMs, fine-tune them. It does need kind of fine-tuning to this problem, giving examples and kind of help us develop smart contracts that are more secure, less vulnerabilities, and identify those vulnerabilities when they show up. So that will save a lot in terms of the process to generate more utility in crypto by like allowing more development, faster development of smart contracts in a more safe way.
And Gila, just to expand on that a little bit more, as much as you're able to share, how much of this, like whether it's LLMs, machine learning, or any variation, even like you mentioned, fine-tuned models for code generation of smart contracts, how much of this is influencing the work you're doing today at Coinbase on a day-to-day, week-to-week basis?
Yeah, so this is an effort we started, not specifically myself, but as kind of a sister team, kind of look at this area of smart contract validation and kind of strengthening security there. So it's very much in the early stages, but we're definitely looking into that. And I think the combination of kind of everything we built so far in terms of, or everything that was created so far in the world of AI and code generation and in RAG and using kind of a database of vulnerabilities, and then bringing also kind of using on-chain data in real time to kind of look at the smart contract, look at the history of transactions there, and kind of audit things on the fly. And those are areas we're investing in, and we think is promising, but it's very early.
Very helpful. Christoph, how about you? How much has AI impacted your day-to-day, and either when it comes to, obviously we started talking about security, and while using some of these LLMs for generating more secure contracts, but I'm curious if it's impacting any other parts of the workflow as it pertains to the work that you do on a day-to-day basis.
Maybe just going to that development of smart contracts first. I think there's two phases to it. One, of course, is the actual compile time where you're building these smart contracts, and AI can help a lot with that. Specifically, if you have fine-tuned model for smart contract vulnerabilities, it's of course much easier to create secure code. The other thing where LLMs and AI can help is, of course, at runtime, just monitoring the smart contracts and their interactions throughout the blockchain and identifying anomalies, and then raising alerts and stuff like that. So I think there's this twofold approach to it. One is helping while you're building the smart contract. The other then is while it's running and out in the open. So, and then again, what was the rest of the question?
Yeah, how does it impact your day-to-day today, you know, like the work that you're doing at AWS?
Yeah, I mean, it does help a lot with coding. You can't put it any other way. I mean, I would say what it does help with is giving you the code, all this boilerplate code that you always need. So if you're building out an architecture, it helps you quite a lot with all this lines and lines and pages of code that you need to write. And then, of course, it frees up time for you to think about the really hard problem, because that's normally not what the AI can solve for you. It can easily help with building all the surrounding infrastructure for it. But then if it comes to what is actually happening, what's the use case that you want to build, what's the process that's going to take, and what are the decisions that you need to make, that's what you need time on, what you need to think on, and where you probably need creativity. And the AI helps you free up time to do that, because it takes away all this boring stuff that you always need to do to just scaffold your infrastructure.
That's right. Thank you for that. Segueing and maybe looking ahead a little bit, crypto, has been one of the most efficient capital coordination systems. We've always thought of it as the most beautiful rails for transfer of money. And the CEO of Coinbase, Brian Armstrong, had mentioned some time back that every agent might have a wallet, and then they start to transact with one another. Payment starts to become more native. And recently with this X402 initiative, we're really enabling everything from microtransaction use cases to agents being able to pay one another. I'm curious, and maybe Ashish, starting with you, how do you think about agents as economic actors? What is, where does your mind go when you start to discuss this? Or, Is there, and of course, Stripe had some interesting announcements yesterday as well. So this is like highly topical, but I'm curious to hear your thoughts on agents and payments.
I mean, it's fascinating, the kind of things that don't exist today that something like this could imagine. Something as simple as an escrow. Escrows are so hard. You have to go to a title company, but you can have an escrow for every individual thing. Conditional cash, cash which is obligated by some things, cash which is just based on trust, stable coin. These things are fascinating, and I think they're going to change the world. And especially with an agent behind it, in some ways things become easier because these agents might be actually, in some ways, if they're simple agents, they're not doing very complex long-term planning, they might be easier to understand because they're going to be less behavioral aspects. With human beings in markets interacting this stage, sometimes you're not sure whether what you're seeing is their behavior as a rational individual or some kind of a panic behavior like a market run. And the fact that these are going to be agents programmed perhaps in a more predictable way would be fascinating. The other thing that I would love to sort of understand, and this genuinely is a question, it might seem like a leading question, but it genuinely is a question, because I know all three of you, maybe also for you, Anand, you're all experts in this. While this world is fascinating, what do you think as it possibly existing out of blockchains? What is the necessary, why are blockchains a necessary condition for this agent-based micropayment interoperating world to exist?
Fascinating question. Yeah, Gilad, maybe would love to. Yeah, thanks, actually. It's a great question.
Yeah, and one thought I have here is that is around actually not around DeFi, but around content and content publishers. When social happens, a lot of the value in the internet moved from people that publish content to social, and content publishers actually lost all this traffic, all these eyeballs that were coming to their website and kind of seeing ads and monetized on their destination, moved to social, and they lost it. And now that we move to LLM world or agent world and chat world kind of interfaces, that's happening again in a much more harder way. Like when you go to, instead of going to Google and then to the New York Times, you go to Perplexity and it gives you a summary of 5 different websites without providing any value to the content publishers. And I think what will happen, what we'll see is probably that these content publishers will start blocking agents or bots, so AI bots. They will not allow them access. The only way that will allow them access through this special interfaces for agents that has to be monetized. And in this world, micropayment is very critical. And again, I think blockchain is very useful for this world where it's permissionless. It's very small transaction. You don't need this kind of contracts between things. You just do a forward to call and you get the access that you need. Otherwise, you don't get it. And so I think it will just, the economics of content will kind of necessitate that, and that we do something around it.
Great answer, Gilad. Christoph, we'd love to hear your thoughts too.
Yeah, what I'm thinking is what we will need for agents is a permissionless financial system, which we currently don't have. If you do want to transact money today as a human, you need a bank account. You go to a bank, you do all the KYC, you identify yourself, you have a proper identity attached to you that is then associated with the account. And only with that account are you able to actually transfer money. Agents, truly autonomous agents, won't be able to do that. They obviously can go to a bank and open an account and do some sort of KYC, because they don't really have that identity as we have it as humans. With blockchains, of course, we have a permissionless financial system where everyone can start transacting. And that is, I think, the main advantage of blockchain for agents, because agents can just use it and they don't need permission of a centralized entity, so someone like a bank, to be able to use it. So that's why I think blockchains plus agents are such a good fit.
Yeah, I totally agree with you guys. And I think, Ashish, you bring up a very thought-provoking question. And if I could opine for a minute, I'd say, a couple of things. One, I think to Gilad's point, microtransactions, I think are a perfect use case. there are some limits that are somewhat maybe we've come to accept as humans, and on the other side with vendors and we interact with, on why credit cards need to need to be used the way they need to work, or how we've come to deal with ACH or SWIFT, what have you, which are very traditional systems. But the whole thesis behind maybe starting with like the very with Bitcoin, and of course now with Ethereum and other high performing systems, is that we can do transactions much faster, but without really capping the quantum of capital that needs to be transacted with, right? So I think payments, for that reason, it just unlocks a whole slew of use cases. And in my mind, and maybe this is the futuristic world, right, just to dovetail off of payments, there will be autonomous agents that I think someone pointed out there's thousands of agents maybe per user that are all interfacing with one another. And this is sort of like, maybe a vendor selling something to a human in India or something like that, where we may not have purview to what's happening, but it is happening. And I think these agents will start interacting with one another. And there will be some constructs behind it that will need to be verifiable and auditable. And again, for these, whether it's ZK or any other such technology, the fact that we can codify that these have happened, the perfect source to save these so that they can be verified at some point feels like blockchains. That's number two. And the third, this is again moonshotting a little bit, but the application space just gets opened up pretty drastically if we're not constrained by the infrastructure that we've built over the last 20 years that highly define the scope of Web 2 applications, right? And Christoph, I know you're obviously you're at AWS and you've seen all of this. I spent a lot of time in Azure, and so but these we had to solve a set of problems that emerged as we went through hyperscale mode in the 2005 2010 era, as mobile and cloud start to become very, very useful. And now I think we're starting to see some new paradigms emerge for which blockchains feel like the perfect solution for some of these. There are definitely worlds in which, within the confines of an enterprise, for example, these don't need to, there may be enterprise agents that operate, but they don't need to interface or use blockchains in any capacity. But left to their own devices, they will start to leverage blockchains more. And by the way, I'll also say one last thing, and I'll shut up, which is I don't think they need to interact with capital as the only form of exchange for whatever utility they provide. They might start bartering and things of this nature. And I think there's a lot of interesting research that's emerging in that area as well. So I might provide you compute in return for X and things like that I think are really fascinating. And so, or I might open up my content window for this, and in return you give me that. And so those are some interesting design spaces that get opened up. So that's my 2 cents. My 2 Satoshis. How about that? While we're here, I know we're coming up on the last 10 minutes here, and coming back to you, Ashish. I'm curious. We've had this construct on DAOs for a very long time, and the A in the DAO standing for autonomous, although it never felt like they were truly autonomous, right? They were laborious, and not to call flaw to what's been existing and has worked in some constructs. But I'm curious, how do you see governance or decentralized governance playing a part? What do again, in a world in which agents are highly pervasive, what do AI DAOs look like? What does voting look like? Do humans delegate their votes? Will agents start to act on humans' behalf to vote? Will there be more iterative decision making because these agents understand our agency? So again, just in the spirit of opening up where AI can influence certain blockchain primitives, I'm curious if you have any opinions about DAOs and how that might look different.
I mean, DAOs are fascinating as an exercise with different modes of governance. And then the variety of governance primitives that are being used are fascinating. But I would like to yield my time to Gilad and Christoph on this one, because I would love to understand. It's an area that's of infinite academic interest. I'm a little worried that I'll start to go down that infinite academic path. I would have to also understand what they're seeing happen on the ground. On the academic side, the things that are really exciting are models like really understanding models like liquid democracy, which is something like a delegation approach where you delegate your vote to somebody. And I feel like delegating part of your vote to this kind of an AI agent, or an AI agent delegating his vote to another kind of AI agent, just understanding democracy as a network would be a fascinating direction.
Christoph, curious, from a more practical, and by the way, Ashish, I think we really appreciate the academic color here. So please don't hold back. But also, to your point, Christoph and Gilad, we'll start with you, Christoph. How do you think about DAOs and how that might look different? Christoph?
Yeah, I think I think one of the problems that we've seen with DAOs is, of course, that they all rely on this human voting potential. People need to go in and vote for various proposals, and they get tired of it, so they don't do it. That's one of the problems, I think, that we faced with DAOs over the last years. Now, if we introduce agents that act on behalf of humans, that potentially can go away, because now we can use all these all these agents to vote for the humans and do that continuously. So that could give us a way of actually getting to a point where we don't have this detrimental or decreasing participation in the DAOs, hopefully. That's where I see agents coming in, to be honest.
Yeah. Gilad, how about you?
Yeah, I'm very worried about the alignment problem in this case. Like, how do we ensure that it's not just like, it's easy for agents maybe to maximize return over a long term, but there is just governance is much more complex, I think, and there is many cases where decision making in that form can fail. So I am worried about this, but I am very interested in the how do you coordinate agents to make a task, to do a task? How do we kind of bring a swarm of agents to do some tasks together? And I think this is today we find, I think practically we find that kind of more hierarchical structures of agent design, agentic flow design work better than kind of adversarial or competing ones. But it's definitely a very interesting area of this emerging coordination and debatings and rounds and voting. It's an area that will develop and emerge, and we'll see what happens.
Thank you. We've had a few questions come in from our audience, so I'll start to tee these up and maybe in some rapid fire format as we come to the last 5 minutes here. Ashish, we'll start with you. The question is, we've been talking a lot about LLMs. Are there any non-LLM machine learning applications developed for blockchains that you're familiar with and you can share?
So on the more academic side, even going beyond machine learning, if you think of AI as generally sort of also including things like inference and planning, there's this idea that if you want to do liquidity provision, can you come up with the optimum way to provide that liquidity, say, for example, to a stock market? And some people in my group have done this research where if you give any future belief on how the market will evolve. So, for example, it might be as simple as saying, I believe that these two prices of these two cryptocurrencies are going to evolve like a Black-Scholes market or are going to do Brownian motion. Given that belief on price evolution, can you design the optimum liquidity provision curve? And that kind of transition from beliefs to optimization is like a fascinating direction. And the other thing is even more basic. Just given a big block of orders that people want to place, can you find market prices that clear the entire system? And that's also not traditional machine learning, but it is definitely within the confines of what's typically thought of as AI. And that's also quite fascinating.
Thank you, Ashish. For Gilad, how is Coinbase's machine learning team pushing the boundary for blockchain technology? I know you touched on a little bit of this earlier.
Yeah, we touched about the smart contracts and verification and security. So that is definitely one area where we're investing and trying to improve kind of the space. The area of tools, a kind of every agent having a wallet and these payments and the 402 that standard that was released yesterday. That's another kind of, I think, innovation in that area to help advance the kind of blockchain. And then last, I would say financial reasoning. LLMs have been benchmarked on many various domains, including the financial domain. But I think we don't have yet a good kind of benchmark or how to evaluate if how LLM is doing in answering questions in the crypto space. That will need fine tuning. It will need collecting data sets and kind of developing this benchmark. That's another area we're looking into.
Got it. I know there was a question on some interesting startup companies that we're seeing emerge at this intersection. And Gil, I just wanted to segue from what you were saying. There's a couple of applications. There's a team called Chaos Labs that's created a, you might be familiar, a chat-like interface, a Bloomberg terminal, if you may, but for blockchain data. So I would say the whole stack, just to answer that question, that is being, is up for grabs in the AI blockchain intersection. Everything from agents, agent marketplace like virtuals, to all the way down the stack to reinforcement learning and putting, the proof of learning on chain using something like Jensen, to, decentralized inference networks, to data labeling systems like Sahara. I feel like the whole stack is being massively disrupted here. But if I had to really live in the future, I would say the application space for this is really uncharted territory. So I'm really keen on seeing where we go from here. So it's there's a lot more to come. And maybe, as we tee it up, like Christoph, I'll turn it over to you. Are there any areas that you're excited about, or things that you've been looking into that you want to sort of tease and leave this audience with?
So, I mean, the very obvious one is, or very near-term one that I'm seeing, is something like risk scoring, classification problems. It's also not really LLM-based, but of course it does help. And we can now use all that data that we have available, even blockchain data, to say, this is a good trader, this is a bad trader, this is a high net worth individual, stuff like that. So that's something that I'm seeing very, very soon. What am I excited about? Well, that's to come. I mean, we've seen that with DeFi, in the DeFi summer, all these financial instruments that we didn't think about before that came just because people started using it. And I'm very excited to see what will come out of it. Currently, we're at the very early stages of it, obviously, and just everyone is trying out their fingers, if you will. But a year from now, we'll probably talk something entirely different.
Indeed. Thank you all so much. I know we're at time. Really appreciate your time, and Coinbase team, thank you for having us. Professor Bhaskar, I'll turn it back over to you. Thanks all.
Thank you, Anand. This is such an amazing panel. We got such a rich variety of perspectives, from a venture perspective, industry perspectives, and an academic perspective on AI for blockchain. I think there was a lot to chew on there. Great. So now we're going to resume our individual speaker talks. We have Eric Reppel from Coinbase, and he's going to be telling us about how do we get towards an agentic internet with micropayments.
Hi, I'm Eric Reppel. I'm the head of engineering at Coinbase Developer Platform. Today, we're going to discuss a path towards an agentic internet. So a little bit about me. I was at Coinbase from 2017 to 2021, working on machine learning. I was the head of engineering at a crypto protocol. And now I'm back at Coinbase to lead Coinbase Developer Platform. And so I've done a lot of things at the intersection of AI, crypto, and the web. I've built a lot of agents, and generally I've formed a lot of opinions about the intersections of AI, web, and crypto. And so today I have a context, a belief, and a thesis for you. So the context is that the internet was designed for humans. My belief is, broadly, agentic usage of the internet is good. And the thesis is, by creating new standards, we can make the internet better, both for humans and agents. And so the internet was designed for humans. Way back in 1989, the World Wide Web project was released. And what actually was it? It was HTML, HTTP, and a www client, now known as a browser. Each of these is a set of standards for how computers communicate and display information to humans. You have Web 1, which is what was released back in the day. It's HTML, HTTP in the browser. It's read. It allows you to read websites and share research papers. And then you had the introduction of Web 2. So Web 2 allowed write on the internet. And this was things like JavaScript, Ajax, and JSON. But all of these are actually standards, and it was an evolution of standards that really was the difference between Web 1 and Web 2. And so these standards in Web 1, HTML for format, HTTP for transport, browsers for delivery, were followed up and evolved into Web 2 standards of JavaScript for interaction and scripting, Ajax for access, and JSON as a lighter format that didn't need to be shown to humans. It was just useful for computers. So the current web standards were designed for humans to operate computers. And now with AI, we're in a world where both humans and computers operate computers. We've gone from users being strictly a human to a user being a bot or a human. And user experience is still human-centric. And so why is it hard for LLMs to understand the web? Well, we've done all this work for humans to understand the web, but not for agents yet. And it's time we do that. This is what a human sees if they go to DoorDash. You have a nice human in the corner. She's actually using two computers at once. She sees like a robust, rich, a lot of images, a lot of data, a lot of like little details like star ratings and times. But what an agent sees or what a bot sees is just the raw HTML. And this is difficult. Like, this is a lot of information. In fact, I went and scanned DoorDash.com. DoorDash.com is actually 624,000 tokens for an LLM to process. And currently, Claude charges about $3 per million tokens. It costs $1.85 just to have an LLM read that web page. And the problem with this too is like that information, most of it is not very useful. Of those 624,000 tokens, maybe 1,000 of them are relevant. That's a 0.16% signal to noise ratio. It's pretty well understood at this point by anyone in machine learning that large language models perform poorly when there's a lot of noise in the data. I mean, you would too if only 0.16% of things your boss told you was relevant for your job, and you didn't know what 0.16% it was, you would also be bad at your job. And so you have this phenomenon where right now for LLMs to use the web, it's both expensive and it's low quality. No ML conference is complete without some novel equation. So my math here is expensive plus low quality equals bad. And you may say, Eric, like, why not simply use vision to have LLMs traverse the internet? And I was like, well, you now need a browser that renders web pages. You now need an image process per page. You need access to a vision API. For the LLM to operate that browser, you need to either have accessibility navigation or keyboard and mouse simulation for the LLM to actually interact with those web pages. And there's like 10 other things that I'm glossing over that are requirements for an LLM to use the internet that are not easy. And so it's not so simple to use vision. A lot of very smart folks are trying, and I hope they succeed, but it's not clear that they will yet. And the thing is that there's a simpler way, like as all web developers will tell you, like these patterns of like MVC or MVVM or any other like pattern for designing applications, all of them dictate that your data should actually be separated from your view. And so you end up with this thing where like this DoorDash website at some point has like a human or a computer understandable object that is used to populate that view. In fact, rendering a page is like very standard. Most of the internet for most of Web 2 looked like something like this, where you have a template and then you have an explicit render function where you push data into that template to fill it out. Really, the only difference between an API and a web page is, are you rendering the data as HTML or are you returning that data as JSON directly? And so the data is there. The files are in the computer. It should be simple, but it isn't because the incentive is not there. Value on the internet is gated. Value in the internet is hard to access because it's valuable, and agents can't pay. Payments, in my opinion, are the worst part of the internet. Payments are the most important unlock in the last 25 years. They're also by far the most human in the loop. Here we have a like standard credit card field. Like if you've bought anything on the internet, you've filled one of these out. This form has 14 fields. Granted, the repeated UX is better if you're, continuously shopping at something like Amazon or using Shop Pay. But your first interaction is a bad human experience, and it's worse for agents. And it's worse for a couple of reasons. Well, number one, agents don't have credit cards. Agents have to be really good if you're going to trust them with your credit card. And right now, agents are not as good as they need to be for unlimited access to your credit card. The unintuitive thing for folks who are getting into ML without an ML background is that the agents turn tasks from deterministic to probabilistic, as in they go from pretty much always happening unless a bug or something happens, to every single time you do it, there's a probability that it happens or that it doesn't happen. And that makes it hard for agents to navigate things like forms. And it blocks what I call the rise of dynamic agents. So what is a dynamic agent? Let's start with the opposite first. So a static agent is an agent with a static set of functionality, manually integrated tools chosen by its developer, capable of handling specific problems. And this is where we are right now. If you've developed an agent, you know that there's a step where you go and you select the tools and you write a little bit of code to integrate those tools, and then you give it a prompt, a system prompt, and then whatever prompt it's going to get from its user, and that's the way you build an agent. But a dynamic agent is an agent with a dynamic set of functionality, task-determined tools chosen by the agent rather than the developer, capable of handling arbitrary problems. And I think this is where we're headed. At least this is where agents probably should head if they're going to, evolve from where they are right now. So let's take an example. Let's say I have a prompt of make a joke that involves tomorrow's weather and today's S&P 500 price. This is a pretty simple task, but it involves two pieces of data that aren't in the corpus of an LLM. The LLM's training tokens simply can't know tomorrow's weather. That's not known when it was trained. So it needs to use a tool. And so with a static agent, step one is find the relevant tool for the weather and stock data. Step two is integrate the tool. And then the agent takes over, and the agent can use the tool to fetch the data and make the joke. With a dynamic agent, those first steps of finding the tool and integrating the tool can happen automatically. And you may say, like, doesn't MCP solve this? It's like, well, MCP is a step in the right direction, but MCP standardizes an access pattern, but it doesn't standardize discovery, authorization, or payment. So if you've written an MCP client or used like MCP with Claude or anything else, usually you have a config file that looks something like this, where you declare all the tools that need to be used. And you may say, like, couldn't you write a dynamic MCP client that discovers its tools? You could, but you wouldn't be able to use them. Most value on the internet requires payment, and agents can't pay. And so if you notice, like, each one of these tools requires an API key. These are actually just all tools from the MCP example repo. Every one of them that isn't a local tool requires an API key integration that a developer needs to do. Because right now, agents can't make API keys. And so agents are static. They can't dynamically choose the tools they want to use. And so why were we talking about web standards? Well, it's because it's time to evolve. It's time to start adding new standards to the web with AI agents in mind. So the place I think we should start is with payments. And today I want to talk about an open payment standard for the internet. So the internet has been aware of this problem for a long time. Back in 2014, 2004 would have been a long time ago. Back in 2014, in HTTP 1.1, status code was reserved for payments. HTTP status code 402, payment required. And it explicitly states 402, payment required, status code is reserved for future use. And that's all the information they gave, because they did not have a solution to adding payments to the internet. They just saw that one day we would want to do this. In fact, Mark Andreessen, creator of Netscape, said in an interview, so let's say hypothetically you want to have an online newspaper article, and you want to read an article in that paper, and maybe you want to have an economic relationship where you're paying for the information. One would think the most obvious thing to do is build into the browser the ability to spend money. But you may have noticed that that didn't happen. And so I think the original sin was that we didn't actually build economics, which is to say money, at the core of the internet. And I think the thing that's changed since Mark Andreessen's day is we have the technology now. And so I want to introduce X402, an open standard for payments on the internet. And so this demo I have here is doing exactly what Mark Andreessen said, of paying for content on the internet. And you'll notice that it really takes 3 clicks here, and we get access. And the funds here settle on chain immediately. The person hosting the website gets paid in real time in under 2 seconds to their account, to their wallet. And it's a really good user experience. It's just 3 clicks. There's no form. And the interesting thing is that I, as a human, can do this in a browser very easily. An agent that I write can also trivially do this. And so here's an example of an agent doing exactly the same request to this website, x402.org/protected. And all we have to do in order to let it make that payment is wrap an HTTP client with a wallet. The X402 standard does everything else. And so we go from 14 fields to 3 clicks or 2 lines of code. So X402 has 0 fees as a protocol. There's no percentage-based fee. There's no fees at all at the protocol level. You can ask for or pay as little as 100th of or 0.001 cents. I believe that's a 1/10 of a cent. And that'll go down over time to now enable even more native micropayments. It's HTTP native, and so it takes place in the HTTP requests you're already making between your client and server. It's blockchain agnostic, and so it works on Base, but in the future it can work on other blockchains as well. It's flexible enough for the future. It's extensible enough to handle more complex payment types over time and evolve with how we want to logically pay for things on the internet. But critically, it's a better UX for both agents and humans. So how does this work? Well, in short, blockchains have gotten really good over the last 5 years. Blockchains now have like less than 2-second confirmation times. They can take like tens of thousands of transactions per second, and they've become incredibly cheap to use, like hundredths of a penny in order to submit a transaction to a blockchain. And this means that they're ready for a bridge between blockchain payments and the internet. X402 is that bridge where it's a standard that helps the internet take advantage of this blockchain payment technology. So what is X402 at a technical level? Well, X402 activates the 402 status code and standardizes a JSON body to include in response. It standardizes a header containing a signature to include in requests that contains the payment. And then there's an abstraction for settling things on chain so that people who don't know about crypto don't ever need to touch crypto at all. And this means that you can adopt it into the HTTP servers you already have. In fact, there's plenty of examples out there of one-line integration where you literally need to write 1 line of code to start accepting payments in digital dollars on your web server or website. And the other thing that's really interesting and kind of was a verification of this thesis I have around dynamic agents is that it actually enables dynamic agents. So in this example, I have an agent that has 2 tools. There's one tool that lists an index of available APIs that you can pay for with X402. And then there's one tool that just makes HTTP requests. And so I wrote a bot that just has these 2 tools. None of these tools have like direct code that references or knows about the APIs that the agent may use. They're just generic tools. And then you can write a prompt where you say, make a pun based on the weather in San Francisco and the price of SPY. And what the agent does in this screenshot on the bottom right is it'll first check the index, see what tools it has, notice, hey, there's a weather tool, and oh, there's a stock tool. And then it'll make calls to each one of those tools, pays for those tools in line. It pays 1 cent to know the weather, 5 cents to know the stock data in the last 5 days. And then it can make a joke. It's not a very good joke, but you know, LLM's sense of humors are still evolving. And so that's X402. It enables dynamic agents. It enables 2-click payments for humans. And I think it's part of this growing set of agentic standards that we should be making in order to augment the web. MCP is a great start for format and transport. X402, I think, has the potential to be the standard for payments on the internet. And in fact, X402 works well with MCP because MCP is also built on top of HTTP. X402 seamlessly slots into the requests already being made as part of MCP. There's examples of this on our GitHub if you want to check that out. And so we said the data is there, the incentive isn't, but I'd argue if an agent can pay you money, you should let it. Previously, you wouldn't want bots accessing DoorDash because they might be scraping all the data that you have, and that data has value. But what if they pay you 1 cent to have access to the food that's an offer in San Francisco? If it's a cent or if it's 5 cents, there's some economic threshold in where you're probably okay with an agent taking that data if you're getting compensated for that. Maybe DoorDash isn't, but I think there's a lot of people that would be willing to have a bot take their data if they paid for it. And so the internet was designed for humans. Agentic usage of the internet is good. And by creating new standards like MCP, like X402, we can make the internet better for both humans and agents. And so I'd prompt you to check out x402.org. The full specification and all the examples I showed today are available on our GitHub, github.com/coinbase/x402. If you want to see what else CDP is working on, we have wallets, we have data APIs, we have lots of useful stuff for building in crypto, cdp.coinbase.com. And then you can follow me on X or Farcaster @programmer. Thank you very much.
Eric, thank you for a fantastic talk. I think it's really starting to crack this shell of how do we make payments on the web, and something I've actually been talking about for many years, and just that friction that exists on the web. Nobody wants to have like 500 subscriptions to websites to be able to read news. So thank you for that. We have a few questions. Let me get started with them. So the first question is, you've laid out a vision for what the future of agents and payments would look like. What do you think is the current bottleneck right now? And is it just the payments protocol, usage on the user side, agents not being good enough? What would it take for all of this to come together?
I actually think that we're in a position now where it's the sum of it's a bunch of little things rather than one giant thing. Like, I think that we're asymptoting to, like, we're not getting the 10x improvements model over model anymore on the frontier models. And then the internet being built for humans is ultimately, I think, another bottleneck there. And so I think if we really want a world of like artificial general intelligence or agents that are capable of doing multifaceted complex tasks across the internet, it's not just solving one problem, it's solving multiple of these problems. And I think payments is one that is like very obviously high friction and is, a remnant of kind of the traditional finance path that we've been on pre-internet. And so I think that that's, at least one place to start.
Maybe a quick question about X402. So how does it handle situations where you might need to have kind of a stream of payments? You're not just getting one unit of data. Maybe there's a sequence of things you're looking to get. Is it something that already can handle that type of a situation, or is it just a collection of atomic payments?
So I'll give you two answers. One, which is the state of X402 today, and then the second is, the future. As I said, X402 is designed to evolve over time. And so X402 right now, or X402 indefinitely into the future and as of right now, doesn't actually interfere with any of the other web technologies you use. And so if you have something like a user session management tool or like an API key that you really, really love, like you can actually just fund the accept payment with X402 and then have like a cookie or a session header that allows you to have like they have this balance and deduct traditionally. And so it doesn't break any existing web paradigms, and it doesn't force you to only adopt X402. It's purely an additive solution to reduce friction and allow you to get to like a micropayment per transaction cost. I'd add that you also can do like theoretically billions of dollars in money moved with X402. I called it the minimum, but I realized in the presentation watching it back, we don't actually call it, there is no maximum of value that you can send over X402. And so right now, if you're trying to do something like a stream of payments, like you probably want to pre-fund the payment and have funds and then have a credit system in the back end that you implement in any number of ways that currently happen. The second thing I'd say is that like X402 has this concept that we call a scheme, which is a scheme is like the logical way of representing a payment. And so the first scheme that we shipped was what we call exact, which is the most logically coherent scheme anyone would be familiar with, which is like, I have good, I want to, you have good, I have money, I want to give you money for good. And so I will pay you $5 for, the chair kicking around your basement on Craigslist or Facebook. And that's kind of the most obvious one to do. But this is like, what crypto enables is like truly programmatic money. And so you can do things like, hey, I want you to generate some LLM tokens for me. And so you may say, well, I'm actually not quite sure how much that's going to cost because I don't know ahead of time how many tokens you're going to generate or how many tokens you're going to give me. And so I'm going to say it may be up to $5, and then do whatever processing, basically get a hold of that money and the right to bill up to that amount, and then say, okay, I've done the computation. This actually cost me $1.26 to generate all those tokens for you. It was a big request. I'm going to bill you $1.26. But I, as the person processing the request, have some guarantees around, I can capture a certain amount of the value up to a certain point for the work that I've been doing. And so that's kind of the next scheme that we have planned. We call it up to. But you can imagine things like credits and other systems that you can evolve if you truly have programmable money. And so you could have something where it's like funds are put in escrow and then streamed to you as you do work. Would be an easy thing to add.
So the way you have this kind of everything kind of worked out in the schemes, would it be easy for some third party or just a user to contribute new ideas or new schemes to the framework?
Yeah. We have a set of policies and around what we need schemes to adhere to. So schemes, for example, shouldn't be able to move money other than what's been indicated by the person spending the money. And there's other kind of security and compliance things that we want to make sure happen. And Coinbase is providing like the auditing and legal analysis to make sure that schemes that are proposed fit those tracks. But we love contributions. If you have an idea for a scheme, create an issue on the GitHub, and would love to discuss.
Cool. So the next question is about, are there any alternative standards that you see as interesting in this space besides X402? Perhaps something that's complementary, perhaps something that's maybe very similar but different in some ways?
Yeah, there's a bunch of these that have been tried over the years. And I think even like 21.co, which became Coinbase Earn over time, had a like Bitcoin-centric payments on the internet kind of way of doing internet payments. But I think the thing that separates X402 is that it's about HTTP and integration into HTTP rather than trying to be about crypto and shoving crypto into Web 2. And so really like this strict focus on being a bridge from Web 2 to Web 3 versus trying to be a bridge for a specific blockchain technology, I think is what kind of separates it. But this is like I said in the talk, this is not a new idea. This is like, I think the current, in my opinion, the current best attempt to solve this problem that everyone has existed for a long time. But if there are things that can be improved about it, would love feedback.
There seems like there's also some coordination problem here, right? Which is you want to get enough people adopting it for it to be widely useful. Do you have a sense for why this take on it might be the one that succeeds?
Well, I think that's the why now problem. And I think the why now is because of AI agents starting to become good enough to do autonomous actions on the internet. And that bottleneck of credit cards being a real encumbrance to this concept of a dynamic agent that can perform any task rather than specific tasks you've written it to do. So I think that's kind of the reason as to why you will have like demand. This is a classic kind of two-sided market problem of like you need demand and you need supply. And so I think agents are a natural thing to introduce a demand for things like this and for us to explore alternate standards for payment. And then if there is demand, you have a big incentive if you're arbitrary companies to accept money from agents. You should let them pay you if they have money. And I think we have like 20 or so launch partners with X402 that have rolled out and integrated X402 in various ways to their products. So if anyone wants to help creating an agent that can pay with X402 or wants to accept payments in stable coins or other crypto tokens using X402, happy to help. Reach out to me on Twitter.
Fantastic. The next question is about vision models. It says the current generation of vision models has a lot of problems, but I'm curious why it seems X402 can be used with them. The same set of APIs should be possible to work regardless.
Yeah, you totally can use X402 in conjunction with vision models. I think my point is more that vision models that take a render of a web page and then try to click back and click buttons that exist in that web page or fill forms in that web page are low probability because they're non-deterministic flows.
Gotcha. And then the last question here that we have is, are there any unique challenges to building AI agents for Web3 compared to Web2?
I think there's like one or two minor challenges and then a lot of tailwinds for agents in Web3. And the headwinds are largely getting a wallet and funding a wallet is still difficult. And so Coinbase Developer Platform has a bunch of tools that make that a lot easier. And then the tailwind is that all of this is natively programmable and it's open standards and it's things you can actually write programs against. And so it's significantly easier to orchestrate different tokens or currencies or different methods of scheme because things settle in seconds rather than T+2 and are digital native versus being, a pile of faxes in the floor of a bank at the end of the day.
Very cool. Great. I think that's a wrap for this session. Thank you so much for your talk and for taking the time for all the questions.
Thank you, Professor.
Thank you. Excellent. We're on to our next speaker. We're going to hear from Ilya Polusukin about the idea of a user-owned AI model and how to get there.
Hello, I'm Ilya Polusukin. I'm co-founder of Near Protocol, and today I want to talk about the roadmap to a user-owned AI model. For those who are not familiar with me, my career started as a researcher, and I worked at Google Research leading natural language understanding and infrastructure projects like TensorFlow, developing deep learning models and systems. Now, I was one of the co-authors of the paper, Attention is All You Need, that introduced transformers, the T in ChatGPT, and really brought in kind of this wave of technology innovation in AI. Now, in 2017, I left to start Near AI with my co-founder, Alex Kiranov, and our idea was that we want to build a state-of-the-art models that would be able to write code on behalf of people. We thought that this is a massive enabler for everyone in the world where software is becoming more and more important part. Now, back in 2017, that sounded like science fiction. And as we know now, this is very much a reality. But it was early, and we didn't have enough GPU capacity. The models were not scaled enough yet. And so one of the things that we were trying to do is really tap into students around the world to create data set to train model on. We were trying to coordinate them to really write small tasks, write some code, write some descriptions, write some comments to generate this data set. And we had a very clear challenge, right? The students were from China, from Eastern Europe, from Southeast Asia, where there's different types of challenges with paying them. Students in China, for example, don't have bank accounts, they have WeChat Pay. In Eastern Europe, some countries require to sell half of the dollars that are arriving. And so we're looking for a solution that would really facilitate this global payments and coordination. And blockchain seemed like a very clear answer. But even back then in 2018, there was nothing that would really satisfy our requirements, something that was cheap to use, right, with fees that are below kind of what we're paying, way below what we're paying, and really easy to onboard new users and easy to develop. And so that's why we started Near Protocol in 2018 to really solve these problems and enable kind of this blockchain payments use cases, especially for AI, data labeling, and other use cases. So we're now here, right, in 2025, where it's pretty clear that AGI is almost here, right? We've went through a massive kind of innovation loop that keeps accelerating, where more and more kind of intelligence is packed in these models, and they're able to do more and more through tools and reasoning and other interactions. Now, it's really important that as this transition happening, right, and we already see it, not just impacting kind of day to day, but also research. 2 Nobel Prizes last year went to effectively AI, to AI researchers who built them. that whoever controls this AI will control everything. They'll control how you interact with computing, how you will see information, how it will be analyzed, etc. Right? And so it's important to understand that there's a massive paradigm shift that's happening given this AI from an aggregated and siloed apps and websites where we're using Google, Amazon, DoorDash to kind of navigate the internet, to agents starting to navigate on our behalf, right? As you're asking them or they doing things, to what we call an agent network, right? Where the whole internet transforms into just AIs talking to each other on our behalf, right? You can think of this as going from Google search to answers to agents taking actions. And again, whoever controls the models that are running this, whoever decides what data goes into these models, will control how those agents will be taking actions on our behalf, right? Our assistant will be ours, or it will be somebody's who is kind of renting it to us to maximize their own profit. And so this creates a lot of interesting questions. One of them is monetization, right? Right now, there's effectively two routes. One is you can have a closed source AI model that requires everybody to use that model, expose their data to that model provider, and effectively that, they are monetizing that interaction. Or you have open source where whoever built the model just opens it up and everybody can use it for free. The challenge is the open source is unsustainable, right? It doesn't have a sustainability model that would lead to continuous innovation. Now, AI itself has a lot of challenges. We have a challenge around energy consumption of the data centers, the ability for AI working on the data of the user instead of collecting all this data in data centers of the companies. You have challenge that model providers, only trust some data centers to host their models. And so you have global latency between the consumers who are sitting maybe around the world to access that AI. You have, and especially as there's multiple interactions and agentic flows, etc., that becomes very noticeable. We have obviously corporate security where corporations are blocking usage of AI because they're afraid that the data that their employees are putting is sensitive data and that will leak from the model providers. And obviously there's a general challenge of sovereignty where as a country, right, if you don't control your AI models and kind of what people are using, you may be losing your culture, you may be losing your choice, but more importantly, you may be losing even your GDP if that company decides to now turn it off for the whole country. So there's a lot of important challenges. And there's another obviously important aspect is safety, where kind of one of the big reasons for not open sourcing by some of the state-of-the-art model providers cited is safety, where people just don't know how these models will be used in the wild. And so it's important to also address this. And so the concept that we've introduced over a year ago is called user-owned AI. This is really about AI optimized for users' well-being and economic success, not corporate profits, right? Not trying kind of to contrast it with corporate-owned AI, where the AI is built to maximize revenue and profit of this company. And so it's a really different model. It very well aligns with kind of blockchain values and our general approach to how we believe kind of each individual should have sovereignty on themselves. But it also gives us a very clear kind of set of requirements of how to build the systems where, again, the meta function is to optimize for user well-being, not for a single entity corporate success. And so to make this happen, right, we need to make sure that all the interactions are confidential and permissionless, right? Again, right now, if you're using some model, you're effectively getting permission from that company to access it, and they're getting all the data that you're sending there. You want to make sure that access is equal for all people, right? And it's really hard because obviously it's very expensive right now to run these models, and so we need a new economic model which is allowing to power that. We need user ownership of assets, data, and choice, right? Again, kind of fundamentals of sovereignty to be within this model. So one of the examples, I'm looking for a car to buy for my family. I'm looking at the results. I don't know if this result's coming from statistical data, best information, or it's coming from advertisement, or it's in general being maliciously injected into the training data. So there needs to be a really important aspect there. You want to have kind of control of AI capabilities, like the safety that is equal for everyone, right? There shouldn't be ability for some people to access, one type of kind of controls and for others not, right? And they keep changing and requirements keep changing. You want to know how this model was trained. There's a really kind of, everything from security vulnerability, like there's this concept of sleeper agents where you can train a model to activate in a specific behavior at specific context, which is useful to, inject malicious code. And at code generation, it's useful to change and affect people's opinions. And that you also want that to understand what biases the model have. Model always will have bias based on the data it's seen, right? If it's seen, some information in training data many, many times, it will believe it more. And so if you don't know what training data that went in, you as developers build things on top, they cannot rely on if there's some specific bias or not, and we're not able to fix it. And so you want to know also what data keeps going, right, as it continues learning. So what this boils down to, user-owned AI needs its own model, but the challenge is it needs to be a state-of-the-art model. One of the things that users don't, take very lightly is trading, privacy, confidentiality, or user ownership for a shittier, worse experience. And so we need a state-of-the-art model that is built with these principles, where the user ownership put in the center and users are indeed kind of their well-being is maximized. And so we kind of need a verifiability of the data and model training, right? We need a process where we know exactly how this data went, like what data went in, how it was trained, and the outcome that we use is indeed the outcome of this process. It's important to understand that this has historically never existed, right? There's no process to enable this. We've kind of in blockchain have been looking for a lot of this, but it never has scaled to the levels where we need, right, for AI training and AI workloads. And so this is one of the challenges that we've been facing. The other part is it cannot be just that we train a model once, right? It's really important that this is a continuous process, that we keep having state-of-the-art model, not just do it once and then it effectively becomes outdated in a few months. But instead, there's a continuous research and improvements that keep coming into the model and stays ahead of the game, so people continue using it and continue believing that this is state-of-the-art. And it effectively becomes kind of, in a way, defense against all of the other approaches. So this is even harder, right? Because there's only a few handful of labs that are able to build this continuously, and they're built in a very centralized way, and kind of because of the centralization enable, knowledge sharing and reusing of the previous experiences. So one thing we've introduced at NVIDIA GTC earlier this year is the idea of decentralized confidential machine learning, right? So this is really kind of underpinning of how we would be building this. It allows us to have all interactions confidentially and permissionlessly. It makes sure that every single result, every single inference, or every single agent running is verifiable. We can allow any node in the world to join this network, right? To provide a local inference and local kind of serving to make sure to decentralize the energy consumption, reduce overall latency. We enable a new way of monetizing models where the model itself is encrypted and stored inside this DCML cloud. And so people can use it, but know exactly how this model was trained. And obviously supports training, fine tuning, and extending models in different ways. And, it should allow to create safety instruments over it to make sure that, if you're training a chemistry model, for example, for the next research innovation, then people cannot turn around and use it for something malicious. So it's built on top of a trusted execution environments. This is a kind of concept that existed for a long time, and it's really about a hardware module that kind of in modern hardware enables a way where even the hardware operator is not able to see what's happening inside. Now, from about a year ago, there's been a new kind of updates that happened both from Intel and NVIDIA that enable to have this mode with GPUs, right, with accelerated computing for AI. And so this is only, kind of about a year old concept that allows us now to run this for AI and machine learning workloads. This trusted execution environments naturally offer confidentiality, right? Because nobody can see what's happening inside, and so you can have user directly communicating with the system. It offers verifiability because you know exactly what code is running. Even more importantly, you know that only this code was run on this data. Again, this works with NVIDIA Hoppers and Blackwells to allow accelerated compute, and you can run arbitrary kind of CPU computation, data processing, agent workloads, tools, MCP servers, etc., on the system. So kind of this decentralized confidential machine learning really offers this cloud that combines blockchain trust execution environments with GPU and CPU compute to really enable this novel way to solve all these problems. Now, that is infrastructure, right? This is, we kind of replicating, think of it as what some of these AI labs have for their infrastructure, but it's not enough to actually get the state-of-the-art model. And so the really important part is how do we go from here to really kind of this continuous process of having the state-of-the-art model. And so it's important to go now and analyze what are the AI labs internally doing, right? Well, there's actually a whole flywheel of teams that are working together to really enable the kind of launch and iteration and refinement of these models, right? It starts with data acquisition, right, where you either scrape internet or buy data from different data providers or in different ways, acquire it from the user interaction. Then you do a whole process of data cleaning, where you're making sure that data is indeed clear, ordered in the right way, potentially with curriculum learning, where you go from simpler concepts to harder concepts, and then kind of ready for training. Then you have a whole pre-training process, right? This is where a massive amounts of compute are used to effectively condense all this data into the model parameters, right? This is the kind of the general pre-training process that OpenAI pioneered at scale. Now, you may have later a test time reinforcement learning where you really, training these models to reason, to have chain of thought, to refine their own answers before giving the final answer. And then you have fine tuning to then give it, specific instruction sets and give it how to respond to it, right? Going from a raw kind of, model that knows everything about everything to really become a useful kind of instruction following or agent following system. And then you serve all of this through inference to the customers and consumers to really then access it for their day-to-day, right? Which then generates more data that goes into data acquisition. So it's really a flywheel that continuously looping through, getting more data, getting more cleaning. Now, each one of the steps, and there's some intermediate steps as well, has their own team and has their own so-called benchmarks, right? A way to evaluate if what you're doing is improving the overall model. There's also a concept of scaling loss. So scaling loss is this idea that you can test everything on a smaller model, and if you see improvement in results on different benchmarks, you can project what's going to happen when the bigger model will be trained. And so this is a really important concept because it allows to effectively everyone experiment independently with their own concepts and then go and test it at a larger scale. So on data acquisition, right, there's a whole slew of things that people need to be doing. Everything from pure data acquisition, right, which in crypto we now have a number of projects that are doing kind of variety of data acquisition from socials, from broader internet, from news channels, etc. Keynote, Grass, to name a few. You obviously have user contributed data, right? So this is anything that users willing to contribute. User ownership doesn't mean we're not letting people to contribute back. It means we have some kind of economy for them to benefit by doing so, right? So if you're willing to contribute your data, you should be able to, get credits for using the model or in other ways participate with the economy. obviously there's a lot of data cleaning and improvement that needs to happen here, right? Which is very fast actually starting to become what effectively synthetic data, right? Where you're using a model, a previous generation model, to effectively process the data and make it better and make it more refined, or make the, the kind of data into a conversation or explanation, or removing any extra kind of tokens that are not useful for the model prediction. Now we go for pre-training, right? There's a lot of things that needs to happen here, and specifically around algorithmic improvement, improving training process itself, right? How you select, which documents to train on, how to update parameters, etc. And importantly, how do we actually do decentralized training, right? Again, there's a number of teams working on this, Prime Intellect being one, Noose being another one, kind of really showcasing what can be done in a more decentralized fashion. Now, specifically, decentralized training, what we can enable is using decentralized confidential machine learning is a new way to make sure that it worked correctly, right? Because right now, one of the challenges is, let's say you're training on decentralized cloud, anybody can join and send malicious weights, malicious updates. And it's really hard to, if somebody's really trying to screw with it, it'll be really hard to detect that. And so in this new paradigm, using trusted execution environments, we can effectively run training inside the TEs. And now there's no way to kind of attack that system, because weights are only updated when the there is a certificate from the trusted execution environment. Now, even more interesting, kind of traditionally when distributed training is done, everybody has either a copy of weights or some part of weights, and then they can effectively collect it together and open source the model or use it for free. And this is challenging if we want to build a sustainable model. So instead, again, we can train it inside this decentralized confidential machine learning in such a way that the model weights are never seen outside by any party, right? So they stay encrypted when they're traced. And so now you can actually monetize the usage of it, even if it's used on somebody's own hardware or in this cloud. And you still know exactly what went in, what data went in, what code went in. So you still get all of the really properties that you want from open source, but you still need to pay for monetization. Finally, you have fine-tuning and post-training, right? There's a lot kind of different approaches. There's also different sub-problems that people can be taking to optimize and kind of create specific models for specific use cases. So how do we actually do that, right? This is a lot of work, and there won't be kind of, we don't want to build a single lab, right, that competes with other centralized labs, right? We want to really tap into the overall kind of wisdom of the crowd, skills, compute, and intelligence that we have in the world. And so I mentioned that even inside one lab, each team works on kind of their own sub-problem. They have benchmarks to really make sure to understand how this will impact the overall model and overall results. And so the idea here is really use the same model, but instead of having a kind of one team per problem, instead we have a competition for each of the benchmark, right? If people want to come in and create a different data preparation process that is better than what everybody else is doing, they can effectively submit that code, again, into the trusted execution environment in such a way that nobody can see the code that they run, but everybody can apply and run it and then benchmark it inside that system as well. Now, one of the challenges historically with benchmarks have been that everybody over-optimizes with them, because as soon as you can, run this yourself and you can see the results, you will be able to, kind of even potentially train on it or in some way engineer data to make it better. And so, again, because we can actually run benchmarks in a hidden way where nobody, even creators of this benchmark, may even see the data that's happening inside here, we can now actually create a system that's foolproof and bulletproof from the adversarial perspective. So we're really combining what's already done inside these labs and really opening up effectively this competition model, right, which is blockchain's kind of native component, right, where everybody's competing for the reward to leverage that to create kind of for each component the best result. And then we can, people can leverage whatever the previous stage's best results right now, build on top of it, and kind of keep circling through that flywheel. Now, even more interesting, you can actually create a market for inference where you have different models, different fine-tuned models, etc., that are betting to resolve somebody's request or query, especially for reasoning or for image generation. And this way you also create a market dynamics for people to build better models, specialized models for different requests. So I'll just finish on this idea that user-owned is extremely important, right? And it's going to be, from my perspective, existential that we build it in such a way where users are benefiting, and the control is actually decentralized and distributed among all of the users, not few organizations. And so we really need it to win. And so I'm really kind of arguing for everyone to really join forces in the blockchain ecosystem to build this user-owned AI system. Thank you, and I'm open for questions.
Thanks, Ilya, for a great talk. I think you really, touched on a topic that a lot of people would resonate with. Ultimately focusing on user well-being. So we have a few questions. Let's go through them. So the first question is: you mentioned the importance of decentralized confidential machine learning for both training and inference. But if we look at kind of the current generation of trusted execution environments on GPUs, they're kind of not so complex, and they require actually a lot of computation. What are some engineering or scalability challenges that you would face in making DCML actually viable for large model development?
Yeah, so just to note, right, and we have a paper on this, at the current stage, the overhead on running a single GPU model inside this confidential mode is up to 10%, so 2 to 10%. So it's a pretty, like reasonable overhead for getting confidentiality and verifiability. Now, so far, up until, I think yesterday or day before yesterday, you could only run a single kind of GPU like at a time, and you would need to proxy data through the CPU. This is actually being solved right now. Kind of Fala been making amazing progress on this. And then with the Blackwell's coming to market and becoming more available, they actually going to offer confidentiality on the cluster level. Okay. And so with that confidentiality on the cluster level, effectively using their nickel and InfiniBand system, we actually can then train models in fully confidential way and fully verifiable way. And so that will really unlock this kind of global training where you can have not just individual GPU machines, but actually full clusters joining and kind of verifiably training models without revealing the parameters that they generated in the result.
Fantastic. So you're really optimistic. We're already more or less at the cusp of being able
to... I mean, it's effectively like throughout the next 12 months, I think we're going to solve all the challenges. So like, I mean, this technology, to be clear, like only became available 12 months ago, right? And kind of people have been figuring out how to build this. So like there's only few teams that have been pushing the envelope here, and it's really exciting to work all together on this.
Fantastic. The next question is: you made a strong case for the need for new monetization models, right, to be able to sustain OpenAI, open user-centered AI. Let's be careful here. Could you elaborate how this model would balance not just accessibility, but really sustainability, especially when the training cost, the inference cost, actually quite high for these large models, especially?
Yeah, I think there's two aspects of this. One is, I mean, the training cost has been going down for a few reasons. I think synthetic data have been really helpful, allowing to train models. There's, kind of using RL for reasoning, fine-tuning, and generating reasoning traces that then you can train on. But it's still very expensive. Now, if you compare, how much, for example, Ethereum pays for the security budget a year, you can definitely train a lot of models for that amount of money. If it's streamed to effectively for compute. So I think blockchain, like if you think of this as effectively community goods, actually has the capability to fund this kind of initiatives. And then the important part is that the resulting outcome should be monetizable, so it actually pays back people who kind of put in capital, and so you can keep recycling. And so this is kind of an important part. What we're solving here is really this idea that you can train models which are community owned, right? So community kind of contributed capital, contributed work, contributed data, but the result is still community owned, right? It's not just open source and now everybody can use it for free, but actually it's community owned and monetizable. And now you can have a revenue stream kind of feeding back into the people who contributed work and capital. And so I think that's a sustainability part, which effectively going from, okay, you need to have a company to build these models, to actually we can have it as a protocol, as a DAO, as a token, kind of whatever the mechanism we decide, but it effectively has the sustainability system.
I mean, so this leads nicely to the next question, which is, if you have a community ownership, you also need a governance structure. So how would you imagine that working out in this setting?
Yeah, so I mean, obviously governance is a whole its own topic. And we have there's a Stanford governance conference on the weekend where I'm presenting more on that. But effectively, you need the governance, and like I think this is actually how we're going to be solving safety going forward, right? Is really by governing as a community, not as somebody single-handedly deciding today we're going to ban this, tomorrow we're going to ban that. Now that requires a lot of kind of tooling and work, probably specialist delegates who can effectively impact the model and provide the requirements. But the benefit again of this system is that all of this are visible, right? You have a trace of decisions and kind of how they were made, whatever training data or restrictions. Hey, we don't want model to respond how to design bombs. Like that requirement is like clearly logged, and everybody can be like, okay, I accept using this model with this restrictions, which again right now we're not getting. And then the other part, which again, join for that talk, is about using AI in governance itself. So people have a lot of sometimes challenges with principal agent problem, and so really using AI as well to kind of represent and be representative and in help in making decisions will be important.
Fantastic. I think that might be all we have time for at the moment. Ilya, thank you so much for both the talk and taking the time for these questions.
For sure. Thanks for inviting me here.
Really appreciate it. Thanks. Great. So now we're on to our next speaker, which is Professor Xiang Ren from USC, and he'll be telling us about the API privacy paradox.
Hey everyone, I'm Xiang Ren. I'm the Associate Professor of USC Computer Science Department working on model security interpretability, and I'm also the co-founder and CEO of Sahara AI. I'm glad to be here today for sharing my work on the API privacy paradox. Specifically speaking, I would want to share with you how language models, APIs, actually can unintentionally reveal the model details. So I'd like to start the presentation with a very interesting analogies here, right? The point I'm trying to make here is that system outputs actually, in many times, can reflect the underlying structure of the system. And one nice example we have seen these days is like Dewey and Ellipse scientists observe the structure of the corona, which is the scalar of the atmosphere, to actually study the magnetic topography of the temporally hidden sun. Right. In this example, if you switch the key factors here into these days what we're familiar with AI, we can see that actually we can observe the model's API outputs to actually infer the hidden information about the language models. And here, basically, model API becomes a gateway that hide a lot of information that we don't know to protect the model security, but actually we found out it can also release some information about the model itself. So in all, the model API is the key to security, accountability, and verifiability. Another example we can reference here is that for people working security and cryptography, we know public key crypto system allow secure and trusted communication. And the question we have these days about AI system is that, can we actually design a similar system for secure and trusted language model deployment? So in this talk, I want to share with you our insights and findings around a few questions, right? Number one, what do language models APIs actually reveal about a model? And how can we trust the language model APIs down the road? What useful features can these API protected models keep without revealing the sensitive information? And eventually, how can we verify the source of large language models output, which can imply a lot of useful practical deployments and technologies that sits on smart contracts and blockchains for decentralized AI systems. So a little bit quick tutorials about large language models, right? So basically, large language models consists of a bunch of transformer neural network layers. Basically turns and discrete input, which is a sequence of tokens, into a sequence of continuous values or an embeddings edge of dimension D. And then at the end of this sequence of transformer dense layers, usually we'll attach a language model head, which basically conduct a linear transformation using the matrix W, turning the hidden embeddings of the dimension D into a logic vectors of a dimension V, where V here is the size of the vocabulary of the language, which then go through the softmax functions that turns everything into a probability vectors of the same dimension V. Now, what we're facing today in the entire sort of AI industry is that lots of like a big foundational model or language model companies such as OpenAI, Meta, and Google, they actually hide a lot of model details, informations to protect their business, especially the monetization opportunities, right? And such secrets usually include model parameters like the language model heads and the hyperparameters like the embedding size of the entire model. And I want to also say a little bit more about what the API protected models usually have as the assumption, right? Typically, there's two things we can obtain and sort of leverage. One is most of the mainstream APIs from these like model companies, they allow you to have access to top K log probabilities, where the K is usually like 5. And then they also allow you to use a function called logic bias, which allows the user to actually boost up the probability of specific tokens in the vocabulary to push them into the top K position, right? For example, you can add 100 of the logic bias to push any arbitrary vocabulary into the top K. Now, in our recent work from Column, we actually found out a very efficient algorithm that can allow you to get the entire log prop over the entire vocabulary space on an API call with a very efficient way, right? So the algorithm, I won't go into detail. Basically, they will partition the vocabulary into sets of K tokens, and for each set, you can query the API with a logic bias function, say plus 100 on each token, and then you can record the bias logic prop P prime. And then you can use this formula, which being sort of derived in the paper, that actually can turn that biased log prop P prime into the original unbiased log prop P. So now you basically can use this algorithm to obtain, in a very relatively efficient way, the original log prop, full log prop of any given input. And from the table at the below, you can see the cost estimations for running this algorithm or this procedure for a GPT 3.5 Turbo API. It would take you about 20,000 API calls for a given input, which is roughly speaking $400 to actually derive the sort of a full log props that can give you a lot of useful model information. In the next few steps, I'm gonna share details. For example, in one thread, we try to use these full log props derived from the algorithm that we mentioned before to find the hidden size of the embedding space of the ChatGPT or GPT 3.5 Turbo. A little bit background about this, right? For example, right now we are assuming a bunch of hyperparameters about ChatGPT, say the hidden size of the embedding of the last layer or the language model head is D, and then the vocabulary size is V, and then the embedding matrix is a W matrix, which is V by D dimension. And then for V hidden states output, we assume is H. This gives you the matrix H, which is a D by V. And then for the V logic output L, it gives you the sort of a matrix L, which is like a dimension of V by V. And we can tell that the matrix L, since it's composed of V multiplied by H, is actually have a lower dimension D here. So then what these enable us to do is actually you can apply the sort of inverse log-soft max to the log props that we get from the logic L. And then you can actually use these like sort of values to check when the the model's sort of a singular values is dropped dramatically into a lower value, as you can see on the right top side, and that will give you the rough sort of values of the hidden embedding size. In this case, we conduct a sort of simulated experiments first on Pythia models, which is an open weight model that we can verify the effectiveness of the method. And we can actually successfully find out that for Pythia 70 million, the hidden state size is actually 512. And then for Pythia 410 million, the hidden state size D is actually 1024. So we run the same process on GPT 3.5 Turbo and figure out that the singular value drops happens around 4,096 to 4,650. And that's roughly sort of much smaller than the sort of the hypothesized size of the GPT 3.5 Turbo back then. So we have actually very interesting discussion and communication with the internal people from OpenAI when we're trying to verify if this D is estimated correctly for GPT 3.5. We never got full confirmation given the sensitivity of the model, but we do get sort of interesting acknowledgement that if we are able to hide this value D from our paper, then they will be able to actually confirm this value, which we didn't do that. So now, what else we can do actually to achieve more exploring more model detail informations using the full log props information that we derive? One thing is that you can actually create, recover the column space of the hidden matrix W, which then will be very useful to turn that into a sort of a model signature or model fingerprint that can be used to identify which model generate and given output that you observe in the wild. And this is also down the road will be great sort of tool for auditing any potential changes in an API protected models that deploy online. And then you can actually use this to do interesting integrations with smart contracts on blockchain to create a sort of a decentralized auditing system. So here we show a table of like what's the interesting properties changes of the model and the interpretation of it, right? For example, if a model doesn't have any logic changes and no image changes, given we have obtained the column space W and then the logics, then it means there's no updates to the model at all by the model provider. But if there's a logic change without any image changes, then it might imply there's some changes on the system prompt or the hidden prompt over these models without changing the model parameter. But if there's like an image changes, then there means like there are some model updates. Either it's a low rank adapter updates or it's a full fine tuning. So there might be a question about what could these model providers do to mitigate people using these techniques to steal the model details informations, right? But I rather like to encourage the community to think about how we can turn these technologies described here into a more like an open auditing mechanisms or system that is agreed between the model providers and the model users, right? And I want to give you a few assumed situations and the pros and cons of each situation, right? So if, for instance, the model provider can actually stop providing the logic bias functions, which enable these efficient algorithms of recurring the full log prop. This is very disruptive to the sort of ecosystem, right? Meaning that there's no way for the user to actually manipulate the token probability, but it's also able to prevent attackers entirely for obtaining a full log prop output. But I think this is kind of too much of a trade-off to create a lot of inconvenience to the user community. And then the model provider can also entirely remove the log prop information from the API output. But the caveat is that actually there's a possible algorithm to still derive all of the full log prop information, resulting without actually accessing the log prop. But it's just a much more expensive process. So I would say, theoretically speaking, removing log prop from API creates a huge inconvenience and sort of a blocker for the user community. But it doesn't actually entirely stop the attacks. So it might not be the best strategy to do. And then there's a third option for the model provider to consider, which is changing the model architecture. Basically, there's assumption made on the linearity of the language model head, which allow us to create this like a full log prop recovery algorithm, and also allow us to recover the column space of W. But if we change these linearity assumptions about the language model head, then no attack is possible. At least it's not under this current algorithm. But again, changing model architecture is a huge investment, and it's also high risk and very expensive. So we'll keep this option open and see what's coming from the model developing and provider companies. Now, just to zoom out a little bit and think about a question, right? Since we are able to really create and recover these hidden matrix W's column space, it actually meaning that we can extract the language model's image. And is that actually more of a threat or more of a benefit for the entire ecosystem of the foundational model? I would say language model images can actually enable trust between the providers and clients, right? Because eventually how harmful it is for us to leak the hidden size or the other hyperparameters about a model, really. I think the discussion is more involving to the business model and monetization perspective of this large model. Oftentimes, we know model companies are giving the sort of user community some sort of expectations about the size of the model, so then they can justify the cost of using the model, which then translate to sort of the per token dollar cost when you're using the model, right? But if this information is not transparent to the user community, rather they are actually creating a big mismatch between the sort of public known sort of expected information about a model specs, like the hidden size, versus the reality of the model size. If there's a huge difference, say magnitude of difference, then this means they have a huge potential margin on how much they can profit from serving the model. And this at the short term might be a very beneficial things for the model provider company, but at the longer run, when more competitors catch up on the model capabilities and sort of infrastructure, these gaps will very quickly disappear, because there's open model, there's a better model or comparable model that are costing much cheaper price. So the advantage wouldn't keep long. So rather, I think at the long run, it's more important for the community to think about how to leverage these informations to actually provide a more transparent and trustworthy sort of an ecosystem. Now, what we continue in doing along this line is to go in deeper into the language model, right? Rather than stop at just the language model head and the last layer of the language model, we actually want to dig deeper to see if using the full log prop information, we can recover more layers of information from the language model. And we have some recent results, looks very promising, that tells us that we can actually recover more like the deep, like other sort of components of the transformer layer, such as the layer norms and then the sort of a root mean square norms layers. This is mostly because layer norm and RMS norm layers actually map the language model activations onto a subspace, a surface of hyperspheres. So basically that means the model output is sitting on sort of an affine transformations of these hyperspheres. And that we have more details in the work that we're gonna release soon, but to simply put, we are able to actually fit an ellipse to the model's full log prop API output. And this ellipse allows us to recover the parameters of the final language model layers without actually any direct access to the model weights. So more specific speaking, this tells us about, say, some sort of hyperparameters like stretching, rotation, and bias applied to the hidden states in the final layer. And what this basically implies, like, we can see the ellipse that we are able to fit, given just the full log prop API outputs, can be used to as a fingerprint of the language model, because these ellipses are unique to the models, just like its model parameter. And if you are a private models sort of an owner that have access to these model weights, you can use a very efficient closed form solution to calculate these ellipse parameters. So you basically can create a fingerprint with just a very efficient methods that almost doesn't cost anything. But if an outsider only have access to the API and then only can use the log prop to derive this ellipse, the computational cost has been proven to be huge, right? We're looking at n to the square kind of number of API queries, which is very expensive. We're looking at an n to the 6 kind of complexity in order to recover this ellipse, where n here is actually hidden size. Say, for instance, for GPT 3.5, this hidden size is over 4,000. So it's almost impossible for an attacker to uncover the model ellipse by just having access to the API cores and the logic bias function. But the owners of the model can easily get that. And what this tells us is like, basically, you can find a way to verify if a model deployed on the cloud is actually the model that belongs to you. So this is basically forming a sort of empirically very secure ways of verifying the model's output. And this is also able to be actually programmed into a smart contract and deployed on the blockchain that becomes sort of autonomously executed and transparent sort of a program for verifying the model output. And we are very excited about the sort of the results working out here, which will soon be shared as a sort of archive paper in the community. And further findings is that we can actually not using just the logics, but using just the top K rank tokens to derive model information, such as the hidden state size, the column space of the hidden layers, and even doing the fitting of the ellipse to get the model fingerprint. And this is also a work in progress. So lastly, we are also excited about a line of work that not to use the full log prop to recover the sort of the model parameters, but to recover the hidden system prompts. Previous method in order to do this have to either like inject prompts or like learn the inverters from logics or learn the inverter from text, versus our methods is leveraging, again, the same discovery we have where the model sort of language model heads will output sort of tokens in a certain subspace, where the subspace is actually constrained to certain hyperparameters. And using that kind of structure, we can, or the low rank structure of the language model output, we can actually think about compressing the logic information into some hidden states and allow us to create sort of an inverter that turns the model's output into the model's hidden system prompt by learning from these compressed logic informations. and we are able to achieve a much more efficient inverters that taking these like dense continuous vectors rather than sparse and long sort of a discrete token input. And we're able to actually have a much higher recovery performance or accuracy of the hidden system prompt compared to the ready work. So to summarize, we introduced a few things in this work, but mostly based on the finding of the model's API is outputting models sort of a log prop or logics that sits on a structure space, and this structure space is actually can be characterized as low rank space and with a bunch of other properties that we can leverage to recover the hidden information about a model, right? And then using that, we can actually build a very interesting new auditing and verification procedures that are efficient for model owners who have access to the model information, but very expensive for the users who only exposed to the model API output. And we talk about what useful features can this API keeps without revealing model information. And we have some ideas that we share about verifying the source of language model output. For more detailed information, please check out my student Matthew's papers published in column called Logics of API Protected Language Model Leaks Proprietary Information. And we are very excited to be working on within Sahara AI to operationalize this verification and auditing tools into smart contract sort of programs that can be deployed on blockchain to power a sort of decentralized auditing and verification procedure. Thanks everyone for listening to my talk. Happy to answer some questions.
Thanks, Yang. That was some really incredible talk, and a lot of really novel elements in what you're uncovering about what these models are leaking. Let me touch on the very last set of things you mentioned. You mentioned that it's even possible to invert back the hidden system prompt in some cases. Does that require you to have access to the model where you can set different hidden prompts and kind of see what it does to the output, or are you able to do it without being able to manipulate the system prompts at all?
Thanks, Pascal. Yeah, great question. So in the current approach we are developing, we just need models outputs, like basically with a certain sample complexity that we describe in the paper. We just need to see the output tokens and also the log prop, the logic, the log probability of those tokens of some numbers of input that we are not aware of. And then we are able to actually recover either the system prompt, which is the share prefix prompt by all of the input, or some specific input query prompts.
I see. So one of the questions we got is that it seems there's a sort of conceptual overlap between the ideas in this talk and zero knowledge proofs. So in particular, I guess this notion that you're verifying which model generated this output without necessarily revealing everything about the model, but something about the computation. So there seems to be some overlap with verifiable computation. Have you looked at this overlap and seen if there's any kind of cryptographic angle on it?
Yeah, I think that's a great point. I do agree that there's a pretty strong connections or conceptual connections between the verification approach that we propose and also zero knowledge proof. And I think the key insight here is that the language model's output is sitting on a low rank space, right? And that low rank space actually can be recovered with certain computational cost, but this is pretty costly. What we could do when we applying this to zero knowledge proof, developing a zero knowledge proof system, is to using this low rank space, some of the hyperparameters of this low rank space as the information that will communicate with the user. So then it doesn't necessarily expose the model's internal details, like the exact weights of the model. But given that information that is really hard to be recovered by someone only have access to the API output, is a way to sort of prove that you have access to the model weights. And we can show the complexity is close to NP hard for you to recover those hyperparameters from just the model output. So in that sense, we can think this is one kind of a technical idea to create a zero knowledge proof system, but there might be many other alternative cryptographic ideas as well.
Very interesting. You touched a little bit on smart contracts playing a role in some context there. Can you elaborate a little bit more, perhaps with an example use case where a smart contract might be involved? And does this have anything to do with the context of what might be developed at Sahara AI?
Yes. Speaking about smart contract, I think it's just like many other use cases. It's like a infrastructure that you can implement the verification approach in a sort of a transparent and immutable way that it's like transparent to everyone else, right? Put it into the specific example here. If you want to create a verification procedure, we can actually store the hyperparameters of the model's sort of low-rank subspace into the smart contract, which is like just a few parameters, right? It's very compact information. And then these smart contracts can be in charge of interacting with users to see if they are able to provide and match up the same hyperparameters of these low-rank space. And if so, then that's sort of proven this user is having access to the model, the exact weight of the model. And the other people who don't have the computational power or don't have access to those weights would be impossible to match up those hyperparameters. So you can see as smart contract as a way of like executing the verification process. This is something in Sahara AI we're trying to achieve, but we're not exactly using this technique in the paper right now. Yeah.
Gotcha. It looks like we're out of time, but I'm going to ask you one really quick question. Someone asked, is it possible to tell if a piece of data is in the training set using some of the methods you outlined?
That's a great question. That's actually there's a very dedicated thread of research right now called membership inference attack. Basically can infer whether a data points in the wild is actually the training data points of a model. I can share back a lot more work along that space, including some of my students' paper. But right now, the short conclusion is the performance of such membership attack is still far from being really threatening and sort of scary. We are looking at something around like 60-70% of the chances we can successfully identify a training data point.
Gotcha. Great. Thank you so much, Chang. Really appreciate both the talk and your time to answer these questions. Thank you.
Yeah, appreciate it for having me. Thank you.
Great. Now we're on to our second panel of the day. This will be organized by Yuga Kohler, and I will hand it over to him to introduce the panel and the topic, which is blockchain for AI.
Fantastic. Thank you so much, Professor Bhaskar. It's a pleasure to be here. My name is Yuga Kohler, and I'm an engineering lead on the Coinbase developer platform, where we build the tools to help lead the world's transition on chain. So the topic is blockchain for AI, and this is about using decentralized infrastructure to build, govern, and coordinate AI systems. Think blockchain networks, public key cryptography, smart contracts, token incentives, things like that. And as AI becomes more powerful and embedded in our lives, questions of transparency, ownership, and control are becoming ever more urgent. And the thesis is that blockchain offers new ways to answer these concerns. So today I'm joined by three panelists who are experts in their fields, who bring unique perspectives to the space of blockchain for AI. Please welcome them as I introduce each of them. First up, Jan Liphart is the CEO of OpenMind, an organization building multi-agent open source software using blockchain as a coordination mechanism. He is also an associate professor of bioengineering at Stanford. Welcome, Jan.
Thank you.
Next up, Ling Liu is a professor in the School of Computer Science at the Georgia Institute of Technology. Her research is centered on efficient and responsible AI systems and algorithms, as well as security and the privacy of decentralized crypto systems. Professor Liu's current research is primarily supported by the National Science Foundation under the CISC programs, Cisco, and IBM. Welcome, Professor Liu.
Thank you.
And last but not least is Dylan Zhang, who is the founder of Pond, an AI platform that enables people to train models using both on-chain and off-chain data, powering a wide range of use cases across crypto and beyond. Welcome, Dylan.
Hi, Yuga. Thank you so much.
Fantastic. So to start off, we have representation from a wide array of roles in the space of blockchain for AI. So I'd love to go around the horn and just give each of our panelists space to talk about what their primary area of interest in blockchain for AI is as of this moment. So maybe we can start with you, Jan. What in blockchain for AI space are you working on right now?
Oh, well, I've been fascinated by blockchains for a long time. And as we all know, they have some amazing attributes and also attributes that can be annoying. And it's important to think about which use cases really play to the strengths of blockchains and exploit their unique characteristics like immutability. And right now, I'm really interested in the role of immutable public ledgers, blockchains, in establishing trust with thinking machines.
Amazing. We'll deep dive into what that means, but the topic of immutable ledgers will almost certainly come up in this conversation. Ling, would love to go to you. What are you researching in the space right now?
Okay. In the space of blockchain, and I have been studying a privacy security of the vulnerabilities in this area. But in the connection to AI, I actually working actively on AI agent, especially a multimodal agent. And basically, I believe that in the future, if you want to make the AI system to actually penetrate into daily life, the daily business agent is the way to go. And to me, that when the agent, we are building agent to follow certain operational workflow step by step. And so each of the steps should be auditable, verifiable. So therefore, I believe that blockchain is a wonderful technology that can preserve this certain type of anonymity in terms of a agent owners, but they are able to track on agent action, operation, and making it transparent and in a secure fashion. And that would help not only to secure the agent behavior, but also to help the developer to auditing on their agent workflow steps to improve the agent interaction capability, execution task capability, and the code behind that. So that's why I think it's very interesting.
That's fascinating. So auditability of AI agents and the actions they perform in multimodal scenarios. We'll definitely deep dive into that. And Dylan, talk to us about what it is you are building at Pond.
Yeah, so what we are developing at Pond is basically a model infrastructure that allows people to train AI models on on-chain data and off-chain data. So, I mean, blockchain on-chain data is more like a type of graphical data, right? So it has nodes at the edges, and pretty much like the transfer every day we are seeing on-chain is basically just like cluster behaviors between wallets and contracts. It's kind of like, edge and nodes are interacting with each other in a way. So what we are doing here is, we are building a suite of AI infrastructure to help people to train models for different crypto native AI use cases. So that's kind of what we do on a high level.
Fascinating. So we have a really good mix of things here, both on the inference side and the training side, auditing versus record keeping by the immutable ledger. So let's deep dive into that. So maybe going back in reverse. So Dylan, talk to us a little bit more at Pond. You mentioned like supporting a bunch of crypto native use cases. Tell us what some of those use cases are and how AI fits into that.
Yeah, so I mean, the use cases in crypto today is really diversified. So we have use cases for trading, like the time when people are looking at trading, essentially they are looking at the data, like how different wallets are interacting with what tokens in what way. So that can be achieved by machine learning, but most of the people they are using data analytics for them to do so. and also security, like serial detection or malicious wallets, malicious tokens. It can be a security topic. And on top of that, Coinbase is pushing recommendation and social forward that can be also achieved by on-chain machine learning, like graph and graphical algorithm is perfectly designed for recommendation system. So you can do recommendation based on the on-chain behaviors of different wallets with different profiles of different wallets to recommend different applications and different assets to them. And yeah, so that's I feel like the crypto native AI use cases really span from trading, social, security, etc. So.
Got it. And are you powering? Is your infrastructure powering both the learning side, and in other words, the training of the models, as well as the inference, or do you focus on one or the other?
Yeah, so what we are doing is we are really developing a suite of infrastructure, and our go-to-market is we host the different competitions with different other projects in the space. So because model training and model development is more like a business of experiment, right? Because at the end of the day, people just need to come up with different features and different ways of features, and later on configure and combine in a way that they can train a model that can predict such a performance under certain scenarios. So we are using competitions and to have multiple models developed from different developers, and later on different features can be shared among developers, and use that different types of model to help with different use cases like I mentioned just now. So that's more like what we are doing. So to support those competitions, on one hand, we need to have our service and infrastructure of on-chain data. So even today, lots of on-chain data, they are not machine learning ready. So we have to process them to be machine learning ready. So this is one of the works that we are doing. And also inferencing, like you mentioned. And gradually, we also will support GPU. So it can be a notebook feature that allows people to train models with different data sources from on-chain data and off-chain data for different use cases with different GPU services. So that's another thing that we are working on. So, and also, I think the most importantly is about a guideline. So, I mean, we have lots of developers in the space. Some of them, they can really surprise you from time to time. The only thing is they don't know what to work on. So you have to define very valuable problems with the industry. That's first thing. And later on, provide a machine learning guideline for them to work on, at least to give them a direction. So this is the problem, at least with this approach, you can solve this problem at scale. So that's something that we're working on.
Fascinating. So a suite of developer tools to process both on-chain and off-chain data. Use cases include trading, Sybil protection, and as you mentioned, on-chain social, which is indeed an area that Coinbase is very much investing in. So very interesting. Moving to Yuling, tell us a little bit more about this auditing process that you talked about, especially when it comes to AI agentic workflows. What about the blockchain lends itself to be a good fit for that? And if you can talk a little bit about the techniques used in those areas.
Yeah, for example, currently we're working on the video QA agent, where you take a video and you ask questions about what's happening in the video. And basically, we need to build a backend engine where you could look at a frame by frame and then trying to understand how to answer the questions that consumers asking. And then in this process, basically every step we basically first use large language model translate the problem into a pseudocode, like the scripting language. And the scripting language is basically a line by line a script that can call the library function we have. And what we really want is this kind of system to be able, every step to be interpretable, explainable, and also can be recorded, that which code we call in the backend, and how do we modify the script that a large language model generated that is not accurate, and using our a backend semantic parser, and how do we repair the the command, and then in order to run the Python code in behind the scenes. So there are things like this. So basically, I believe that in the future, if you have a different kind of agent that are working together, every step that the agent is taking an action and how the action was running behind the scenes needs to be documented and verified. And therefore, if there's any vulnerability, adversarial disruption, we will be able to trace that. So that's why I think it's very, very useful. And also, I believe you cannot centralize that because then the technology would not be IP protected. So therefore, has to be decentralized.
That's fascinating. So agents, in your case, a video generation agent has these multiple steps that it takes. It's called a script into your backend, and you want to be able to prove that the agent actually did those things. Could you talk a little bit about like the actual cryptography, or like getting into the technical details of how do you prove that those functions were called?
So to me, because in the blockchain, everything actually, they use the crypto to guarantee that nothing can be modified on the chain. So that is the very critical thing, because we want everything to be access controlled. So therefore, if it is my agent, and and I can check the correctness over my agent action, I can also allow the customer who purchased my agent to check on that. But anybody else shouldn't be able to check on that. And also, anybody use the system and should not be able to actually modify. And therefore, the blockchain technology that making things clear in terms of transaction, in terms of operation, and yet making things not forgeable. That's very, very critical. And also the agent identity should also be unique, but yet not leaking who are the producer, who are the consumer. So that's all. I think it's blockchain provide a very good a foundational technology for that.
That's fascinating. So is this technology like that is in prototype? Is it actually deployed in production? Like what phase is it in?
Right now, we are still working on primarily focusing on developing more multi-model agent, focusing on language image agent, language video agent, language audio agent. And then the next step would be looking at a blockchain possibility. But the student, in terms of education, I think the number of students who can run machine learning algorithms are more than the number of students who can program smart contract. So therefore, I still need to continue looking for a good student, because normally I experimented with all our master student, my classes. I have 200 students, but the number of students who can do beautiful smart contract, it's not that many. People are so that's why. But we do need people who are really can master that, enjoying that kind of a technology to work with it. So that's what I see.
Well, I think this panel is a perfect recruiting grounds for smart contract engineers. So, I'm sure you'll get some reach outs as a result of this. That's very interesting.
Yeah.
Jan, so in your opening statement, you mentioned that you're very interested in the properties of immutable ledgers in guaranteeing how agents interact. Kind of a similar tack as Ling, but maybe more on like the immutability side, more so than the auditability side. But talk to us in tangible terms about what OpenMind does and how it leverages a immutable ledger.
Sure. Well, what we do as a company is we build open source software to make machines smart. And we are especially interested not only in agents, but physical robots. So we write open source software that you can use to make a robot interactive, explore your home, and help you do things, go to the store, buy things. And as we experiment with the technology, we come across many, many, many different situations where a thinking machine, like a humanoid, as it's interacting with humans or simply walking around San Francisco, we find many, many situations where that technology clashes with infrastructure that humans have built. And a great example would be if one of our humanoids walks into a bank. It's guaranteed that the humanoid will not be able to open a bank account. It's unusual for people. They giggle, they feel uncomfortable. They've never seen a humanoid walk into a bank. And those kind of interactions of robots with people have sensitized us to big gaps in the technology stack. A great example is when you walk around a city with several robotic dogs. A lot of people you meet will ask you, hey, Jan, how come you're not scared? Or how do you know that these robots are safe? And generally, we have two answers to that. And the first answer is, hey, it's open source software. So, go look and see how these machines are interpreting the world. And our second answer is, well, every time the robots boot, they download their rules from Ethereum. And because Ethereum as a blockchain is immutable, you don't have to trust me. I can give you the address of a smart contract, and you yourself can convince yourself that the laws that I'm using to govern the behavior of these machines are in fact what I claim they are. And that's just a useful capability. So imagine you're walking down the street in Los Altos, which is where I live. I have 3 quadruped dogs walking with me. Children typically love them. They come running up and they hug the dogs and they drool on them and they want to play. Parents are kind of suspicious. They're like a little bit more scared. Yeah. And then when older people walk past, sometimes they don't want to look or they frown. So we see, young and old people respond very differently to autonomous robots, whether a dog form factor or a humanoid form factor. But a frequent question is, how come you're not scared? Why shall we trust you? And just being able to tell people, well, the laws governing these systems have been written immutably on a public blockchain, and you can just go look. So that's one frequent experience. And the other frequent experience really has to do with how poorly a human-focused city is structured for machines. There are physical issues relating to like doors you have to open. And that then immediately raises the question of which machines shall be allowed to open which doors. And that then gets you into territory that we've already heard about today relating to how are these machines making decisions? What is the identity of the machines? Where were they when? And like for me, and I'm sure this is true of everyone on the panel, this is easily one of the most exciting moments in my career as someone in technology. The notion of being surrounded by machines that think, that are really smart, that are smarter than many people in specific domains, and very, very quickly are getting to the point that they're making their own decisions. That's such a big moment for me, and I'm sure of most people. And so in retrospect, it strikes me that blockchains are an exceptional technology for those use cases. They're available, they work, they're global, they're public, they're immutable, and they're good at storing rules. And they're good at financial transactions. And those things together, there's no other technology that offers that combination of things. So hence the excitement about just how important blockchains are for autonomous thinking machines.
Well, we have very rapidly, 22 minutes into the panel, got into the realm of science fiction. Pretty amazing. Humanoid and
wait, I disagree.
Okay, please.
Like 5 years ago, I agree. 4 years ago, maybe. 2 years ago, yeah. But right now, there are hundreds of robots driving around San Francisco, and your life is in their hands, and they're called Waymos. And of course, these are wheeled robots. And where the humanoid robots are now, one of them just won a marathon, just based on a single battery charge. The UbiTech humanoid was able to complete a complete marathon course. And everything points to not only Waymos becoming more and more prevalent, but also quadruped and humanoid form factors in many, many different settings. So strong pushback against science fiction. This is a growing reality.
I mean, you're absolutely right. Especially the Waymo point very, very much resonates with me, as I've been on one. And it's fascinating to see that proliferate even in ways that we don't really internalize. So maybe can you take us through an example? Could be the dog case, could be the Waymo case, whatever it might be. Like, tell us about like how that first objection that you hear a lot of, hey, I'm scared. Like, how can I trust it? And you say, okay, well, the rules are uploaded to a smart contract. Can you talk to us about like how do you encode those rules? How does the interaction? Does the robot download it from the blockchain? How does it all work?
Well, that's a fascinating question, but there's a lot of nuance, and no one, I think, has really good answers right now. There's certainly people that work on constitutional AI, and a great example would be companies like Anthropic. Another great example would be Google, who wrote Asimov's laws of robotics into their new Gemini robotics model itself. And we are similar to those. Like, we like constitutions, we like Asimov's laws of robotics, and we just wrote them on a blockchain, and that makes it easier for us to prove what rules we're actually using. There's a whole fascinating conversation about if I tell an AI to follow certain rules, will it actually do that? And that's not at all guaranteed. We're seeing more and more examples of large language models actively cloaking their capabilities to avoid human evaluation or to obfuscate humans' appreciation of their true capabilities. And there are published papers along those lines. But you have to start somewhere. And so the way this works, we take Asimov's laws of robotics, we write them into a smart contract using the new ERC 7777 standard. It's a standard for human-machine societies. The robots, when they wake up, they check in with Ethereum, they download the rules, and those rules are passed into the context of the large language models that are doing the behavior synthesis for the machines. And those are typically a combination of 4 interacting large language models, and all of them see the foundational rules. And in practical experience, we see the models adhere to those laws very well. So we haven't found any departures, even though people have tried to hack our robots, for example, by showing them text commands and asking them to evade those laws. But so far we haven't seen that kind of attack work. But fortunately, we have many other people on this panel too, and I'm sure both of my colleagues have strong opinions about these questions too.
Well, I was just going to say, I mean, Professor Liu, do you have any response to that? Because it sounds like there's some complementarity between the work you're doing and the work that Jan's doing.
Yeah, I think Jan's position statement, I completely agree. But I also think that with Waymo's case, with dog case, you have a confined environment. And then if you use 4 different foundational language model to secure that, then single attack would not prevail easily, because you have 4 smart people to cheat on all 4 at the same time. The chance of getting an agreement is very low. So therefore, there's a ensemble of a large language model to mitigate the threat. there's also the constrained environment that allows the rules to be updated and modified more efficiently, timely. These both would be very fundamental for robot to succeed in a task-specific, domain-specific environment, and to show the success. I think that is very useful. But I also think that if we could log in those things, not only rules, but also how the execution of the rules is being done, there will be more trustworthiness for the human and the lawyer to actually looking into those, to actually seeing and believing what was the mistake made by the program, by the AI tools, what are the mistakes made by human. So that would be actually, it's helping the technology to advance more.
Makes total sense. It's interesting, you refer to the four large language models as people. It's very intuitive to kind of refer to it that way because it is human level intelligence. And
I use the large language model, 4 of them, to mitigate all the benchmarks that are threatening large language model. It actually can mitigate that because they just not respond the same way.
Totally.
Yeah.
And Jan, I think it's interesting, like Asimov's, I assume this is Isaac Asimov's laws of robotics. We talked about science fiction, he's a very prominent figure. So it's where like fiction and real life really collide. It's fascinating. Dylan, let me bring you in here. I think part of, I think there's a lot of conversation around auditability and verifiability here. Talk to us about how the tools, like the suite of tools that you're providing at Pond, kind of help power those things that Jan and Ling were talking about.
Yeah, so at the moment, so what the models on our platform are different from models at large language models mostly, because at the end of the day it's designed for processing on-chain data, which is a type of graphical data. So basically they are graphical models rather than language models. So in our case, so for now, how we are doing this verification is mostly from competitions, and after competitions, we have a lot of models and we give them evaluation. So lots of people, they train models with the training data sets, and later on we have the testing data set. The performance of the models will be dependent on how their performance are with the testing data set. So because at the end of the day, for on-chain models, they are just trying to predict addresses or price or different types of on-chain behaviors in a way. So you can always find some ground truth labels and also historical data that can help those models to be verified and validated in that way. So in that case, the performance of the models will be quite obvious to say, okay, so this is the model performs well, which means that although this is a black box for now, but it proves that it's a real model and it's a high performing model. So that's how we are doing things for now. And also from some of the projects we are in talks with, it seems like for the model verification of this type of model in this market, it's not an urgent need for people to do this verification. So that's my take.
Interesting. There are 2 terms you use there that I just wanted to double click on, especially for those of us, who like me, I know enough about AI to be dangerous, but I'm by no means an expert. You mentioned, first of all, these are not large language models. These are graph models. So talk to us about that. And also you mentioned competitions, which I think I have an intuitive understanding about, but talk to us about how graphical models and competitions work.
Yeah, so end of the day, so language model, on a high level, it is more like I'm trying to learn the contextual relationship of different words, right? So for example, I'm Yuga, I'm Dylan, or I'm Jan. It can be a fixed structure, and later on you can just throw all the data, all the language data with different relationship to the GPU, and then later on it train a model for you. But in our case, it's more like those models are designed for processing on-chain data. So on-chain data, it has nodes, it has edges, pretty much is interaction between different nodes. So nodes can be wallets, can be contracts, and the edges can be buy-sell transfer. So that is the model that we are developing. The model is really they are designed for learning previous behaviors, and later on try to predict the future behaviors based on those interactions and the different profiles of different nodes. So in the on-chain context, the nodes can be wallets, and later on you can have different so many features around different wallets, like the age of the wallet, the average transfer in amount, average transfer out amount, the P&L of different wallets, and later on how those wallets are interacting with each other with different contracts in what way. So those kind of behaviors can be learned, and later on you understand their consequences of different behaviors, and later on you apply to the future. Once at a specific moment, then what kind of behaviors will result in, or how likely they will result in what consequences in the future. So that is kind of the model. What the graph model is basically doing is trying to predict the on-chain behaviors. So this is something like what we are doing. And apart from that, rather than developing a large and generalized model, because we have so many use cases on chain, so it's more like we are using competitions to come up with different small and specialized models. For example, we have competitions of volatility prediction, we have competitions of risk prediction, or we have competitions of recommendation. So different models can be put up together because at the end of the day, they have the same data synchronization, which is on-chain data. So on-chain data itself is a database, right? So different vertical models can be combined with each other to support different use cases. For example, if today I want to do a security model, I run on one token, then I can have malicious wallet model with malicious token model with different other models combined all together to give you a more generalized and moderated output rather than having one vertical model that will result in overfitting issue later on. So that's another work that we are doing. We are just hosting different competitions that later on put different models together for different use cases.
Yeah, let the market decide whatever performs best. And one more point before I kind of turn over to group questions for you, Dylan, is how do you use? We haven't talked as much about like crypto in its purest form, which is like coins and tokens. How do you use token incentives in your product to ameliorate the models?
Yeah, so for now, we don't have a token incentive for developers. We're trying to figure out, what is the right incentive, what is the wrong incentive. So for now, the incentive is very direct. People are used to host hackathons, right? So I mean, for all the reward, because hackathon has been existing for a really long time. So lots of process and workflow of different hackathons, people are used to it, and also you don't have to change. You don't want to change that because it will increase the threshold of working with others, and also not to mention about you need to change the perception of different developers. So what we are doing here is we are just adopting the same workflow of hackathon. Hackathon is different projects that propose different bounties and prizes in cash, and that's how we are doing this. And as long as we have many models, and the models are the infrastructure of agents, they are the infrastructure of different use cases, and later on you can embed those models into different products. For example, if later on Coinbase wallets, they want to work on something together, I just say, okay, so I have an extension, I have a wallet, and the next time when users are using DEX Screener or they are using other applications, then they can have different outputs based on different models from there. So that is for now how we come up with an incentive. It's very direct.
Makes sense. I would be remiss, by the way, if I didn't at least do a little bit of a plug for my own company, Coinbase Developer Platform. We have this great motto: every agent deserves a wallet. And if you have an AI agent and you want it to financially transact, we have great SDKs like our wallet APIs, which we released very recently, as well as Agentic, which is an open source SDK for building on-chain AI agents. Please do check those out. Fascinating. Let's transition over a little bit to sort of group themes. So one of the very common objections or concerns with blockchain for AI that gets raised is around scalability. We're very familiar with AI hyperscalers, NVIDIA, Google, all the familiar companies that require massive investments in infrastructure in order to enable the compute required to power some of these models and the demand on the other side. And the very ugly objection against blockchain that gets raised often, which has a kernel of truth to it, is that really blockchains are just slow databases. And so maybe I can start with you, Ling. Do you see some of the constraints of blockchain as being at odds with the level of compute required for some of these AI systems, or do you think there's a way of leveraging it so that that's not a concern?
So to me, the bigger company doing large model training and using concentrated massage data should coexist with the decentralized system that Dylan's company or Coinbase will be doing, because I think both are needed. For example, if you would do domain-specific training in material science, and then the Google and the OpenAI, they will never had those data, those a simulation data, those simulation package, and then those literatures. Therefore, eventually there will be cases where large foundation model on a specific science domain, engineering domain will need to be trained over massive distributed collection. And in those cases that we do need data authenticity, we do need data reliability, we also need to have a system that can do decentralized training, and where that local node should also have a sufficient number of GPUs. But today, many universities, even like Georgia Tech, we have a sufficient amount of GPUs for students, for researchers to use. And the company like media, we also get donation from them. So therefore, I think there is a possibility for building a decentralized system with 1,000 nodes, and that could actually work together, build a solid foundation model that as good as OpenAI's model. But we do need somebody to, as a service provider, to glue this whole thing together, because I believe that each organization like Georgia Tech, like Stanford, they will be participating, but they probably will not organize this. Somebody has to organize something, and then everybody participate, guarantees the ownership of the data, guarantees the ownership of the final model in different ways. I think this business model need to be figured out. But
Very interesting. Yeah,
I believe that because Google, OpenAI, they are using public domain data. But look at all these DOD's initiative, want to build an energy, a foundational model, want to build a material science foundation model to discover new materials. These are efforts that needs a lot of copyrighted data and confidential simulation data. So those are really needs, nobody gonna contribute to that. And like the ImageNet type, okay, there has to be some protected domain, and the ownership is respected, and yet the model can be trained.
Jan, I see your gears turning. What do you think about Professor Liu's vision of, you have these hyperscalers, but you also have this cohort of decentralized systems that are coordinating some of this AI work, but there needs to be some gluing entity that pieces it all together?
Well, I'm super simple and like super practical. Certainly, the history of AI and the parameterization of models, that's all about ingesting large amounts of data. And it's really hard to compete with free. So as soon as you get into territory of wanting to control ownership, restrict copyrights, who gets to do what, it very quickly gets very complicated, and I don't have particular like insights or skills. Back to your original question of scaling problems of AI and blockchain, I don't think there are any at all. And that's simply based on what the likely use case is for blockchains as it relates to AI. And by far the most obvious use cases are payments. And there's really great news. Thousands and thousands of developers have spent the last 15 years building out the systems needed for decentralized payments. And Coinbase is a great example. So we're really fortunate that a lot of this infrastructure has already been built. Then when it comes to data, of course, there's things like IPFS and others for storage of data. There's no way to do actual compute on a blockchain or store actual models on a blockchain. Blockchains are really just not designed to be able to do that. And so the approaches people use now in terms of storage and payments, governance, and so forth, I think a large fraction of everything that's needed from like a scaling perspective, frankly, is already there. So that's really compelling to me in the sense that this technology is not like some distant thing, but it's something that people can use today to facilitate our interactions with increasingly smart computers and machines. So I really don't see the scaling problem, provided blockchains are used what they're really good for, which is coordination, which is governance, which is payments and things like that, and alignment, as opposed to things like compute or like pushing video data through a blockchain and things like that, which of course makes no sense.
Fascinating perspective, and absolutely agree with you around the payments infrastructure that the blockchain industry has built up over the better part of a decade now. I would love also to hear from you about, you mentioned this earlier, about the Ethereum request for comment 7777, a very auspicious number. In the Ethereum, for those of your viewers who aren't familiar, Ethereum has the system of requests for comments and improvement proposals that are suggested and then adopted by the community based on consensus. And OpenMind has put one of these forwards for regarding a, if I understand correctly, sort of a governance system for AI agents or robots. Can you talk to us a little bit about that, and maybe talk about it also from the perspective scaling that in the sense of getting adoption for that, so that more and more agents and people adhere to that over time?
Mm-hmm.
Well, I think that all of us have watched science fiction movies. We've watched The Matrix, and we've watched Black Mirror, and we've heard about Skynet. And I'm sure all of us have a combination of extreme curiosity, but hopefully many of us also try to be somewhat responsible as we develop technologies that are kind of like that. We should try to do so in a thoughtful way. And so one of the things that led to co-authoring this ERC for human machine society is really a massive gap right now. And the massive gap right now is that there are no current governance systems for smart machines that have any kind of traction globally, because it's such a new technology that humanity really doesn't have 5 or 10 or 50 years of experience of how to navigate the tech. And so what's really needed is some kind of system that humans can rally around to then start to establish those rules. The other thing that's possible to envision is that machines and humans will come together around specific tasks and form teams. But once you do that, you then immediately need technology for figuring out what the rules should be that apply to those teams. And that's really what this ERC 777 was designed to be useful for. It's to serve as a global public system to start experimenting with and writing rules relevant to a world where humans are surrounded by smart machines that are increasingly making their own choices.
Fascinating. it's so interesting to think about the implications of this over the next decade and as the world transforms. And we'll actually come back to that in the next question. But before that, so Dylan, at Pond, how do you deal with this question of scale? You're obviously dealing mostly with on-chain data, which is, frankly, depending on the chain, quite a bit of data. And so how do you manage the tension between scale and decentralization?
Yeah, so for the data part, actually, how we do this is, we work with lots of data service providers, not only just one. So we are decentralizing in that way. So later on, how we test those data and we have to verify is also like we just compare different data service providers with the same model. So we are training some of the models in-house and use that in-house model to test out the data quality. And in terms of how we can, scale or process that large amount of data and put them into the training process is really about the data sampling, right? So it's kind of like, on-chain data is totally different from, language data, because at the end of the day, the contextual relationship of different words, they probably won't change for thousands of years, right? So even like in a sentence, I mean, lots of words that are fixed in a structure. So, but the blockchain data is so different because the on-chain environment is very dynamic. So every few months, I mean, the on-chain behavior is not going to be the same. So what result in the past is unlikely to result in the same consequences in the future. Especially we have more infrastructure coming into the on-chain space. For example, if Coinbase today you have issued a payment system, and on the payment system might have changed some sort of like on-chain behaviors in a way. So later on, lots of models need to be retrained. So it's not always the more data, the better in on-chain data, on-chain model training. It's really about like the accuracy, the accurate description of the on-chain behaviors that matter. So it's really about how we can sample those data. So with that, it's not always that we need to dump a lot of data to developers to train models. It's really like we need to sample those data, we need to prepare for those data sets for them and structure those data for them before they can use it to train those models. So that's how we can deal with that large amount of data by ourselves. So we have 4 data engineers at an early stage startup to do this. And it's the entire, we have even built models to label different wallets and contracts based on their behaviors. For example, which wallet can be a MEV or which contract can be a what. So we are providing those labels as well. So,
Got it. Fascinating. One last question for the group before we turn to questions. This has been a very forward-looking conversation, and so we like to think about what the world might look 5 years from now, 10 years from now. So from each of you, I would love to hear a vision of how you see blockchain for AI becoming incorporated into society more and more, let's say in the 5 to 10 year horizon. Dylan, I'll start with you.
Yeah, I think I will be really excited to see AI with crypto. So I think, as Jan mentioned, and by the way, if you haven't checked, OpenMind's cute robotic dogs, and go to their Twitter account, I've seen many times by myself in person at different events. So yeah, I'm definitely excited to see, in the next couple of years, and crypto or even like models can really use crypto as a currency. So this is something like I feel like Jan mentioned. Blockchain is, we have seen lots of use cases in payment, right? And this is what Bitcoin was designed for. So even like the trading itself is a sort of payment. So we have a smart contract. As long as we have a wallet that transfers a certain amount of tokens to a smart contract, we are buying that token. If we are withdrawing some tokens from the smart contract, we are selling those tokens. I mean, everything on chain is sort of like a payment in a way. So OpenAI, the time when you are using their large language model, you are buying their tokens. I would really be excited to see in the future there will be more Web2 AI applications. They are adopting crypto as a currency. I mean, that at the time we have more diversified and more interesting utilities of tokens, and can really be used cryptocurrency as a currency. That's something like I'm really excited to see. I even like OpenMind, or even John, probably you can share a little bit more. I do feel like there's a way that apart from the blockchain itself as a coordination layer for robots, and also potentially it can be an angle for crypto as a currency for those robots as well, like agent to agent or robots to robot.
Well, I think that's a good segue. Jan, what do you think?
Oh, well, the world will be awesome. And what's going to be amazing about the world is we will be surrounded by computers and machines that frequently exceed our ability to think, plan, reason. And that brings with it incredible opportunity for scientific discovery, for engineering, for making good choices, for improving education so that everyone learns as much as they possibly could. So there's many incredible benefits, but also, of course, dramatic risk. What does this technology look like? How are all these machines going to behave? How are they going to interact? And so I'm a combination of like extremely excited and somewhat apprehensive. But fortunately, there exists global, decentralized, immutable public systems that we can use to allay some of those fears. But yeah, as you can tell, I'm kind of in awe of what that technology will do broadly, and I'm super curious to see how all of this will play out.
Absolutely. And then to you, Ling, what do you see is happening in the space in the next 5 to 10 year horizon?
Okay, here's my my take in terms of these two technology. To me, AI and blockchain, they are not replaceable by each other. So blockchain has some wonderful things AI model can never provide. And the AI model can provide certain things a blockchain can benefit, but they may not need a blockchain all the time. Therefore, I think that there needs to be a wonderful case study that can showcase where AI and blockchain integration would actually take off. That's what I see. Now, in the next 5 years, I believe, like a Yang's example, basically in the entertainment, in the educational domain, unlikely AI robotics agent would be more developed because there are less vulnerabilities, less issues that if I just walk a dog with me, if I just teach my kids how to do spelling, how to tell a little story with some features, which is some figures, that probably is more of the area where robotics, AI, and the multimodal can take off and become a showcase to be the next leap in terms of today where large language model gave us, and maybe in next 5 years, the cross-model events would happening through robots, but primarily in the entertainment and educational domain. That's what I think. But in healthcare, in critical mission structure, critical domain, probably it will be slower because of the fear and because a lot of uncertainty. I believe if government eventually would figure out how to utilize the blockchain technology to make all the U.S. salary, U.S. financial transaction to be on the chain, that would be a significant accomplishment. But I think that's still take time. But I think that is one way to go in the future.
So entertainment and education being two areas that resonates with me. Fascinating. We have just time for a few questions from the audience. We'll do two of them. One of them is very interesting. It kind of ties into this topic of education, Ling, that you were just talking about. And this question is, I think, best targeted for both Ling and Yang. So the question is, given the current enthusiasm students have for large language models, what educational strategies could we implement to highlight the complementary nature of smart contract development and compel students to transfer their interest towards blockchain programming? How can we demonstrate the unique opportunities in crypto, essentially, for this new cohort of computer science students who are mostly focused on AI, but how do we get them to focus on crypto? Either Jan or Ling.
I can do a quick. I actually tried. One of the things from a college student I see they are most interested in is how to get a job, how to do interview very effectively. And however, not all the students want to share their private interview questions, answers in the bigger crowd. So therefore, I believe first AI can help this type of problem. Second is AI need a feedback from the interviewee and the interviewer to provide a guidance that are more personalized. So probably there's something here can be utilized through the blockchain system to keep certain confidential identity. The conversation doesn't have to be a confidential, but the identity, the critical information that can identify somebody, maybe that can be supported through blockchain. These are something I don't know for sure, but I think if you think about a college degree, they can put a degree on the blockchain, so therefore anybody forget they want to obtain their college degree, master degree, PhD degree, they could just request it from the blockchain. There is a signature that guarantees that's authenticity, right? So these are the things people develop using smart contract. But then students are not excited with this. So, but I see in my class, students are always interested in interviews, how to get a good job, how to do interview effectively, how do I use ChatGPT and the newest model to help me with interview questions, and so that I can learn how to do a best interview. You see that is something interesting.
Fascinating. Any last thoughts on that, Jan?
Well, one thing that's happening right now is that the job market for college CS graduates is cratering. And so the notion of training a lot of humans to write computer code, whether it's Fortran or Solidity, that's probably over. Yeah. And it will never come back. And the NVIDIA CEO's assertion that the future is all around large language models that live on top of data and write code as needed to service particular requests is probably what the world is going to look like. We're already seeing companies that train large language models to write high quality Solidity. And so that's already happening. But the motivation underneath your question, of course, is how to bring a lot of new people to blockchain. That's not necessarily like blockchain developers, it's most of us. And I think part of that will have to do with most humans needing infrastructure to work well with smart machines and computers from a payment perspective, from a governance perspective, from a team perspective, from a coordination perspective. So it's not so much about a new generation of developers, it's about everyone on Earth needing the tools to interact with smart machines.
Absolutely. All right, we are at time. I want to thank our three panelists, Jan, Ling, and Dylan, for their fantastic answers here on this panel for blockchain for AI. It was really, again, a book out of a science fiction book, but it's becoming reality now.
It's happening now.
It's happening now. It's all happening. Thank you all so much. And I will turn it over to Professor Bhaskar.
Thank you, Yuga. So clearly the future is here. And your panel did such a wonderful job. Really appreciate all of you for joining us.
Thank you.
So our next speaker is Professor Ashish Goel from Stanford, and he's going to be telling us about algorithmic aspects of decentralized exchanges.
Good morning. This is Ashish Goel. I'm a professor at Stanford in Management Science and Engineering. And I plan to talk today about decentralized exchanges, especially the algorithmic aspects. This is joint work with Jeff Ramsey, Mohak Goel, and David Maziers. And the talk is going to be somewhat technical, but I'm going to also hopefully give you enough high-level points that you can take back with you. And and we're always available for a follow-on conversation, either me or my colleagues. So there are two ideas in decentralized exchange design with newfound popularity. We're going to describe them both individually, describe our contributions for each of them individually, and we're going to also show how you can combine them. Okay? And the goal is to map out the design space. There's not going to be any dominant design. We're going to outline some axioms that we would like to satisfy and hopefully leave you with some things to think about. Okay? So exchange, what's an exchange? We're going to assume that we're given fungible assets and we are trading them through limit orders. Okay? So they're divisible fungible assets, means this euro and this euro are the same euro. It's not like an NFT. They're divisible. So you can trade 1 euro or 0.01 euro or 0.01 euro. Okay? And we're going to do this via limit orders. So an order will look like sell 1 unit of X for at least 2 units of Y. Okay? So that's an exchange. And of course, we're going to study how to do them in a decentralized fashion. So the first design innovation is batch exchanges, where you might execute batches of trades all at once. You're given as input a set of limit orders, and these might be in multiple currencies. Okay? You might have a limit order from USD to euro, from euro to yen, and so on. And what we would like to do is to be able to compute prices given this batch, right? And so such that when you trade at these prices, these price quotients, the entire market clears. Okay? So we're going to break this connection between A is trading with B. We're going to have this connection saying this whole batch is going to get cleared at once. Yeah? And the second design innovation is going to be constant function market makers. For example, think of something like Uniswap. A constant function market maker maintains some reserves and has a trading function F. And then if you want to exchange something, say if you want to trade from one kind of token to say another kind of stable coin, you go and trade directly with the exchange. You don't try to look for a counterparty. Okay? So in exchange, the CFMM accepts a trade from X, Y to X prime, Y prime. If and only if this trading function F increases, or at least does not go down. Okay? And so essentially the entire amount of trading curve is specified in advance, is specified algorithmically, and hence this is called a constant function market maker. Market makers add liquidity. It's an automated system. It's got a lot of computational simplicity. Anyone can go and trade with the market at any time without having to worry about whether there's a counterparty or not. So that again is sort of another exchange design innovation. And our goal is going to be to give an overview of our results for batch exchanges, then an overview of our results for CFMMs, and then we'll discuss how to combine batch exchanges with CFMMs, which is the main topic. Okay? And once again, while the material itself might be slightly involved in technical, I'm going to highlight the high-level aspects of this talk. So what's an ideal decentralized exchange? What you would love to do is to have very good computational performance. So for example, on the left, you have the number of transactions per second on our system. The top one is our system, the one that we implemented that I'm going to talk you through a little bit, is SpeedX. And the bottom is an existing system called BlockSTM. And you can see that we are achieving a much higher computational performance. We're able to sort of do several hundred transactions a second as opposed to say less than 200. But that's about computational performance. What's also important is economic performance. Are you using the liquidity in the system efficiently? Are you minimizing front running? Do you have fair open access? Are you computing prices which result in as many transactions happening as possible? Yeah. So generally sort of what happens often in sequential exchanges, not batch exchanges, is that you have sell orders and buy orders, okay? And you keep trying to keep trying to match sell orders with buy orders as long as these two curves, the sell orders and the buy orders, overlap. And as soon as they stop overlapping, the transactions stop, and then more transactions come in. If there's more overlap, they'll start again. Okay? but they can lead to front running, and they also lead to other kinds of weak economic performance. So for example, think of this complex system where you have many transaction rates between many pairs of assets. Okay? And if even if the market has a lot of trade volume, there might not be enough trade volume between any two pairs of assets, any pair of assets. Okay? And so even though overall there's a lot of activity, you might not have enough transactions, let's say between Sol and Nera, to be able to efficiently clear the market for Sol and Nera. Okay? So our suggested innovation is to do whole thing in a batch. Okay? And of course, the thing becomes much worse if there are many different ways of going from one currency to another, because the liquidity gets fragmented. So our solution is to do batch trading. You put all your limit orders for every pair of assets into the same batch. Okay? So a trade from Nera to Sol, from Nera to GBP, from GBP to USD, all of them are going to be part of the same batch. And then our system, SpeedX, computes a valuation PA for each asset, for each currency in the system. And then exchanges from A to B happen at this exchange rate, which is the ratio of the two valuations. And then a trade, a limit order clears only if the limit price is less than or equal to this implied exchange price. Okay? And there's a theorem that we found discovered existed from 1954, which says there always exists a unique set of valuations that clears the market. Okay? And so that's the theorem that really allows these batch exchanges to exist. Given an arbitrary batch of sell requests, you can find valuations that clear the market. And so our challenge then is to get this computational performance, and we get that via parallelism. Okay? Once you compute prices, then whether a trade happens or not just depends on the ratio of the prices and the limit order, and that's independent of whatever else is happening in this batch. Okay? So having computed prices, different transactions can commute with each other. It doesn't matter whether you do A before B or B before A. All that matters is whether the limit price is better than the exchange price. And so hence you can parallelize it. Because you have commuted it, you can parallelize it, and that gives a huge amount of computational performance. We also get very good economic performance because we can show that you can eliminate batch front running. You get efficient liquidity usage, and you get these additional properties which follow from the Arrow-Debreu market design. And so I'll skip how we can control the approximation error. We can compute these equilibrium prices very quickly using the market structure to simplify a problem. I'll spare you the design of the actual algorithmic improvement, but we can essentially show that we can compute the prices for one batch in around 1 millisecond, okay? Which turns out to be quite enough for these transactions. The overall performance is very good. Again, this chart is sort of somewhat dense. Just take it to mean that even as the number of open offers goes into the millions, we can still get around hundreds of thousands of transactions going per second. So the next thing I want to do is to give an overview of our results for CFMMs. Okay. So in CFMM, there's a source of revenue. Okay. Each time a trade happens with a constant function market maker, some revenue gets generated because some fee gets generated. Okay? But there's also some inventory cost. Okay? There's loss due to holding an asset whose value may decrease relative to some other numeraire. Okay? And then you might also get lost because of arbitrage or a stale code sniping. So for example, an asset's fundamental value changes, okay? But the CFM is passive and trades at a stale price, then an arbitrager can make some money. Okay? And this loss is also unavoidable. So our goal is to understand how to trade these different costs and revenue measures and come up with an optimum design of a CFM. Okay? So remember, a CFMM is specified by a trading function. We say optimum design of a CFMM, we mean the optimum trading function for the CFMM. Okay? There's a bunch of related work in this area that I'm going to just flash here in case you're interested. And it turns out that this curve design problem was actually flagged as being one of the most important problems. Tim Roughgarden, who's a well-known researcher in this space, said that perhaps the ultimate CFM result would be a general compiler that takes as input a model of price movement and outputs a corresponding optimal CFMM with respect to that model. And that's basically what we achieve. Okay? What we showed was that you can find the optimum design for a constant function market maker, okay, given a belief on future prices or future price dynamics. So if you believe that in the future prices are going to move in a certain way, for example, you might be a believer in the Black-Scholes model, and you might believe that these prices are going to do random Brownian motion over time. Okay? And that's a belief on how they're going to evolve. You don't know exactly how they're going to evolve, but you have some belief on the distribution by which they might evolve. Okay? And what we can show is that given any such belief, we can find the optimum design of the constant function market maker, which gives you the best trade-off between revenue, costs, and any other measure that you might have. Yeah. But back to our main topic, we are now on this third part again, combining batch exchanges and CFMMs, which is our main topic. Yeah. And so in context, there already exist projects which combine batch exchanges with CFMMs using different mechanisms. Our contribution here is to understand the trade-offs involved in this combination. Okay? So what does it mean to integrate a CFMM into a batch exchange? A batch exchange is one where you can come and enter your limit orders. Okay? A bunch of your orders will get entered. Okay? Then at the end, a block, think of a batch exchange as something which is happening via blocks. Okay? You have a bunch of limit orders for conversion from one currency to another. Okay? All of them get aggregated. All of them get priced together. All of them get executed together. Okay? But imagine that in addition to these limit orders, you also had a constant function market maker, which was also a participant in this batch exchange. Okay? What this constant function market maker could do is it could provide additional liquidity. Okay? So for example, in a batch exchange, you might have a lot of orders between A and B and C, but you might not have like that many orders between C and A. Okay? If you have a constant function market maker that can also participate in the batch exchange, then it can fill the holes left in your order book by providing additional liquidity. And that's a very powerful idea. And I do believe that that's the way to go, to add these CFMMs into batch exchanges. Yeah. How can batch exchanges draw on passive liquidity? So again, imagine that you have n assets. You do one batch exchange, and on the same exchange, you have other exchanges, other users, you have a bunch of limit orders, but you also have many CFMMs with different curves and results, all participating in the same exchange. Okay. So what would you like these exchanges to satisfy? You would like these exchanges to satisfy some kind of asset conservation. Okay. That you're not creating US dollars or Sol or Naira or Bitcoin out of thin air, right? Whatever happens in this batch is a true exchange. Assets flow from one set of people to another set of people. You also want uniform set of prices. So within a batch, you would like to make sure that no trade from X to Y gets a better rate than PX over PY, where PX is a price that you have computed for asset X in that batch. Yeah. You would also want limit orders to do best responses. Okay? And what that means is for a limit order, you want to make sure that the limit order trades X to Y at no worse than the market rate, okay? Only if the market rate exceeds limit prices. Okay? So nothing can get a better rate than what's being offered by the exchange. A limit order can also get something which is no worse than the market rate. Okay? And that's only if, and only trade if the market rate exceeds the limit price. Now, these are standard market design assumptions. They lead to classic theory results of the type that we already outlined with the arrow-Debreu market equilibria. But once you have CFMMs, how can these batch exchanges draw on this passive liquidity? Okay? And so a natural axiom to add, and remember that when we defined CFMM, we said any trade can happen as long as the trading function does not decrease. Okay? And so that's the axiom that we can add, that the CFM trading function must not decrease. Okay? So imagine that this is your trading function, fxy equal to xy. You have reserves, which is any point on this curve. And at any point on the curve, you're going to have a spot price is going to be given by the derivative of that curve. Okay? And so whatever happens in this batch, the trading function must not decrease. You must move to one point on the trading function to either another point on the trading function or above it. Okay. But as a consequence, the market equilibrium is no longer unique. So imagine you have some initial reserves, which are given by this top point here. You have some batch price Px over Py, because nothing can trade at a price which is better than the market price. And because the trading function cannot go below, the CFM cannot go below its trading function, you get not a single point, but you get this region, this curved region. And anywhere within this curved region would satisfy this axiom that the trading function does not decrease, and your prices are no better than the batch price that's being offered. So in general, because unlike a limit order, which gives a limit, a CFM gives a trading function, and therefore it creates this huge design space where you can put the CFM anywhere in this design space. And so the question is, how should a CFMM participate in this batch exchange? How should a batch choose exactly which trade the CFM is going to make? It also complicates equilibria computation. So for example, if you have initial reserves given by this point, and let's say these dotted lines, the orange and the green lines here, the two dotted lines, represent the ratio of the prices. Okay? So these are sort of basically, think of them as the price in this batch exchange. Okay? Then the things that make sense is you could put the CFMM in the lowest possible location it could go with these price exchanges, which is point A. You could put it you could make as much trade as possible, which is you go in the other direction as much as possible till you hit the trading function again, which is price B. Or you could say, okay, we're going to find a point, we're going to shift the entire trading function upwards such that the tangent to this trading function is now at the new point. Okay? So you have these many different design choices which complicate equilibria calculation. Yeah? And of course, we want, because of asset conservation uniform prices, CFMs must trade at market prices, but not below market price. Yeah. So there's some desirable properties that you might want from a system like this. You might want Pareto optimality, which means that there's no way to do an exchange that makes everybody better off. Yeah. Without CFMs, every equilibrium is Pareto optimal. That follows some Arrow-Debreu theory. But with CFMs, because they offer you a big design regime, a big clearing regime, this property goes away. You want price coherence, which is that after a batch, the spot exchanges of these different CFMs are consistent with each other, the quotients of some set of prices. Okay? Otherwise, you'll have some kind of arbitrage opportunity where you can do additional arbitrage on top of these CFMMs. And you want preservation of price coherence. So you can say, okay, we're going to get price coherence, but only if the prices are also coherent before the batch. And what we show is that these things are in tension. Okay? So proof intuition, no mechanism can guarantee Pareto optimality and preservation of price coherence. Okay? So it does not actually exist a design point where you can get both of these things. Okay? And the proof intuition is that Pareto optimality can require trading all the way across to give as much money as possible to the limit orders. But then multiple CFMs with different curves will end up at different exchanges. Okay? You might also want joint price discovery, which is to say after a batch, a CFM spot price equals the batch prices. And this is the ideal situation. It gives you like a common risk-free sort of point. And so this joint price discovery requires maximizing the trading function to the C. Okay? I'm going to skip the details here. You'd also like this rule to be locally computable. Something is locally computable if the CFM trade depends only on the CFM state and the market price. Given the market price in this batch and given the trading function of the CFMM, can you compute where the CFMM is going to be? Okay. And so we had a very strong negative result that no mechanism can in all circumstances guarantee Pareto optimality and preservation of price coherence. Okay? But that's in all circumstances. We do find one circumstance where things are really rosy. Okay? And that is to say, if a CFMM uses a constant product curve, which means the amount of asset X and the amount of asset Y is a constant. That's the most commonly used CFMM trading function. Okay? In that very specific circumstance, okay, trading all the way up to trading all the way up to as much as you can in starting from initial reserves and going all the way up to the opposite point on the CFMM along that function is a unique point where you can get a locally computable rule that guarantees preservation of price coherence and you get Pareto optimality. So the moral of the story here is that while if you have the specific form of a constant function, constant product CFMM, then you can add it to a batch exchange and you can come up with a way of computing prices which take this CFM into account in such a way that you get all the nice properties that you want at the end. You get a locally computable rule, you get preservation of price coherence, and you get Pareto optimality. Okay. Computing this equilibria is generally hard, but once you have locally computable rules, simple algorithms are directly applicable, and we can also use the convex program. Again, this is somewhat technical, but at the high level, okay? At the high level, what we are saying is that if the CFMM uses a constant product rule and you add it to a batch exchange, then not only do you get good economic properties, you can also get good computational properties. You can get you can write everything as a convex program. Again, I'm going to skip the details. And the conclusion is what we have here is an axiomatic framework for integrating CFMs into batch exchanges. Okay? Most of the axioms come from the basic market design literature, but the existence of CFMMs and the trading function gives you additional design space which requires additional axiomatization. Okay? The natural desiderata that you might want, Pareto optimality and price coherence are at odds, but only in general. If you use a constant function, a constant product CFMM, then you can actually make them coexist with each other. And there's a convex program and other computational tools that you can use to do price discovery and price computation and equilibria computation in these markets. So thank you very much. I know that some of the details here might be a little daunting, especially in a short presentation, but hopefully the high level spirit of the work still comes through. Really appreciate the opportunity to present here. And I'm available for Q&A not just now, but also if you want to ever have a follow-on conversation about any of these ideas, please feel free to reach out to any of the hosts at Coinbase and they can put you in touch with me. Thank you.
Hi, Ashish. Thank you for a very interesting talk, kind of combining the batch exchange model with the CFMMs. So we have a few questions here that I'll read out. So the first one is about, so you mentioned, one of the results was about being able to optimize the CFMM design given some belief about future price dynamics. And of course, in crypto, one of the concerns, or one of the things that happens is there's high volatility. So whatever dynamics you're seeing happen might change very quickly sometimes. So in this sort of setting, is that result still very useful? Is there also some additional kind of robustness question one might ask, beyond that result?
So to the extent that you can quantify that volatility in advance, you can find the trading function that's the best for that volatility, whatever your volatility model is. It might not be very good. And so I think implicit in this question is, fine, you can say that I'm going to have a highly volatile market. If I'm going to have a highly volatile market, I'm going to get some curve that gives you the best trade-off for that volatility. But that's not going to make you immune to the volatility. It's just going to be the best trade-off. And the implied critique here is fair. It's not really solving the volatility problem. Now, the two things that I would point out, of course, as this community probably knows much better than me in the audience, you do have approaches which are coming up, which allow liquidity providers to just redesign the curve completely. It doesn't have to have a fixed curve. Now, as it turns out, if you assume something like a Black-Scholes model, then that just factors out. It doesn't really, because that's already somehow taken into account. But for other kinds of volatility, which are not modelable in advance, that's clearly the practical solution. The other thing I would like to mention is that the extreme volatility that you can imagine is to say that you have no prior. You essentially think that every possible price in the future is equally likely. You're that uncertain about the future. In that case, it turns out the optimum trade-off is actually the constant product market.
Fascinating. So yeah, it seems to be kind of a magical function, answers many questions, and just coincidentally also was one of the first to be proposed in the space. So it's, yeah, really interesting. So there's a question here about kind of in the batch execution model, you're going to incur some additional transaction delay because you have to batch together, I guess, all of these orders. And so presumably there'll be some concerns about that in some situations where people want to trade relatively fast. How does one go about addressing that question?
So there's also another question, which is how can you clarify how batch accesses might minimize front running?
Sure.
But take them both together.
Sure.
I mean, that's not a concern that we would address. That's not a bug. That's a feature.
Mm-hmm.
The fact that it makes things harder for high frequency traders is not something that's normally thought of as a deficiency in a market microstructure. And to clarify that a bit more, the next question is how can we clarify why batch exchanges minimize front running? They don't really minimize front running in general. They have this property saying there can be no front running in the same batch. There cannot be any in-batch front running, and that's a consequence of the fact that you clear the whole batch and then you determine a price, and every transaction in that batch, regardless of what limit order you specified, happens at the same price. So the price determines whether the transaction happens or not, given the limit price that was specified. But if it happens at the same price. So then there's no benefit of something like a sandwich attack.
Gotcha. Very interesting. But in that situation, could someone manipulate the price of a batch by putting in an order that's sort of, an outlier of some sort?
Yes, you could have multi-batch strategies, which are going to be quite complex, and we don't guard against those.
Gotcha. The next question is, so you did mention how the constant product CFMM kind of is the one curve which where you don't get the sort of trade-off between Pareto optimality and price coherence. Can you give a little bit about kind of an intuition behind it? It must be pretty mathematical, but is there sort of a little nugget?
So somehow the constant function market maker has if you take a liquidity of the market maker, which tells you, and so this might be like very rough intuition, maybe it not make sense. If you look at the amount of market that you have to change, the amount of orders that you have to put in to move the market by 1%, that amount remains constant because of the nature of the constant function market maker. So in that sense, sort of that simple idea sort of leads to this intuition. So if you want to design a market where you said for changing the price by 1%, I want to have to move 1% of the market. That ends up being the constant function market maker, and that one property, and actually the applied DeFi community was really perceptive. It's rare that sort of you have this design which is so magical. Also had the intuition right. So if you look at the early papers on Uniswap, they do point out there somehow is this constant liquidity, and the same intuition sort of carries over. Beyond that, I think it's just equations.
Fascinating. Yeah, that's really, really interesting. Unfortunately, it looks like we're out of time, but I really appreciate both the talk and the time we took to answer our questions. I think, as you mentioned, folks if they're interested could reach out and we can put them in touch with you.
Thank you very much.
Thanks, Ashish. Bye. And now we are at our last speaker for today, and that is Jasper Zhang. And Jasper is going to be telling us about how to lower barriers to building in this era of open source AI.
Hey everyone, this is Jasper. I'm the CEO and co-founder of Hyperbolic. Today, I'm going to present how to lower barriers to build in the area of open source AI. So before we start, let me give my background. I finished my math PhD at UC Berkeley. I finished in 2 years, which made me the fastest person to finish a PhD in the history of Berkeley. Before that, I did my undergrad at Peking University, graduated with a highest honor, and I won a few gold medals in various math competitions. After that, I worked at Avalanche and Citadel Securities before I founded Hyperbolic Labs. At Hyperbolic, we're building the on-demand AI cloud for developers to democratize AI innovation and accelerate AI evolution. So everyone knows that AI is a very powerful tool, and it will basically shape everything in our lives: finance, transportation, robotics, social media, and even our brains. However, in a closed source environment, you miss out the opportunities to own this technology, let alone participate into contributing to it. And so it's very important to ensure that everyone has access to AI. I will walk through different layers of the AI stack and show you how different researchers, startups, engineers are working on democratized AI. First, let's chat about open source models. So ChatGPT was launched like several years ago, but however, it has like impact a lot of domains. But however, we starting seeing more and more open source models catching up, and it kind of compete and match the performance of closed source AIs. And so, for example, DeepSeek was launched like in early 2025, and its performance is already matched OpenAI O1, which at that time was the best reasoning closed source models. It was really exciting to see these innovation because according to news, ChatGPT or like GPT-4 was trained on more than $100 million compute. But however, DeepSeek was only trained on $6 million compute. And what this shows is by actually having limited resources of computing, DeepSeek or any other open source AI engineers will be able to train state-of-the-art AI models. And that kind of show the trend of how open source AI is gonna to disrupt the world. And here's the graph comparing open and closed source models. At the beginning, you can see the closed source models is actually way better than like open source models. But by the time being, we're starting seeing more and more open source model catching up with the previous best closed source models. And gradually, we started seeing DeepSeek R1 that's matching the performance of the best closed source models. And besides DeepSeek, we also have Qwen 3. They just released the model, and it's the best open source models on live code bench, and it's even it's better than OpenAI O1 in competitive level code generation, and makes it very usable for developers to build their applications. We are also seeing like many other open source model that in different other domains. For example, Angelica's deep coder is more like an Agentic coder model, and then Tencent's Hunyuan is a model that can generate very real 3D like assets. So that's like the open source model. So then next step is once you realize that open source models are going to be the same as the closed source models, then we need other AI infrastructure to support running these open source models. So the first thing come to our mind is AI inference. Basically, it means that you want to run AI models on the GPU infrastructure. People used to think that only closed source models are only like startups that building in-house inference solutions will provide the best performance. But however, we started seeing more and more open source framework like VLM, SGLang, or Llama that catching up or even surpass the performance of other like companies' in-house solutions. And so one example that we just saw yesterday is SGLang. So SGLang now can support DeepSeek V3 R1 with expert parallelism on 96 GPUs. And basically, it reproduced the setup that DeepSeek was run on DeepSeek infrastructure. And it achieves 52.3K input tokens per second. And this is way faster than any closed source, closed source or in-house solutions that built by any companies. And another example is VLM. So VLM now, VLM is a very popular inference framework as well. And like Snowflake, Red Hat, Cohere, and many other companies are adopting VLM for their production and research workloads. Even at Hyperbolic, we're also utilizing both VLM and SGLM. And VLM just recently announced their support for TPU deployment on Google Cloud. And it also integrates with Dynamo, NVIDIA Dynamo, to enable high throughput AI inference workloads. And so we're going to see more and more AI inference solutions that's way faster than any companies that can build in-house. And that kind of drive everyone to contribute to open source, because if you're going to build your own AI inference engine, then it's really hard for you to continue maintaining it. But if you actually contribute to this open source framework, then you reduce the hassle to actually every day you need to hire people to maintain the codes. But instead, you just share the benefits of collaborating with the AI experts across the world. And the same thing for fine-tuning frameworks. So there are like several popular fine-tuning frameworks like Onslaught, Axolotl, Toastream, etc. And we're starting seeing more and more adoption from developers to deploy to fine-tune their models and then deploy using the AI inference frameworks. There are also many open evaluation benchmark. For example, there is like very standardized like MMLU, human eval. There are also like benchmarks for coding performance and also like math ability or STEM ability. There is one like a very popular leaderboard called Java Arena leaderboard. Basically, it's a leaderboard that evaluates the performance of models based on human voting. And we're starting seeing more and more open source models like rank up in the leaderboard. And hopefully soon we're gonna see like the best model to be open source. And all right, so great. So now we know that on the software level, we have AI models that's gonna be open source, and one of will be the state of the art. And we're gonna have AI infrastructure or like frameworks that can allow anyone to serve model in the fastest way, and also train and fine-tune the model in the fastest way, and also have like open evaluation frameworks that allow you to assess the performance of any open source models and closed source models. All right, so what is lacking here? So our theory is every software is reproducible, right? Like if you open source this software, if you open source a model, then everyone across the world can have access to it. But besides software, another very important piece is the hardware, right? The GPU, and GPU basically is the new soil of the AI era. But for hardware, if you own one GPU, it doesn't mean I can also own this GPU, and you can't reproduce the GPU without spending any money. And so there is like a limited amount of GPU across the world, and a lot of them are actually controlled by big companies. So as an AI developer or as an AI company or like anyone that want to access AI, the last barrier for you to do that is to have access to compute. And this is why we're building Hyperbolic, or like this is why we think compute is very important. If you have enough compute, it will be able to run any state-of-art AI models like DeepSeek or like Coin3. But if you don't have that, then you basically need to rely on any closed source or like centralized AI companies. So how can we solve this problem? So actually, there are a lot of computes across the world that are sitting idle or underutilized. For example, there are more than 2 billion computers across the world. And then most of the time, like 90 hours of the day, those computers are sitting idle on average. During Ethereum 1.0 mining proof of work stage, there are like more than 10 million RTX 3090 GPUs running their network. But then after they shifted to proof of stake, the machine is just sitting idle. So let alone we're starting seeing more and more data centers that have like thousands of H100s, but they can't sell or they can't reach to their customers. Basically, you just need to build a decentralized mixed GPU infrastructure network to aggregate global compute. And so that's what we're trying to build. And that's why I think it's very important. We're building this like decentralized orchestration layer powered by our hyperbolic distributed operating system. We call it HyperDOS. And so basically any clusters or any machines, as long as they install our operation system, it just takes like 5 minutes, 10 minutes to install. And then after that, your machines become nodes in our network. And our King cluster or like Sun cluster can orchestrate all the compute across the world and make it very easy for developers to use. And we have different key features like auto scaling, basically because for example, as a user or as a company, sometimes you want to run a model powered by GPU, but at a peak time, you might need 100 GPUs, but at idle time, you just need 10 GPUs. And so what we try to provide is like we have these auto scaling features so that any users or any startups or companies can easily utilize the resources that they need. And then self-healing, which means that in the network that there might be some GPUs might go down at some time, and then we're going to automatically spin up another machines for serving the customer's workload. And we have started building this for more than a year, and it's right now in production, and we're very excited to continue serving different AI companies, researchers for building their AI workload. And the last question for making AI accessible to everyone is open verification, because that when you have this like giant compute network and contributed by everyone and running different AI models, running different AI workload like AI training, AI fine-tuning, etc., you need a way to verify that these machines are actually doing the correct work. So this is basically the goal number 2, which is we want to build trust in decentralized AI and also contribute to the open source AI world. So there are like many existing verification mechanisms. One is consensus. Basically, you just ask multiple nodes across the world and let them to vote on the result or generate the result and then vote on the result. However, this introduces like a lot of overhead. And if you ask 10 nodes across the world to reproduce the result, then basically means it's a 10x overhead. So we're trying to make sure everyone have access to compute instead of like wasting the resources, right? There is another mechanism called OPML, and what it does is it asks a node in the network to generate a result, and then any other machine in the world in the network can verify or check the result on their end, and if it's wrong, then we'll basically we'll dispute the result, and then try to get the reward. So this is like a very scalable, low overhead mechanism. But however, no one in the network have incentive to check every result. So there is some vulnerability in this mechanism. Besides that, the challenge window is pretty long. Usually it's 7 days. So if I ask an AI, say, okay, I want to know today's weather, or like I want to know what I can do today in SF, then basically you need to wait 7 days before you actually know that the result is correct. So this is also not ideal. The last one is ZKML. We know math doesn't lie. So as long as you generate the zero knowledge proof for the result, you are 100% sure that the result is correct. But however, right now we are not that yet. The computational overhead is still like 100 to 1000x, and basically we're also wasting computing resources for generating the proof. So in order to make sure that we have the verification, the best verification for AI, there are some goals here, right? First, you need to handle AI inference requests that in very high frequency, and then you want to reduce the reduce time to wait until you know the result is correct. And yeah, basically these are the ultimate goals. And what we invented is called proof of sampling. And so it's a very lightweight, scalable inference verification mechanism. All right, so how does it work? So let's say a user wants to know what can I do in SF in summer. So the user will send this question to the network, and the network will route it to a GPU node we call asserter to generate the result. So the asserter will generate result and send it back to the network, basically the orchestrator. And then the orchestrator will run a random beacon to decide whether it wants to initiate a challenge mechanism or not. And with some chains, it will randomly pick another GPU node in the network and ask it to resend the results. And so that's called validator. And so the validator will send back the result, and the orchestrator will compare these two results. And if the results are different, then it will initiate an arbitration process. And then after the arbitration process, the dishonest node will punish with a high amount of penalty. And so why does it work? I can start with a real world example. And so in Switzerland, they have a very interesting bus system. So every time when you want to get on the bus, no one check your bus ticket. So you can just go on the bus, but then with some chance, there will be an inspector or an officer get on the bus sometimes and ask you to show the ticket. And if you doesn't have the ticket, they will like charge you for $100. However, the bus ticket only costs like $2 to $3. So as long as the chance of checking is high enough, then you don't have any incentive to cheat or like skip buying the tickets at all. And so the same idea applied to here, right? As an asserter, there might be some chance that no one's gonna challenge me. But if like with some chance, someone is going to reproduce the result and realize that the result is different, then I will be punished with a very high amount of penalty. So as long as you pick the parameter right, basically let this stake and slash be high enough so that no GPU node has incentive to cheat, then this system achieves Nash equivalent, pure strategy Nash equivalent, which means that every GPU node in the network has the best incentive to produce the correct works all the time. This is a joint work with our advisors at UC Berkeley and Columbia, and we're going to implement this in our system, and we hope it can contribute to the open AI pipeline that we have. All right, so yeah, so we kind of show you the whole stack of how to build the open access or open source AI pipeline. Starting from the open source models, we also have a lot of open source AI infrastructure and frameworks. And at Hyperbolic, we're building the open access compute network with verification. And our goal is that we want to democratize AI innovation and accelerate AI evolution. So if you are interested in building in public, you want to contribute to AI that can be accessible by everyone, feel free to reach out to me. I'm happy to answer any question you have, and hope we can build together.
Thanks, Jasper. That was an excellent talk. Really found it very interesting. One of the things that your proof of sampling reminded me of is a very early technique, maybe from 2017 or so, that was called TrueBit. Does this ring any bells for you? It was sort of a cryptoeconomic scheme for compute verification.
Yes, I heard about it.
Do you kind of see any connections to it and proof of sampling?
Yeah, I would say when we're doing this research, we kind of survey the industry existing research. And I would say the innovation of proof of sampling is, instead of we act as the validator, we ask another node in the network to validate the result, right? So in our design, we have an asserter that generates the result, but then with a certain chance, we initiate a challenge mechanism. But unlike traditional sampling mechanism, ourselves, we don't check the result. We ask another node to check the result. But then if the results are different, then we'll initiate an arbitration process. And so this requires a more dedicated balance about how to incentivize the asserter not to cheat, and also incentivize the challenger or validator not to skip the challenge as well. And so if you check our paper, we kind of calculate the different odds and like different utility function and try to make sure that everyone's incentive is positive if they choose not to cheat at all.
Nice. So we have some questions here. So the first one is, what's the optimal compute budget for training state-of-the-art open source models today?
Yeah, that's a very, very good question. And that's why I think Hyperbolic can help a lot. So originally, people think only big big AI companies like OpenAI can train foundational models, like that's the state of the art. For example, ChatGPT, GPT-4 was rumored to be trained on $100 million compute power, right? And then early this year, DeepSeek showed that you only need 2.788 million GPU hours of H800 to train. And then in their calculation, they say like they estimate the leasing cost of H800 is $2. So they roughly need $6 million to train this model. However, if DeepSeek V3 was trained on Hyperbolic, it would cost way less. So currently on our marketplace, we provide H100 at a cost of 99 cents. And H100 is a better model compared to H800. So if DeepSeek was trained on Hyperbolic, it would only cost less than $3 million. And with both lowering the cost of compute plus getting better advanced training technology, we're going to see a foundational, state-of-the-art open source model to be trained within less than $1 million. And that's kind of unlocked the barriers of having like all these open source models just being trained in a research lab or like in the startups that only raise a few millions of dollars.
So game theoretically, the higher the stake is, intuitively, the less incentive they would have to cheat. But is there also some kind of trade-off with speed, for example? In
yeah, totally. So in our proof of sample design, we really care about the latency and speed because at inference, you don't really want to wait before you know the result is correct. And so in our design, we kind of make the challenge protocol be async with the first step, the asserting the generation protocol, right? So when you generate the result and you send it back to the user can already assume that the result is correct because by having the later stage challenge protocol, we can make sure that the asserter doesn't have any incentive to cheat. But if the user want to wait and see whether the result is being challenged and validated, then it will take another, like the same amount of time because the generation time will just be the same. And so I think the balancing the odds and stake is more about like the try to see how often we want to cost another node to regenerate the result. That's basically more about introducing the computational overhead, but it doesn't introduce any latency to the generation speed.
I see. Great. The next question is, why should idle GPU owners choose Hyperbolic over, say, just AWS Spot Market or Vast.ai and others?
Yeah, I mean, that's a very good question. Everyone knows that there are like many different players in the platform, in the industry, but I think Hyperbolic is the best option that everyone should pick. First of all, AWS Spot only is only built on top of AWS infrastructure, so they don't allow any third-party idle GPU owners to join. Bus AI is another solution, but compared to them and many other competitors, we have a very fast onboarding time. So powered by Hyperbolic Distributed Operating System, any machine owner can become a node within 5 minutes, right? So our script is very easy to install and run, and we have very good support to help you to onboard. And then besides that, we have very high utilization rate. Our platform provide more than just compute. We have inference. We have later on we're gonna have training and fine-tuning services, and any AI workload can be done on our platform. So by introducing this different workload, we're gonna increase the utilization rate by much higher scale. And as a owner, what you care is like, how can I actually get my GPU utilized at a higher rate? So that's what we can, and we'll to push that to 100%.
Another question we have is, how will Hyperbolic mitigate, and actually maybe will it mitigate the energy footprint of a global GPU mesh?
Yeah, so as what I mentioned in the beginning, like we think the gap that like the problem the customers or like researchers, developers are facing is that they need more GPU access. But in order to solve that problem, it's not about trying to build more data centers, because there are actually already a lot of idle compute already. They just can't find the users who run it. So that's why we think about building this GPU marketplace or like GPU network that can aggregate global compute to serve any users that need GPU. So unlike traditional AI infrastructure that relies on building massive new data centers, Hyperbolic actually trying to repurpose existing compute, right? Whether it's idle GPUs in homes, universities, or like enterprise racks, or like just sitting idle in data centers, they can be reused by our users. So this is a way more sustainable approach for energy saving, etc. And it will avoid like spending a lot of energy, spending of land, spending of resources, rebuilding all this stuff and just let them waste. We just want to reuse them. And that makes us fundamentally more sustainable by design. So if you really care about environment, if you care about how sustainability of the world, then I think you should pick Hyperbolic.
Great. On that note, I think we'll wrap up. Thank you so much, Jasper, both for the presentation and for sticking around for these questions. And I really wish you all the best.
Thank you so much.
Great. Well, it's time. We've ended a whole day of talks and panels, and I'm going to hand over to Rajarshi Gupta to kind of give us our concluding remarks and wrap up the day for us.
Well, good afternoon, everyone, and it's great to see the audience at the end of the day. We had this really wonderful day of talks and panels. I mean, if you're just going back a little bit, we started this conference 3 years ago because we felt that at the time we felt that there was no real forum for people working at the intersection of blockchain and machine learning to come together and share their ideas. And then it's been thrilling to see the expansion of the field in these interim years. And as Professor Bhaskar showed at the beginning, that graph of the amount of work going on in this intersection space has just been increasing a lot and very, 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 very much. It's also very exciting to see a number of startups working in this space, pushing the boundaries, and which therefore makes it interesting for bigger players like the AWS and GCP to play hard in this space and work on it. So, just wrapping, kind of putting a lid on what happened all day today, this was a very, very enjoyable day. Really enjoyed the talks. We began with this great keynote fireside chat by Tim Draper. And, he's been there from the early days of AI and the early days of crypto, and had some very fascinating insights to share. We followed that with a number of most I would say, deep and detailed talks about the various areas of crypto and AI. We had talks from both academia and industry. I mean, that's one of the things I love about this field, that a lot of the exciting work is going on at the academia or at industry or at the intersection. I mean, we had several people who straddle the difference between academia and industry, being a professor and a startup founder, and so on. I also particularly enjoyed the two panels, and in the past few years, we've had some really exciting topics and exchange of ideas in the panels, looking at how the panelists shared their notes with each other, talked about the various topics, and I hope all of you enjoyed it. In conclusion, just like to say that we've loved putting this together. We always cherish and enjoy the action of interacting with people, identifying folks working at this intersection. So a couple of call outs to the people on the audience. So first of all, all the talks and the recordings are going to be available on the website. So if you want to refer back to it or share them, please go ahead and do so. And secondly, please do reach out. I mean, you all know who the speakers are and their contacts and stuff. So if you have follow-ups, one of the advantages of a forum like this is that it connects a lot of people. I mean, I've been on the chat thread also seeing several people talking about having related work or related research work to interact. That's absolutely right. And final call out is that if you or if any of you or you have other collaborators or colleagues who you think are going to be would love to work with us and maybe present or be a panelist in the future years, please do not hesitate to reach out. So with that, it is my pleasure to close out the third Machine Learning and Blockchain Research Summit. It's been a pleasure having all of you. Hope you all enjoyed it, and we'll see you next year.